Okay, start business statistics. Unit number 5, total syllabus will be off. Yes, please do hit the like button to motivate, then only we can bring more. Yes, guys. Measures of central tendency is the topic number 1. Later, measures of dispersion, measures of skewness, and correlation and regression. After that, probability, that is approaches where 3 type of probability distributions also there: binomial, Poisson, and normal distribution. Research, the concepts and type and research design. Data collection and classification of the data. And sampling, the types and estimation methods of the sampling. Probability, non-probability method, sampling distribution, central limit theorem, standard errors, statistical estimation, various things are there. And hypothesis testing and parametric, non-parametric type of tests are there. So when each of the parametric test will be used and what is the conceptual understanding behind it. And report writing is the final one. These are the total syllabus coverage is going to be there in this course, and as per the NTA also this is the syllabus which is given. Now let us start without late with statistics. So guys, statistics, what do you mean by statistics? What do you mean by statistics? Meaning of the statistics. The practice and science of collecting and analyzing a numerical data in a large quantity. Simply, statistics is nothing but a quantitative variables, generally numerical data will be there. How we are going to analyze those numerical data? By various calculation methods, whether to establish a relation, correlation will be used, whether to establish the dependency, we will be using a regression, and if we wanted to know that based on the data the probability of the outcome, then we will be going for a probability distributions and the probability methods, as well as to pick up the sample out of the whole population. Various sampling methods will be there, and various theories are there to calculate the exact outcome of our research also. And how hypothesis testing is there, which is a parametric, non-parametric test. Everything is dealing with a numerical data in a larger number of quantities, like a tabular presentations, pie chart, histograms, various things will be used. From those numerical data only we will be arriving at a conclusions will be drawn, or we will be drawing inferences from the whole numerical data which is there in the large quantities. That is a simple definition of the statistics. And if you look at the properties of the statistics, it is about the totality, not about the individual elements. It is about the totality, means aggregate of the facts. Aggregate of the facts means total of the facts which are numerical in number form, it will be there usually. Even qualitative also we can use in majority, like height and weight, there also statistics can be used. But statistics main scope of area is that numbering or the numerical form. So it will be expressed in a numerical, and which is affected by the different factors will be there. It is not just the one, various factors will be impacting on our statistical conclusions also, because numbers will be drawn by taking various bases. And from the various collected data, the estimated data or prepared data or the assumptions that you have taken, the calculations or the outcomes will be there. So properties of statistics number 3 is that collected and estimated. It is based on the collection of the data as well as it is based on the estimation of the data. Right? So systematic collection will be there, like a primary type of primary data collection methods. Secondary data collection methods. A proper sequential procedures will be adopted to collect the data for the statistical analysis purpose. Because if you are not using a systematic collection methods, you may not know how you are collecting a data, then you will not arrive at a proper conclusion, because data is not in the sequential form. It is total of a raw data will be there, which is not as useful information that we can infer or we can get it from the entire collection of the data. And predetermined purpose. It's a predetermined purpose. What is this predetermined purpose? You are doing the statistical calculation with expectation of something. Suppose I just wanted to identify the risk associated with the securities. By using a statistic, this is my research topic with the securities of the X company, I just wanted to analyze. So if I'm adopting to a standard deviation technique of the risk analysis, standard deviation technique will be adopted. So when I'm calculating that, my purpose is very clear or not, which is predetermined purpose. The purpose is to calculate the risk associated with the securities by using a tool called as a standard deviation tool in the statistics. So clear cut a predetermined purpose will be there to use the statistics. These are the simple 5 properties why we are using a statistics in decision making. Is that clear? Hello Commerce, Prachi, Jain and Felicita. Now in the statistics there are 2 types of data. There are 2 types of data. The data are, we can say data can be a number form, data can be a qualitative facts form, data can be arrived in the form of records, and all these by using this data we will be converting that into an information, because when raw data converted into an information, the information we can use it for the analysis to make a conclusions, right? So based on that only the results will be drawn, as well as the measurements or any observation of the variables also. Everything can be done once you convert the raw data into an information. There are 2 types of data. There are 2 types of data. Quantitative data, qualitative data. In case of quantitative data, the test we are going to use in the statistics is that parametric test will be used for the hypothesis testing. So parametric hypothesis testing will be used in case of a quantitative. What is parametric? What is non-parametric? What are the types of parametric? What are the non-parametric types of methods and techniques? Everything will be discussed in the hypothesis chapter. This is not the right time to discuss that one. But as of now, we can understand quantitative is nothing but a numerical data where assumptions can be taken up based on the data. And qualitative, which is unflexible data, which is non-parametric, that is like a chi-square and Crucial-Wallis test, lexicon test, those things will be used over here. Right? And our discussion is of quantitative data. Quantitative data can be of a continuous as well as discrete. Quantitative is an continuous data or else a discrete data. This continuous data again divided into an interval as well as ratio scales of measurement of data. There are 4 scales of measuring the data. There are 4 scales of measuring a data. That is interval scale, ratio scale, nominal scale, ordinal scale. Out of the 4 measurement of scales, we have 2 types of quantitative data, that is continuous as well as discrete. So continuous data is of interval and ratio levels of measurement, and qualitative data is of nominal and ordinal. Qualitative is of nominal and ordinal. Is that clear up to now? Now what is nominal, what is ordinal, what is interval, what is ratio, we are going to discuss. Yes, NIOR or else NOIR. 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 Nominal, ordinal, interval or ratio. IR is a continuous data which is a quantitative, and NO is a qualitative which is a non-parametric methods will be involved. I hope I am clear. Now let's look into the what is continuous, what is discrete. What actually it means to say. Why the continuous and discrete data is there. Continuous and discrete data is of continuous information is an information that fall in a continuous series. I will tell you the example. Like a class intervals will be there. Now class intervals 0 to 10, 10 to 20, or 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. When a range is clearly mentioned, that is what a continuation of a data, because the data is getting continued like this with a separate class intervals which a length of the class is clearly mentioned in the data. That's what we can say continuous series, which can be measurable. Every value within the range is included in the data. Here historical, like history can be like histogram can be used to represent the data. Histogram is a presentation of a one type of presentation of a continuous data. And here group distribution will be used. What is the meaning of group distribution? Wherever frequencies are there, like continuous data tabulation, frequencies performed against the value group. In case of discrete data, here, in case of discrete data, space between the values of is a discrete data which can be countable. Here it can be measurable. Continuous data is in measurable form and discrete data is in countable form. Discrete data is in countable form. And there are distinct or different values in discrete data. Distinct or different values can be there, like a 0, 1, 2, 3, 4, 5, 6, 7, 8. That one. And here bar graph can be used like this. Bar graph can be used like this. Bar graph. And group distribution in case of continuous. What is the meaning of the group distribution? Group distribution meaning and ungrouped distribution. Grouped and ungrouped, within 5 minutes I will be going into that discussion with a clear-cut example I will be showing you. But as of now, wherever the frequencies are present, that is grouped. Ungrouped is nothing but discrete is performed against the single value. Whenever single class intervals are present, that is a grouped. Whenever class intervals are not present, that is not a grouped. Ungrouped frequency distribution. Discrete data is of whole numbers, correct. The points are associated with the unbroken line because we are not breaking the line 5 to 15, 15 to 16 to 30, 31 to 45 and 46 to like that. Here it is not breaking anything. It is sequentially following the continuously the data is getting followed. Whereas here discrete data is unconnected one. Like ducks in a pond. Total how many ponds, how many ducks will be there in the pond, like a 10, 12 or 1, 2, 3, 4, 5, 6 like this. We can count it, which is in a single form, single line format will be there. It is not getting continued. It can be a random numbers also. It is ungrouped, right? Next, you can look at levels of measurement. With a single chart, I am going to complete the total 4 variables. NOIR, right? We know very well. Nominal, ordinal, interval, ratio. What is nominal? What is nominal? Guys, do hit the like button and do not forget to share it with your friends. Please try to share it in your social media contact now, like WhatsApp status, Instagram, as well as in your Facebook also, just to boost up. So guys, what do you mean by the these levels of measurement? So there are 4 levels are there to measure the data. First 2 are qualitative, last 2 are the quantitative, that is continuous data, that too. When you assign the name or when you classify the data, suppose I have collected a data of entire 10,000 population, I have collected a data. In this 10,000 members, I can classify based on the male and female. One nominal classification means I am giving a name, this category as a male, this category as a female. Second is that I can categorize as a literate, illiterate. I can give one classification as an illiterate and one classification as illiterate. I can give you one person like who completed PG, who didn't complete it before the PG, UG, like UG and Inter, like that. And I would say again above the 30 years and below the 30 years of age group. Based on the age group I am classifying, right? A classification and assigning a name for that particular classification. That is what we call it as a nominal. Like a male and female, color wise, hair color wise, brown hair color, black hair color, and red, like that, various colors. Type of living accommodation, like a hotel, hostel, apartment, various things will be there. And religious preference, we are all called as an Hindus, and some other religious, Muslim is also, some other Christian, some other various Buddhism, Jainism, various things are there. So those are the classification, and for the classification we are assigning a name. These are the examples. That is what a data classification with respect to nominal. Second is that ordinal. What is this ordinal? Named plus ordering will be given. You name it, you classify it, also assign the sequential order, which is to come on the first, which is to come on the next, which is on the last. Like assign the sequential ranking also. So ranking is a main one over here. First one is a classification, second one is a ranking. Like a high school class ranking. First class, second class, third class, fourth class, fifth class, seventh, eighth, and ninth. Like that, many classes will be there. And in one class, student number 1, student number 2, student number 3, performance wise, rank number 1, 2, 3 wise. 100 percentile, 99 percentile, 98 percentile, 97 percentile. As ranking in a systematic way will be given over here. It can be a socio-economic. Rich people will come on the top and middle people will come on the middle. Poor people will come below the poverty line. And Likert scale will be there. Strongly agree, strongly agree, and moderate or the neutral, and disagree, strongly disagree. This is also a ranking type, right? And yes, maybe or no. Yes isn't standing on number 1, and maybe is in middle, and in the below it will be there. That comes under here. Okay, guys. Once again, I will be pausing the live for 3 minutes because for here I received. It is not stuck. I am going to pause the video. Okay, just hold on. Clear, guys? So here interval scale of measurement. Interval is nothing but interval classification will be done, as well as ranking the sequential order also will be done. Moreover, here clear cut difference between the data will be standard, constant difference will be there. A proportionate interval between the variables will be there. That is of Celsius temperature, like 1, 2, 3. Thermometer will be there, na? Thermometer will be there. In the thermometer, clear cut. On the tape also, if you see the tape will be there, na, which is for the measurement purpose will be using. If you see the tape also, clear cut, 1 to 2, 2 to 3. How much distance between the proportionate difference between the 1 to 2, 2 to 3 also same. A constant difference will be maintained over here. Constant difference will be maintained over here. Like a time on the clock also. Time on the clock, how it look like? This is the clock. 1 to 2 is the same 1 hour. 2 to 3 is the same 1 hour. 3 to 4 is same 1 hour. 4 to 5 is same 1 hour. Like that, constant difference will be there. Here there is no absolute zero. Clear cut difference will be there. So classification, ordering, and the difference also will be there. Extra. Next, ratio scale is that. What is a ratio scale? What is a ratio scale? Ratio scale is that naming, ordering, as well as naming, ordering, and a proportionate clear cut difference will be there, and absolute zero also that you can find in the ratio scale. Here we can find the example of the ratio scale as an income of a person. Income of a person. If he is getting a salary, income will be there. If he is not getting a salary, zero also will be there. So one can either earn 0 in the month, and in other months he can earn more also. That depends upon the work he is doing, or whether he is doing a work or not also, it will be deciding. So that comes under the ratio scale. So if you can observe nominal, ordinal, interval, ratio, I hope I am clear with this 4 levels of measurement. Done? Guys, I hope everybody hit the like button. Acha, my favorite also came, huh? Now if you look at nominal scale, here labeling and classification, what is the measures of central tendency will be used? Measures of central tendency is that mode will be used in this nominal data scale. mode will be used. And ordinal scale, mode as well as median will be used, but best measure is that median. Best measure as that a median only will be used in ranking. And after that, interval, labeling, classification, and a meaningful difference, add and subtract, not absolute zero. Here a mean, median, mode, three measures of central tendency can be used over here. And in the ratio scale, here the ratio scale, mean, median, mode, three will be used. Interval and ratio, three things will be used, but in the nominal mode, ordinal, best is that median will be used. Just remember that any question can be possible. Now let's go ahead with our branches of statistics. There are two branches of statistics, as we know, that is descriptive statistics as well as inferential statistics. Descriptive statistics deals with collecting a data, summarizing, describing data as it is without any changes, just a presentation purpose. We can say descriptive can be used. It is describing a data however it is, just collection of a data, summarizing a data, presentation of a data, and describing the data in the way it is. 3 minutes हो गया, क्या हो गया? 3 minutes हो गया. I think you are not in live, bhai. Where are you? Are you sleeping? Inferential statistics. Second one is that inferential statistics. What is this inferential? By using the descriptive statistic, that collection of a data, summarizing, describing, then you are going to draw a separate conclusions. Drawing conclusions, making decisions, and which is based on the sample or the population that is involved in the study. So now these are the two types of a statistics. I am entering into the main part. The basics I given. Now entering into the main part. Is it okay? Main part. How will you get the idea to make innovative slides? You people are the motivation. As you are motivating, I am trying my best to present in a better manner. You people gave me an award in an academy also. So I just wanted to keep my name without decreasing the quality. Rather than increasing, I just wanted to maintain and not to go below than that. So now measures of central tendency. Measures of central tendency provides, it is actually central tendency. Two words are there. Central tendency. Two words are there. Central means a middle most expected value. Tendency means a nature or the behavior. How that middle value is behaving. That's what the entire discussion of the measures of central tendency. Right? Measures of central tendency provides a very convenient way of describing the set of scores with a single number that describes a performance of the particular group. So the performance will get to know by middle value. How the middle value is going to behave, that is what we call it as a central tendency, measurement of central tendency. Now positional averages, mathematical averages. Thank you, Nandini. Rahul, for what? What is your question? Which I didn't tell. There are two types of averages. 2020 question, by please be very careful. 2020 question it is positional averages. What is this positional average? Positional average means it will tell you where the middle value is located, like where the position of the number in the data. That is what a median, mode, partition values. I'll tell you what is that. Each of the discussion will be done today only. And mathematical average is of three types. Arithmetic mean, geometric mean, harmonic mean. These are mathematically we are going to calculate the three types of mean. Three types of means are comes under the mathematical averages. Positional averages are median, mode and partition values. Award is not recent one, by. Now if you ask me the examples related to descriptive and inferential statistics will be, just look over here, entire syllabus is covered under the descriptive and inferential only. Here position, which is quartile and percentile rank, like a partition values are there now, that comes under the descriptive, showing as it is. We are not going to make any type of conclusion. Data is there, we have summarized, we have classified data, we have presented, and we have given a a name for that, like a quartile rank, and identified the middle value, like a median or a mode or a partition value you have done. So central tendency, median, mean, mode is also a descriptive, showing as it is without any conclusions. And frequency, it can be a count of frequency, and it can be of a percentage also. And variation, like a dispersion, variation is nothing but a dispersion, that is standard deviation, range, variance, all these are comes under the dispersion. Skewness also will be there. Skewness also part of how the peakedness of the data, that also comes under over here. And inferential statistics is a conclusion part, where I told you the conclusion where we can make it. How do I prove the theory which I made it? What is the data behavior? What is the conclusion of this data? That's of a hypothesis testing, why various parametric, non-parametric tests will be used. And estimations in the hypothesis testing, like a sampling, by using a sample, we'll be making a various estimation. Like a parameter will be there, population parameters, confidence intervals, significance levels, and I would say like type 1, type 2 error. All those are for the conclusion part, where inference is going to drawn based on the data that we collected, classified and analyzed. The conclusion can be drawn in the inferential statistics. You said some surprise is waiting now. That surprise is no. Surprise is not the award. Award I have received last year itself. My first year of the academy only I have received, within 6 months or 3 months, within 4 months, I think, if I'm not wrong. 6 months, I would say. But this is something big, not award. I'll tell you. Now, arithmetic mean. I'm starting with arithmetic mean. Guys, pakka, damn sure, 100%, 1000% question will come here, because properties of arithmetic mean is more important. What is arithmetic mean? It is a simplest form, and everywhere it is used as a measure of a mean or the average. Simple average is called as an arithmetic mean. Just a simple average will be there now. That is what we usually call it as an arithmetic mean. So what is arithmetic mean formula? Very well known. I am not spending much time over here. The mean is equal to sum of the values divided by number of the values. Sum of the values divided by number of the values. For example, numbers are given as in 10, 10, 20, 40, 70 is given. From this, how to identify the mean? 10 plus 10 plus 20 plus 40 plus 70. How much? 40 plus 40, 70 plus 40, 110, and 130, 140, 150. So 150 divided by how many numbers are there? 1, 2, 3, 4, 5. 5 numbers are there. So 5 threes are. Then 30 will be the average. 30 will be the average. Thank you, Rahul. Now, there are 7 properties. Damn sure question will be attacked over here only. Look at the 7 properties with a clear-cut example I am going to tell you with a tabular presentation. Just observe the example. You no need to remember any property. Observe the example. That's it. Observe the example. Property number 1 of the arithmetic mean is that sum of the deviation of the item from the arithmetic mean is always 0. Sum of the deviation of arithmetic mean means from the numbers, if you deduct the arithmetic mean, the total whatever you are going to get is 0. How? Look at over here. These are the numbers 5, 6, 7, 9, 3. Variables are given. What is the mean of this variable? 5 plus 6 plus 7 plus 9 plus 3. Total add put together 30 will come. 30 divided by number of variables are 5. 5 number of variables are there. That is 30 divided by 5 is equal to 6 will come. 6 is the mean. So from this x we need to deduct the mean. 5 minus 6 minus 1. 6 minus 6 0. And 7 minus 6 1. 9 minus 6 3. And 3 minus 6 minus 3. So if you sum up everything, minus 1 plus 0 plus 1 plus 3 minus 3. total it will become 0. Understood the property number 1? Sum of the deviations of the arithmetic mean is always 0. Sum of the deviation of the items from the arithmetic mean is always 0. Property number 1 satisfied. Property number 2. If the number of items and mean are known, then the total of the items can be obtained by multiplying the mean by the number of items. Look at, if the number of items and the mean are known, total of the items can be obtained by multiplying the mean by the number of items. If you read like this, you will not understand. Look at the example so that it will be clear for you. If we know the number of workers in a factory as 100, suppose say 100 members are there. Average of their monthly wages is 400 rupees. We can easily obtain the average or not. We can obtain the total monthly total wages or not. 400 is the average. Multiply 100 number of people, which is a 40,000. So now read the property again. Total number of items, 100 workers, are known. Then total number of item can be, the total of items can be obtained by multiplying with a mean. What is a mean or the average? 400 is the average salary or the average wage. 400 into 100 will give you 40,000 total. That's it. Next up, property number 3. What is the property number 3? Property number 3 is equal the sum of the squared deviations. Look at squared deviation. Property 1 whole square. Can I say like that? Property 1 whole square. Whatever the property number 1 is there, simply you are going to do the whole square. Square deviations of item from the arithmetic mean is always minimum, which is less than of sum of the square deviation of the item from any other value. Now let us go into the example. Here the third property example is square deviation. Suppose 5, 6, 7, 9, 3. Same example. What is the mean that we arrive? 6 is a mean we know very well. X is equal 6. So x minus x bar also we have arrived. Minus 1, 0, 1, 3, minus 3 we have got it. And we need to square of this standard deviation. We need to square of this square deviation. That square deviation, if we do the square, 1 square is minus 1 square is equal to 1. 0 square is equal to 0. 1 square is equal to 1. 3 square is equal to 9. Minus 3 square is also 9. So total put together is how much? 1 plus 0 plus 1 plus 9 plus 9. 18, 19, 20. Total 20 is there. This is x is equal to 6 when arithmetic mean. Suppose. Now change the things to understand the property. Let us assume the number below the mean. Suppose square deviations are taken. We are going to deduct, it is not from the mean. We are going to deduct from any other value below the mean. That is 5 minus 5, 6 minus 5 and 1. That is 7 minus 5, 2, 9 minus 5, 4 and 3 minus 5 minus 2. Then if we do the square of that one, 25. So if you do with any other, if you do the square deviation with any other value other than the mean is always lower. Square deviation from the mean is always lower. If you do with a 7, if you do with a 8, that will be always higher. Even if you do with a 2 also, that will be always higher than the sum of square deviations of the mean. So below than this, none of the square deviation will come. Means below 20, no deviation or no square deviation will come. Are you getting the point? Square deviation from the mean is always minimum. Clear? Guys, you didn't hit the like button. Please do hit the like button. Now the property number 5. Property number 5. Sum of the positive deviations are equal to the sum of the negative deviation in the absolute terms. You can just see 20, 40, 60, 80, 100 are given. Total 300. So 300 divided by how much? 1, 2, 3, 4, 5. 300 divided by 5 is equal to 60 will come. So 60 is the mean value. So from that we are just arriving. You can look at 20 minus 60 minus 40. 40 minus 60 minus 20. 60 minus 60 0. 80 minus 60 plus 20, and 100 minus 60 is equal to 40. 20, 20 plus 20 minus 20 cancel, plus 40 minus 40 cancel, finally 0. What is that 0? Sum of the positive deviation, negative deviation, plus or minus cancel, plus or minus cancel, remaining will be 0. That is absolute term. Okay. Property 4. Yes, we'll go for 4. Now the property number 4 is very simple. If we add most important property is that 4 and 7 only. 4 and 7 only. Look at, if we add or if we delete an observation which is equal to the mean, if we add or if we delete an observation which is equal to the mean, then the arithmetic mean remains unaffected. Means whether you are adding or deleting the which is equal to a mean value, it is not going to impact it, because same value you have added or you have deleted. So what is the big change is going to be there? From the total it will decrease, from the number of observation also it will come down. So let us assume arithmetic mean of the 10 observations are 15. Total 10 observation, for that arithmetic mean is 15. Now 11th observation you have added, then the observation still 15, then the arithmetic mean is still 15 only. Why? 11th observation became 11 and total also increased by 11 now. 11 increase and below 1 is increase. Same value will come. That is 10 into 15. 10 into 15 divided by 15 plus 11. 10 into 15 divided by, wait. 10 into 15 is the first value, plus another 15 will be added and divided by 11, so that it will be giving you the same arithmetic mean as a 15 only. Just simply look at, if you add or delete the value which is equivalent to arithmetic mean, then the arithmetic mean is not going to change, because number of observation is increased is equal to the total also sum will be increased. 135 divided by 11 which is equal to 15 if I am not wrong. Property number 5 is equal to property number 2. No, by property number 2 is a multiplication, total into number of observation. But here the sum of deviation, just a plus and minus nullification we are trying to tell. 165 or 135, whatever it may be, I am not calculating anything. It will give you the same mean. That is what I wanted to say. If you add or if you less, which is equal to the mean. Suppose you deduct the 15, 9 numbers will come. 10 into 15 minus 15 divided by 9 numbers only. In that case also 15 will come again. Now sixth property is that, if we have an arithmetic mean and number of the 2 or more related groups, actually not just one group is there, multiple groups are there. In such a case, 2 arithmetic means has to be possible. For every group, arithmetic mean separately you need to calculate. If they want us to ask a combined mean for all group together, all the different groups together, what is the combined mean? We need to calculate the mean for each group and multiply with the number of observation and divided by the total number of observation. That's it. Right? Calculate the mean for each group, that is x bar 1, x bar 2, x bar 3 will come. Then combined mean, how to calculate? We need to combine all these means. Mean into number of observations of one group, second group, third group, divided by all the group number 1, group number 2, group number 3, total observation has to come. Combined mean calculation. Next is 7th property, most important, 4th and 7th only. Please try to understand. This is given in the 2020 exam, 2019, every exam you can see these 2 properties only, majority cases. Arithmetic mean is depending upon the change of origin, that is plus and minus, and change of scale also, which is multiplication and the division. Change of origin is indicating addition and subtraction. Change of scale is indicating multiplication and the division. If series increased, decreased, multiplied, divided by certain value, then mean also will be changed by the same value. Here if you add or delete by same value of the which is equivalent to the arithmetic mean, then it will be same. There is no change, no effect will be there. But here the seventh property is that if you do other than the arithmetic mean, if you do any value, multiplication, division, addition, subtraction, then our arithmetic mean also increased by the same. Arithmetic mean also increased by the same, depending upon the origin as well as the scale. So let us take the example. For example, previous illustration over here, we have calculated a data that arithmetic mean is equal to 6. 5, 6, 7, 9, 3 are the variables. Now let us try to do, I am adding by 2. I am adding 2. 5 plus 2, 7. 6 plus 2, 8. And 7 plus 9. 7 plus 2, 9. 9 plus 2, 11. 3 plus 2, 5. Then we have got 40 as a new total. So 40 divided by 5, how much it is? 40 divided by 5. 5 8s are right? 8. So new arithmetic mean is what? 8. What is the old arithmetic mean? 6. How much I added? I added by the 2. My arithmetic mean also increased by 2. So do I need to calculate this much? If I know the property, if the question is saying that it is increased by the 2 means you can say that arithmetic mean also increases by 2. So for this x plus 2, what I am doing? I am multiplying by 3. Now you see the effect. Let us multiply. Now the present arithmetic mean is 8 for this situation. I am multiplying by 3. 7 into 3, 21. 8 into 3, 24. 9 into 3, 27. 11 into 3, 33. 5 into 5, 5 into 2, 5 into 3, 15. Total 120. 120 divided by, I hope it is visible, right? 120 divided by 5 number of observation. How much? 5 2s are 10 and 5 4s are 24 will come. So now 24, what is the present mean which I have taken? 8. What I have done? Multiplied by 3. 8 into 3, how much? 24. New arithmetic mean that we got it or not? So whatever that you do, whether you do subtract, whether you do the division, whether you do the multiplication, addition, everything, arithmetic mean also having a same effect. All the 7 properties, I hope everybody is clear. If you understood well now, one question is in your pocket. That's my assurance. Till now, whatever the discussion went so far, now levels of measurement are pakka damn sure one question will come by 100%. Now let us move into the grouped and ungrouped data. Arithmetic mean. Yes, chalo, let us move forward. Arithmetic mean grouped and ungrouped data. What is this grouped and ungrouped data? There are 2 methods for calculating the arithmetic mean, that is grouped and ungrouped. And for the grouped also we are having 2 methods, direct method as well as step deviation method. Even 3 methods are there for the grouped data, 3 methods, for the ungrouped data 3 methods are there. Direct method, indirect or shortcut method, and step deviation method. In the step deviation, the length of the class interval is the only difference. I will tell you what it is. Even though it is not mentioned in the slide, think it as direct method, indirect or shortcut method, as well as we can say this one. What should I say? Step deviation method. And ungrouped data is also same, direct method, indirect or step deviation method. So what is group? Can you see the table very clearly? I think grouped data that have been organized into groups into a frequency distribution, 2 to 4, 5 to 7, 8 to 10, and 11 to 13, and 14 to 16, 17 to 19. Can you see the difference? What is the difference over here? Difference is how much? I think 2 is the length of the class interval. Is it correct? 2 is the length of this class interval. 2 is the length of this class interval. So very clear, constant length of the class interval will be there. Wherever we are going to multiply with a class interval, that will be called as a step deviation method usually. I will be telling you the difference also. Look at ungrouped data is nothing but which is having only a frequency, just single numbers 8, 4, 6, 7, 2, 5 and 3, 2, 1 like that, single numbers continue, which is a discrete data. So data that has not been organized into a group, which is ungrouped, also called as a raw data it is. So this is a continuous data, this is an discrete data. In the continuous, grouped will be used, in the discrete data ungrouped will be used. Now you can just see total summary of all the formulas of 4 methods. Nature of the data, ungrouped data, grouped data. Excuse me. So direct method. In case of direct ungrouped data, arithmetic mean of the x is equal to x bar is equal to summation of x, means general however we calculated so far in the same way, summation of x divided by n, that's it, nothing more nothing less. And in case of a grouped data, what is a direct method? Multiplication with a frequency, like a number of workers, number of students in the class, like that, as a number will be given for each of the class interval, that multiplied with a frequency. So summation of the frequency into that number, the variables, divided by number of the summation of the frequency. Summation of the frequency multiplied by the variables divided by summation of the frequency, means total of the frequency. Here this is about a direct method. Direct, x is an indicating a variables, n is indicating number of values of x, f is indicating frequency, a is indicating assumed mean, d is indicating deviation, the difference, that is x minus a from the values, the assumed mean, the deviation. And here c is indicating, u or c is indicating, u is equal step deviation, c indicates the length of the class, or the h indicates the length, h indicates the length of the class, h indicates the length of the class, as well as c indicating a common divisor. I will tell you what it is by, once you see the examples you will understand very clearly. So indirect or shortcut method, in case of ungrouped individual series, arithmetic mean of the x is equal to x bar, that is x bar is equal to assumed mean a plus summation of the deviation divided by n. How it looks like, you know, like this. Summation, suppose 0 to 50, 50 to 100, a class interval is given, and for f is also given, which is number of workers in this class interval, like that, 90, 150, 100, 80, 70, 100. So summation of the frequencies are total 500 are the summation of frequencies. Okay. Now the mid value, how to identify the mid value? Just a class interval, lower class interval plus upper class interval divided by 2. 0 plus 50 divided by 2, 25. And 50 plus 100, 75. 100 plus 150, 125. Middle value of the each of the class interval that we need to calculate. So those are the observations. Now observation. F multiplied by the x, usually in case of the direct method. But in this indirect method or the step deviation method, we need to identify the deviation that is taken from the assumed mean. Deviation that is taken from the assumed mean. Here you can assume any of the mid value as an assumed mean. Any of the mid value. No need to like take only this 75, only this 125. I have taken 125. So x minus 125 divided by the class interval, that is c. Sorry, n number of observation. So that is x minus 125, which is 25 minus 125. First one I am calculating by 50. How much? 25 minus 100 divided by 50, which is equal to minus 2. And 75 minus 125, which is 50 divided by 50 is equal to minus 1. 125 minus 125 divided by 50, 0 by 50, 0. And 175 minus 125 divided by 50, 1. And 225 minus 125 divided by 100 divided by 50, 2. 275 minus 125, 75 divided by 50, which is equal to 3. Right? So 125 is a middle value or the mean that you can say, or the assumed mean also we can say. A is an assumed mean. If you want to calculate the exact mean, you can calculate. But actually our intention is to calculate the arithmetic mean. Now that is why we are assuming that as a mean and identifying a deviation over here. So the deviation that we have got is that -2, -1 and 0, 1, 2, 3. Deviation multiplied by the f into dx. So 90 into -2, 150 into -1, 100 into 0 and 80 into 175, 80 into 1 and 70 into 2 and 10 into 3. So summation of the f dx is how much? -80 is coming over here. -80. So first what is the formula? A plus assumed mean is 125 plus summation of the frequency into deviation divided by number of observation. What is the total number of frequencies? That is 500 and deviation is that 80. By formula till here, if it is there now, formula till here, sum a plus summation fi di divided by n, that much is an indirect method. The moment when you multiply the whole with a length of the class, that is h, which is a 50 is the constant length of the class, then it will become step deviation method. So that's what I am trying to convey here. Indirect or shortcut method grouped data is given as an summation d divided by n. In case of ungrouped data, summation d divided by n. In case of grouped data, summation fd divided by summation f. Now look at the method of step deviation. Here we are just adding c, here we are just adding h. In case of ungrouped data, the c is getting added, which is an common divisor, and in case of a grouped data, the class interval length we are getting multiplied, not added, sorry, it is getting multiplied. Total that we have calculated in the indirect method multiplied by the c in case of ungrouped, multiplied by the h in case of grouped data. Understood the methods? This is not much important, but still I don't want to miss any point. One trick is to remember this grouped data, ungrouped is that grouped data multiplied and divided by the frequencies. Blindly remember, frequency will come mandatorily in case of the grouped. If frequency is not coming, that is ungrouped data. If frequency is not coming, that is ungrouped data, simply we can say. So direct method, if you can see for the grouped data, number of children and number of families, this is observation into frequency. So multiplied by both and get the total number divided by the number of observations. 519 divided by number of observations are, number of frequencies are total 240. And after that we have like ungrouped data. Ungrouped data direct, however we calculated summation x divided by n. We know very well how to calculate. Indirect or shortcut method in case of ungrouped data, calculate the x. From that arithmetic mean we need to deduct. Arithmetic mean like x minus a means assumed mean. So deviation we have identified. Deviation is equal to 60. 60 deviation plus sum of the deviation is 60 divided by number of observation are 10. Total number of observation are 10. Like that you will get the total. Many teachers didn't cover what you are covering in the free session. Thank you so much, Rahul. Now can I go into the geometric mean? Arithmetic mean is fully completed by. Now the geometric mean. So more 10 minutes I will take, not 10 minutes, 5 minutes. Let's complete the geometric mean and arithmetic mean, so that I will give you the homework of the certain questions where you need to do. I will upload the only question part in the Telegram. You do that and come to the tomorrow same session. Chalo, let us go for the geometric mean. In the same way, however, we went for the mathematical average number 1, arithmetic mean completed. Mathematical average number 2. Geometric mean is defined as an nth root of the product of n items are the values. Nth root of the product of n items are the values. This is, we are just trying to identify the growth on the investment or the like the profit ratio or the profit percentage that on the investment. So for this and the volume of the sales area, for those purpose we will be using this geometric mean. The PYQ of the question is that from the geometric mean, which is there in the red color. appropriate average which is used in computation of the average rate of a growth in population is geometric mean. What is the tool or the mathematical average used for calculating the growth? Answer please. What is the mathematical average will be used for calculating the growth? Geometric mean will be used. This is an nth root of the number of items. N items are the n values. Now what are the properties of the geometric mean? Interesting properties. Whether geometric mean, when it is there in the under root, is it possible to become negative? Never ever. It never be 0, it never be negative, because this is nth root. When it is inside the root, it never be negative, it never be 0. And if all the observations are the same, if every observation is same, like a 2, 2, 2, 2, 2, 2 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, like that only total observations are have a same value, then geometric mean also same value. Geometric mean also same value. Suppose 2, 2, 2, 2, 2, 2 is there, like 10 observations of 2 is there, then geometric mean of that observations are 2 only. Right? 3, 3, 3, 3, 3, 3 and 10, 10, 10, 10, 10 is there. Geometric mean also 10. That is the second property. Third property, product of the values of series will remain unchanged when the value of a geometric mean is substituted for each observation. Like geometric mean of a series is that 1, 3 and 9. 3 observations are there. 1, 3, 9 is there. This 3 observation geometric mean is calculated as an 3. Okay. That is how to calculate the 3. Simply under root of 1 into 3 into 9. How to calculate this one? Total 27. 27. What is the root for 27? Can I say 3? 3 is the root. So geometric mean is 3. Now if the geometric mean is 3, if we substitute other items in the series with a 3, then the series will be 3, 3, 3. How? Suppose here 3 is there. Instead of the 1, I am substituting with a 3. Instead of the 3, we are keeping same. Instead of the 9, I am keeping 3. Now actually, whether we write this 139 or 333, both are giving a same 27 only. Correct? Huh? Both are giving a 27 only, which is 3 3s are 9, 9 3s are 27. 27 is that same 3 will be the geometric mean. So geometric mean is going to unchanged if we substitute the observation with the geometric mean. It is not going to change. And it is capable of algebraic treatment by. Algebraic treatments in the mathematics, as it is a mathematical average, for forming algebraic treatment, we can use this geometric mean. This is not much important, just a mathematical point of view it is important, but for ours, there is no essence over here. Now, final property is that the geometric mean of the product of two variables is the product of their geometric mean. Geometric mean of the two variables, most important property is this only. Geometric mean of the product of two variables is the product of their geometric mean. Product of their geometric mean. That is, if z is equal to x into y, normally, then geometric mean of the z is equal geometric mean of x into geometric mean of y. Both will give you same. If geometric mean of the two variables is product of their geometric mean, simply to z is equal to x into y means their geometric mean also will give you the geometric mean of the z. Got it? The difference. Normal z is equal normal x into normal y. Then geometric mean of the z is equal geometric mean of the x into geometric mean of the y. That is what they mean to say. That's it. Now the harmonic mean. What is harmonic mean? It's an reciprocal to the arithmetic mean. Ulta. Dividing the arithmetic mean simply. Harmonic mean is the reciprocal of the arithmetic mean and calculated by taking a reciprocal of the each observation. Each individual observation reciprocal we are going to take it up. Each of the individual observation is going to be reversed. That is, number of observation till now it is in the below. in the denominator. Now it is in the numerator. Now it is in the numerator. N divided by 1 divided by n whole divided by 1 of x1 plus 1 of x2, 1 of x3, like this, 1 of xn, means total reciprocal of all observation will be coming in the denominator. On the numerator, total number of observations will come. Simply 1 divided by arithmetic mean. Excellent. Perfect understanding. Simply 1 divided by arithmetic mean is nothing but a harmonic mean. 1 divided by arithmetic mean is nothing but a harmonic mean. So harmonic mean has the least value when compared to a geometric and arithmetic mean. Harmonic will be the least one. So that is why the relationship, how it will come? Harmonic mean less than geometric mean less than arithmetic mean. This is what the relation, or else AM more than GM more than HM. HM will be least, AM will be highest. Geometric mean will be the middle one. And yes, session recording will be available, no issue in it. Harmonic mean is rigidly defined. Harmonic mean is rigidly defined. It is constant in nature, it won't be changing. And it is based on all the observation. It is based upon all the observation. So because only not just on the 1 or 2 observation we can able to calculate this harmonic mean. It is based on the total all the observations. Right? The fluctuations of the observation do not affect the harmonic mean. That is why rigidity is there in the harmonic. Just because of the fluctuation in the harmonic mean, just because the fluctuation in the observation, harmonic mean is not going to change. It's going to be constant or rigid. And more weight will be assigned to the small numbers. Suppose 1 by 3 and 1 by 15 is same. Can you please tell? 1 by 3 and 1 by 15 is same. One by 3 is having highest weight, highest weight 33%. 1 by 15 is how much? Not even 12% if I am not wrong. So highest weightage assigned for the normal small number, and less weightage will be assigned for the highest biggest number. Larger number, larger items, small weightage, and small numbers, larger weightage. Right? Are you getting the point? Now median and this one I will look into later, but I will tell you the difference between the AM and GM. Here AM, GM, AM is more than the by. This slide is an total PYQ slide. Slide total, whether it is symmetrical, anything that you can take it as important slide, which is PYQ. 2 to 3 PYQs are there from here only. Relationship of the arithmetic mean, geometric mean, harmonic is equal to all are equal if all values are same. All three means are equal if all the values of observations are same. Otherwise, the relationship will be arithmetic mean more than the geometric mean more than the harmonic mean. In general this one. If special situation, if all the values are same, then AM is equal, GM is equal to HM. Next, if A and B are positive numbers, arithmetic mean is equal to A plus B divided by 2. Geometric mean is equal to under root of AB. Harmonic mean is equal to 2AB divided by A plus B. How you got this 2AB divided by A plus B? Simply 2 observation divided by 1 by A plus 1 by B. So how you'll get 1 by B plus A divided by AB. So this AB will go up. In such a case, 2AB divided by A plus B will be coming. Right? 2AB divided by A plus B will be coming. 2AB is equal to geometric mean square divided by arithmetic mean square. So harmonic mean we can say geometric mean whole square is equal divided by arithmetic mean is equal to harmonic mean. Harmonic mean is equal to geometric mean whole square divided by arithmetic mean. Suppose if G is the geometric mean and H is the harmonic mean, now the relationship between this you can identify in such a way. Geometric mean is equal to under root of arithmetic into harmonic mean. Simply AM into HM is equal to GM square, or else GM is equal to under root of the AM into HM. Arithmetic mean into HM. Right? In either way you can write it. In either way you can write it. What do you mean by median? Name itself is indicating it is a middle value. Name itself. Actually, central tendency itself is a middle value, central value, which is a median. Actually, the median other name is that central tendency only. So median is the one, like suppose an apple is there. If we are doing like this in the middle, like means this is half part, this is half part. So that exactly a midpoint will be there where that pluck will be there. Now that is called as a median point, where we will be dividing into two parts, like 50% and 50%. Proportionately we will be distributing. So here you can just see properties of median is more important. There are 5 properties. Out of that, one last property is there. The last property is a questioning area. Damn sure if they wanted to ask a question, first questioning area is from the median is that property number 5 only. I will explain with an example. Remaining 4 properties are easy to understand and we can recognize easily. So you can just see median can be determined only if only arranged in order. Like ascending order we need to arrange. Correct na? We need to arrange the values or the observation in a ascending order. Then only we can be able to find out the median. And it is not based on the all values. It is not been much affected by the extreme like end values. Last value, first value is not much impacting. First and last values are not much impacting. Middle value is the one which is going to decide our median. So it is not going to be based on all the values. It is going to be based on only the middle values, or only some values will be affected over here. But number of observations or a number of values, number of items will be impacting on the median. And if it is affected by the positions of item, like a first position, second position, third, fourth, fifth, like that, the positions might be impacted, not the values, because position is the one which is deciding which is there in the middle. If I say there are 7 members in a row, means to whom I am arranging in such a way, like the position of that person. Rahul is on number 1, Shamal is on number 2, Abhishek is on number 3, Shilu is on 4th, Raud is on 5th, and Preeti is on 6th. Like that means my position of that person is important, person is not important. Position of that person is important. Who are there in the middle if I arrange in an age of the ascending order? Their ages ascending order if I can arrange. The middle person position is important, not the person. Right? N by 2 plus 1 we can say. Next here, n plus 1 by 2, not n by 2 plus 1. Here median can be determined by ogive. Ogive curve will be there, less than ogive, more than ogive. I will be discussing that in the data presentation. Now I am not going to discuss any of the frequency polygon or ogive curve or the histogram, bar graph, all those things at a stretch I will be discussing in a separate session. Okay. Next. Now here an important property is that sum of the absolute deviations, that is deviations by ignoring the signs, we will not consider any signs, from the median is minimum. Like yesterday, sum of the deviation from the mean is minimum is there now. In the same way here, these are the observation 5, 7, 8, 9, 21. Right? That is the observation. Now the x minus median. What is the median of this value? Median is that how can we calculate the median? N plus 1 divided by 2. So 5 total how many numbers are there? 1, 2, 3, 4, 5. 5 numbers are there. 5 plus 1 means 6 divided by 2, 3. Third number will be that is third number is an median for us. So 5 minus 8 and 7 minus 8, 8 minus 8, 9 minus 8, 21 minus 8, 13. Like that we have arrived at a x minus, means we have deducted values from the median. So value minus median we have done. Now the value that we got by doing is that 18 we have got. 18 we have got. Now here from the median, this property is entail the use of a median as a various practical situations also. Look at sum of the absolute deviation. Sum of the absolute deviation is nothing but deviation from the mean. Sum is that 18. 18, that is x minus d is the minimum when you compare with other values. Suppose x minus other value 7, which is below the median. If you do the sum, 19 you are getting. And above the median that you deduct by 10, which is above the 8 is above the 9 is that 10 we have taken above the 8, which is above the median. So sum of the deviation which is above the median is also, as compared to the median sum of the deviation, it is higher only. But only when it is median, it is lower, 18, 19, 22. Even if you do with a 1 also, it will be higher as compared to the sum of the deviation from the median. Is it clear? Sum of the deviation from the median is minimum always, even if you compare less than the median value or more than the median value. Signs has to be ignored carefully, because we should not consider the signs. We should not consider the signs. If we consider the sign, then answer will be changing. Chalo. Next. Formula for median. Formula for median. So odd series, if you look at if the series is an odd series, then n plus 1 divided by 2 observation is a median. N plus 1 divided by 2. If it is a even series, n plus 2, n divided by 2 plus n by 2 plus 1 whole divided by 2 again. This is the even series. Even series is a very rare question, but odd series they can ask. But step number 1 is we need to arrange the raw data in an ascending or the descending order, ascending or descending order, and then apply the formula to find the median according to the nature of the series of. Shamal, please don't confuse with any of the thing. Please don't confuse. Whatever the properties that we discussed yesterday for the mean, that is for that only, and this is for this only. Don't confuse at all by comparing. First arrange the data in ascending and descending order, then apply the formula to find out, that is n plus 1 by 2, which is equal to odd series, and n by 2 plus 1 whole divided by 2, which is for the even series. That's it. Now mode. Hello Kushbu. Guys, do hit the like button if you like the session. Mode. What do you mean by mode? What do you mean by mode? Mode of a set of values which is occurring in a whole observation, list of observation repetitively. Most frequently it is repeating. So that occurs most frequently, or a most commonly observed value is called as an mode. Most commonly observed value is called as an mode. Generally here, hello Mega Kandelwal, it can be used as a data when it is qualitative as well as quantitative. The mode can be used. When it is qualitative and quantitative, it can be used. And it may not be unique. It may not be unique value, because if it is unique, now only single will be there. As it is most frequently, that is what is common value, not the unique value. So here Z is the one. Z is the one representation of a mode. Z is the representation of the mode. And it is not affected by extreme values, like a beginning and end point is not going to impact on the mode, because mode is nothing but the most repetitive values are called as a mode. So whether it is in the beginning, whether it is ending, that there is no point in it. There is no like essence of the extreme values. And we can say the extreme values may not be there also sometime. And the mode is easier to compute, because by looking at the observation we can able to identify. There are two types of modes, or three types of modes we can say. Unimodal means only single mode will be there in the list of observation, right? And ill-defined mode is nothing but multi-mode, which is more than one mode is possible. More than one mode is possible, like it can be a 1, it can be a 2, it can be a 3, it can be a 4, it can be a 5, it can be a 6 also. So ill-defined mode or else multi-mode is nothing but that only. Bimodal mode also we can say, bimodal mode. Whereas trimodal mode is nothing but 3. If 3 exactly modes are coming, that is trimodal mode. That trimodal is a part of the multimodal also, but generally it is recognized as separate. Right? And here mode is equal to 3 median minus 2 mean. Very famous relationship that we know very well. We know very well. Mode is equal to 3 median minus 2 mean. Mode is equal to 3 median minus 2 mean. And for the median calculation or for the representation in a graphical format, what will be used in the median? Ogive curve will be used in the median to represent in a graphical format. To represent in a graphical format in the mode, what will be used? Histogram or the frequency polygon will be used to locate the mode graphically. To locate the mode graphically, histogram and frequency polygon are the two graphical representation mechanisms can be used to locate the mode in a graphical way. Right? Now, what is the exact empirical relationship between the three? Mean, median, mode. We know very well this is a repeated PYQ of the 2020 also, 2020, 19 and 2018. Every year this question is coming in one another way, either in the statement form or a direct question form. So here the relationship that we can find out is that mode is equal to 3 median minus 2 mean. 3 median minus 2 mean. Or else, if you can do somehow simplification, then you might get it. Mean minus mode. Mean minus mode is equal to 3 into mean minus median. 3 into mean minus median. You can get this after solving this equation. You can get this also. And the more possibilities of a simplification also you can do. Because if you remember this standard one, you can verify the option. Whether all the options are suitable over here or not. You can just able to verify if you can simplify that one. Right? So that's all about the empirical relationship. Bye. I hope everybody got it. Now about the partition values. Partition values. I hope I am assuming that I am not going speed. If I am going speed, please put a pause on me. Thank you, Preeti. Right, done. So partition values is also positional average. Before going to the partition values, I just wanted to test your memory. Please tell me the mathematical average separately. Please tell me the positional averages. What are mathematical averages? What are positional averages? Because just wanted to, whether you are on the track or not, just wanted to check. It's today 12 p.m., 3 p.m., 5:30, 7 p.m. 4 marathons are going to be there. AM, GM, HM mathematical. Median, mode, percentile are comes under the partition values are comes under the positional average. Why I ask this question? Because this is a PYQ. This is a PYQ, very recent examination. So let's start with the first percentile. Percentile. What do you mean by percentile? Percent means 1 of the 100 or a value upon the 100, a value that is divided into total observation divided into 100 equal parts. That is what a percentile. You can see on the graph also 1 to 99 parts are there, almost inclusive of the 1, inclusive of a 99. Total 100 parts is the division of this graph. 100 parts are there in the division of this graph. Right? So here percentile is nothing but the value of a variate which decides or divides a given series into 100 equal part. Each percentile contains 1% of the total number of observation. 1 is 1% of the 100, 2 is 1% of the 100, 3 is 1% of the 100. Like that, every value is having a 1% upon the 100 total equal parts. And this is denoted by the P usually. Suppose if you look at P10 is written. P10 means percentile 10. Percentile 10 is indicating the value variation up to a 10% out of the total 100. 10% out of the total 100, because here 10 parts are there. P10 means 10 parts. 10 parts indicating 10%, because each part is 1%. Right? So this is, we can say, D1. D1 means decile number 1. Decile number 1. I will discuss what is that decile. Then you will understand easily. Now the P20. P20 means value of the variation exactly 20%, means 1% is total 20% of the 100 equal parts. So 20 equal parts and 20%. P25 means 25%, 25% of the total values. That is denoted as an Q1. Q1 means quartile deviation, or sorry, quartile number 1. I will tell you what is that quartile also, so that you can understand easily. And P30 means P30. The value variation up to exactly 50%, means 50 equal parts. This is usually called as an D5 or else Q2, which is also called as a median also. P30, which is exactly 50% of the total number. Is it P30 or P50? This is P50 by, sorry, P50. P50 either Q2 or else a D5 will come. I will tell you what is the D5, what is that Q2 also. This is usually we call it as an, in case of percentile it is median, because 50% is the middle value of the 100 or not. 50 is the middle value of the 100. It will divide first half, second half. That is why P50 is a median of the percentile. Right? Next, deciles. What do you mean by decile? Data, dividing the data into 10 equal parts. Dividing the data into 10 equal parts. Dividing the data into 10 equal parts. Those data is nothing but, you can see, D1, D2, D3, D4, D5, D6, D7, D8, D9. 10 equal parts, but in between 9 gaps will be there. 9 gaps will be there. Even though 100 equal parts, but 99 gaps only. Even though 10 equal parts, only 9 gaps. Even though 4 equal parts, but only 3 gaps. Gaps are the one which are speaking about, like gaps are the percentile. Gaps are the decile. Gaps are the quartiles. Right? 10 equal parts, but 9 gaps only will come, because small and largest values will be there. So the values which will divide the data into 10 equal parts, 10% is indicating, 10% of the total observation is indicating that now there should be a 9 values which is denoted in between that. So 10% means a 10 total 10 equal parts of the entire 100. So D1, D2, D3, D4, D5 like that up to D9. Each of the decile is indicating percentage 10%. So here what is the median? D5 will be the median. Here 9 parts, here 4 parts, here 4 parts, total 9. Middle one will be D5. D5 will be the median in case of deciles. Right? Now, quartiles. Alright, typo error was there. This is 4 equal parts, quartiles. That will rectify in the final PDF. Do not worry about a smaller typo errors. Rectified in the PDF which I am going to give it to you. So quartile. Quartile divides the entire data equal to 4 parts. 4 parts. In between the 4 parts, how many gaps are going to be there? Only 3 gaps. 1 gap will be less as compared to the total parts. So smallest and largest value in between Q1, Q2, Q3. What will be the median over here? Q2 will be the median over here. So generally, this first part is indicating 25% of the data. And this last part is indicating 25% of the data. And the middle one is indicating this is 25, this is 25. Total how much percentile it is indicating? It is percentage of 50% is indicating. Right? 50%. First 25%, last 25%. Middle one is that between the 26 to 75% middle value is a 50%, which is Q2 is equal to 50%. The value of a variate that divides a series or a distribution into 4 equal parts, that is known as a quartile. So the in between the 4 equal part there will be a 3 quartiles will be there, which is Q1, Q2, Q3. Q2 is called as a median. Q2 is called as a median, which is equal to 50%, and 21st to 25 is called as an Q1. Second, third quartile is an above 75, which is the last to 25. Q3 shows 75 exactly. Q3 shows 75 because if you put together 25 plus 25 plus 25, Q3 is 75. Absolutely, I am going to come to that point. I am just trying to make you understand the structure of the quartile. Later I will tell you what it is. Here first quartile is nothing but below which are 25% of observation. And above this Q1, there are remaining 75 will be there. Okay. And second quartile is indicating 50%. The value of the which divides distribution into two equal parts, which is 50% and 50%. Like that it will be divided. So when it is divided, 50% will be coming in the middle. That is what a Q2 position. So Q2 is indicating 50%. Q2 is the median also. And what is the third quartile? First 25%, second 25%, third 25. So 325 put together, 75% of the value is indicating Q3. Below the 75 and above that only 25 will be there. So upon this only above that 25% will be there, but below 75% will be there. Right? And this is from the whole observation we can say Q1 is less, which is only 25%, Q2 which is only 50%, Q3 which is 75%. So Q1 is less than the Q2, less than the Q3. Is that clear? That's it. Final relation is that only. I hope I'm clear. Partition values also. Hello Bajanti. Now let's go ahead towards the final summary which we are discussing from yesterday. Median, odd, even series, median n by 2 plus 1, n plus 1 by 2, and median n by 2 plus n plus 1, n by 2 plus 1 whole divided by 2. This is when it is used to find the salary of the workers, or whenever we wanted to identify the median value, that will be used. And mode is the most frequent value. It is used for when best selling item in a shop. In that case, voting will be there. Or best candidate out of the all MLA candidates. First one is that mode only, whoever is got highest. And arithmetic mean. Arithmetic mean is nothing but sum of the values divided by number of values. Generally, mode is more of qualitative in nature rather than quantitative. Qualitative data will be there because many number of people aiming or favorite towards something means that is what a most frequently or most required one. And arithmetic means sum of the values divided by number of the values. Report card, monthly temperature of the city, those are average. On an average, we can calculate. Geometric mean wherever the growth, the sales growth, value of the sales, population is getting increased or not, how many death rate is there, like that growth rate and how it is increased rate will be there. Now for that it will be used. Next, harmonic mean, it's an 1 by arithmetic mean. 1 by arithmetic mean is simply called as an harmonic mean. So that is speed, production, cost. In those cases, for the calculation of the speed, calculation of the production, calculation of the cost, harmonic can be used. Now entire relationship that yesterday I have discussed the relationship between the AM and GM and HM. When all the values are same, AM equal to GM equal to HM. When the values are not same or any other case which is not identical situation, AM more than GM more than HM. Arithmetic mean is always higher. Yes, reciprocal of the AM is called as an harmonic mean. Next, geometric mean, the relationship also been given. Geometric mean is equal to under root of the arithmetic into harmonic mean, or else geometric mean whole square is equal to arithmetic into harmonic mean. Either way you can write it. Now main focal point of the discussion is this one, questioning area. Try to understand the graph very clearly. I am going to make the mean median mode relationship with a partition value called as an quartile. With a quartile, you can understand better of this table and the graph also. You can just look into it. Symmetrical, asymmetrical, we know very well. Symmetrical is nothing but wherever exactly mean, median, mode, all three are equal. That's a symmetrical distribution, right? Where the mean, median, mode are equal, that's called as an symmetrical. If there is a situation those are not equal, then that is called as an asymmetrical. If there is a situation all these three are equal, symmetrical. If there is a situation that they are not equal, then that is asymmetrical. Asymmetrical can be of a two types: positively skewed, negatively skewed. Right? Positively skewed, negatively skewed. If it is asymmetrical, right? Positively skewed is indicating this is what a positively skewed. By this positive or negative skewed, we will be deciding based on the quartile. Okay, quartile is a base for this division. Look at very clearly the graph which is there over here. I think I need to zoom it out. Visible? So here quartile, first positively skewed. In case of positively skewed, actually out of the quartile which is higher, Q1 is higher or Q2 is higher or Q3 is higher? Q2 is the median, which is in the middle or not? Which is in the middle in the both the case. Q2 is a median which is there in the middle, right? Which is there in the middle. I think not visible, by for me it is not. No. Hello, let it be. So Q2 which is 50% of the quartile, that is in the middle. Now median, mean is on the right side. If you look at over here, in the positively skewed, mean is higher. This is what? Q3 or the Q1 in case of positively skewed. In case of positively skewed, what is that? In case of positively skewed, what is that one? Q1 or Q3? What you have to say? Which is higher, you tell me, just simply which is higher, that one will be the, in the quartile which is higher, Q3 is higher or Q1 is higher? In the quartile which is higher, Q3 or Q1? Q3 will be higher. Q3 will be higher. So you can just see by over here, Q3 is higher now, 75%. So the domination which is rightly tail now, it is skewed towards the right. Tail is sloping towards the right. You can just see. This is higher, mean is higher. This is indicating a 75%. So this is 50% and this is plus values. Means above the 50%. And this below the one, this is the middle value is the one, median. So above the one is an plus and below the one is a negative. So mean is an higher value which is indicating 75%, which is Q3, and this mode is an Q1 in this case, and this is a Q2. So in a positively skewed case, mean more than median, more than the mode. Understood? Mean is higher in the positive. Let's exactly mirror image is that negatively skewed. Mirror image is that negatively skewed. What is that? Here same Q2 is a median and mean is that Q1, because less than it is mean is less than the as compared to the median and mode also. Mode is the highest over here because this is ulta to the positive, negative will be ulta. This is left towards more of negative value. These are negative values, that is why negatively skewed one. This is 1, this is negative, this is positive. So positive towards a positive, Q3 is there, which is a mode over here. Here mode will become Q3, here Q1 will become mean. So in such a case, mean less than median, less than mode, or else mode more than median, more than mean. Understood the relation very clearly? If you understood the graphical representation, no need to mug up that more or less. Just understand that one. Q1 is less because left side it is negatively, it is going tail towards the left side, and positive is the tail towards the right side. That is why. Now, first chapter number 1, measures of central tendency, 100% without any leaving of the questioning area I've completed. Let's test your knowledge with the questions. Fatafat you need to answer in the chat box, because we should not spend much time on the question, because we need to enter into chapter number 2 today. Hello. Question number 1. The most appropriate average to be used to compute the average rate of a growth in the population is that. Growth. I have told you very clearly. It's an geometric mean. We have discussed already in the session only. You can look into the yesterday's session. First part number 1. In the case of a classification of a data, the class having upper limit is treated as a lower limit of the next class. I think this question didn't discuss. Let's move to the next. Which of the following is not one of the measures of central tendency? Mode, median, mean, range. So range is not a part of central tendency. These three are positional averages. But range is an dispersion. Measures of dispersion, that is not of a central tendency. Which measure of central tendency is derived from the most common value? Most common value. Option D, mode it is. Most common value, most occurred value is mode. Which measure of central tendency is obtained by using a middle score when all the scores are organized in a numerical order? It is median, because ascending or descending order arrangement has to be the step number 1 when the observation values are given and asking us to calculate the median. We need to arrange either in the ascending order or descending order first. From low to high to low, we need to arrange, then only we have to calculate the median. Otherwise, we are not allowed to calculate. Which measure of central tendency is obtained by calculating the sum of the values and dividing this figure by the number of values that there are in the data set? Hello Haripriya, good morning. Which measure of a central tendency is obtained by calculating the sum of values and dividing this figure by the number of values there are in data set? That is, mean is a correct answer, option number B. Mean, that is formula, direct formula of a mean. In case of symmetrical distribution for a continuous data, which of the following are true? That is continuous or discrete data. If it is symmetrical, what will be the one? Option number A is the correct answer, because in case of symmetrical, mean equal to mode equal to median. And what is the best measure of central tendency with respect to ordinal type of variable? Mode, median, mean, none of the above. Best measure with respect to ordinal type. Ordinal means a classification. In case of a classification, what is the best measure? Only just a classification. They are not asking a sorry, it is not a classification, it is ordinal. Means a ranking also. Classification as well as ranking. What is the best measure What is the best measure? Yesterday I discussed and I highlighted in the bracket also with a red color. With a red color I highlighted. What is the best measure of central tendency when the ordinal type means a classification as well as ranking? Median is a median and mode both are mean and median both will come, but median is the best measure in case of ordinal. You can just see in case of nominal mode, in case of ordinal median is the best measure, in case of interval not skewed mean is the best measure, in case of interval or ratio which is skewed median is the best ratio. Please remember this slide also. I will try to add this slide. Anyway, some things we need to learn it from the PYQ or the MCQs only. So that is this part. Actually, I have told this part there also, but still I will add this slide there. Next. Which one of the following is known as the average of position? Guys, do hit the like button if you haven't hit the like button. Please do share it with your friends, guys. And you are getting for a good work if you are getting a less number of views now. And kachra videos are getting lakhs of views. Just because of the motivation that we are not even deserved to get 1,000 views for this type of quality videos. That's ironic. I can't do anything, but I can only make a request to share it with your friends. So your average of the position is an B, which is median is the one. Average of the position means out of the one, average will be middle value. Mean is independent of change in origin and scale. Standard deviation is independent of change in scale, but dependent on change of origin. So option D is the correct answer. Both are incorrect statements. Both the statements are incorrect. You can look at this slide is most important by. Please look at the slide very carefully. Mean dependent on the origin as well as scale. Median also, mode also means these three things are dependent on the origin as well as the scale. They have given mean is independent. Wrong. Right? Next. Range, mean deviation, standard deviation. These are dispersion. Absolute as well as relative dispersion. Look at those are independent of origin but dependent of a scale. We'll discuss about that also. And here correlation coefficient, independent of origin and independent of the scale. Right? Regression coefficient, independent of the origin, dependent of the scale. Independent of the origin, dependent of the scale. So you can just look at the statement. Standard deviation is independent of change in scale but dependent of change in origin. It is independent of origin, dependent of the scale. That is standard deviation. Independent of the origin, dependent of the scale. Ulta they have given, that is why wrong. And mean is a dependent of change in origin and scale, which is a wrong statement. Got it? The difference. Both are wrong, that is why. This please look at if you want take a screenshot of this one by. I'm pretty sure from here if any type of a statement also they can mention over here, right? The mean is a measure of dispersion. The mean is based on every observation and is a representative of the whole population. Mean is a measure of a dispersion. It is based on every observation and is representative of whole population. So option B is the given answer, that is only statement 1 is false. Why, if the statement 1 is false and statement 2 is true, na? Answer can be 1 and A, B and D. ये क्या किया मैंने? What I have done? The mean is a measure. Mean is a measure of dispersion. Actually, it is a measure of central tendency. This is false, and it is based on every observation is represented over the whole population. First one is false, second one is true. Okay, okay. So both B and D are true only. Let's go for the next question. I'll change it. I'll change the question. Any measure indicating a center of the set of data arranged in an increasing or decreasing order of the magnitude is a measure of. Option C, central tendency. That is central tendency is the one. Next, which of the following is not the characteristics of a mean? It is affected by extreme scores. It minimizes the sum of square deviations. The sum of the deviation about the mean is 0. It is used with ordinal data only, not at characteristics of a mean. Mean will not be used in case of ordinal data. Mean will be used in case of a ratio or interval. But mode will be used in case of median will be used in case of ordinal data, not the mean. Right, remaining three are, it is affected by the extreme scores and some minimizes some of the square deviation which are property, and some of the square deviation about the mean is 0, which is another property. Next, considering the probability distribution, if mode is greater than the median, then the distribution is classified as a mode more. Median won't be affected by extreme values. It is about middle value only. It won't even consider all the observations. Position is important rather than the number of observation. So it is, when mode is greater means, is it rightly skewed or left skewed? Mode is greater by, oh bhaiya, mode is greater. What you are saying abruptly? When mode is greater, just now we have discussed now, if mode is greater than the distribution, it is an left skewed, not right. Look at left skewed. Mode is greater than the mean and median. Mode more than median, more than mean. It is left skewed, not right. Mean will consider everything. All values are extreme values affected. Manner in which geometric mean, harmonic mean, arithmetic mean are related. There is no condition attached over here. Then normal condition, what will be the situation? Hello Nakul Tiwari, कैसे हो भाई? So option A is a correct answer. If all the values are identical or the same, then D. If they mentioned all the values are same, then you can go for the option D. Unless otherwise they mention, general situation is that AM more than GM more than HM. If a constant value is added for every observation of the data, then arithmetic mean also obtained by. I'm good. I'm good. So adding the constant is the correct answer. Adding the constant. Because same thing we need to add. If it is increased by something or added by something means we need to get the new arithmetic mean we need to add by something. The same thing. Taking relevant root of the product of all non-zero and positive values. No negative, no zero. No negative, no zero. What is that? It's geometric mean. Geometric meaning is the correct answer. Geometric mean. The mean of 10 observation is 10 and all the observation are increased by 10 percentage. The mean is increased observation will be. Option D is the correct answer. It will be 11. But how to calculate this? Present value of the present mean is the 10. So 10% of a 10 means equal to 1 na. So new mean will be, it is getting added by 1 which is equal to 11. Which is equal to 11. That's it. Or else 10 observations 100. So 10 observation is 10. 10 observations are 10 means 10 into 10 100. Total value is equal to 100. So now it is increased by 10 means 10 percentage means 110 it will be. 110 divided by 10 observations only. So which is equal to 11. In that way also you can say. Distribution in which values of median, mean, mode are not equal is considered as. Thank you, Rahul. Yes, simply mean is also increased by 10 percentage, Abhishek. Correct. All are not equal. Simply the situation, all are not equal. That is treated as an asymmetrical distribution. Arithmetic mean all purpose average. Median, median, mode are positional averages. Class is half class done. Now half class left over. Half class, mean, median, total discussion. Chapter number 1 completed already. You are late. You came at the questions time. You didn't came at 5:30. Now you are late to the 8 a.m. also. Hello, okay, 5:30. Those who are not going to get, they are not, those are not going to attend 5:30 a.m. session, they are not going to get a JRF also. I have already told you on Sunday with Taitan ke saath. Option A is the correct answer because both the statements are correct. Generally, arithmetic mean is an all-purpose average. It will be used for everything. It is general mean. Normal average is treated as an arithmetic mean, and median, mode, partition values are comes under the positional, and AM, HM, GM are comes under the mathematical average. Yes, it is 5:30 p.m. Those who are not going to attend that 5:30 p.m. session, 5:30 a.m. session are not going to get JRF. The arithmetic mean of the 10 item is 50. If each item is increased by 7, then new arithmetic mean would be. Recording? No, not recording. I am saying those who are waking up at 5:30 and sitting for the class for a 15 and brain like fresh up your mind and go for the next activity of your day. So if 10 item arithmetic mean is 50, if it is increased by 7, arithmetic mean also increases by 7, that is 50 plus 7, 57. For nominal data, the only measure of central tendency that can be applied is Acha, option gadbad hai. Okay. I will check it out. You say the I will check it out that one, don't worry. For nominal data, the only measure of central tendency that can be applied. Nominal data. Sir, not possible. Okay, JRF also not possible. That's up to you. If it is not possible, bolte like all are making it possible. Now everybody is attending. More than 60 members are coming. Sleep early. I am forcing you to sleep early to wake up early. For your better health. JRF also not possible. Simple as that. So mode is the one which we have studied just now. Mode. A distribution where the values of arithmetic mean is maximum as compared to the median and mode is. Itna jhoot. Yes. 60 are there. 60 are there. Did you came to that session first? Optic. How many were there? You tell the original number. First day 70. So positively skewed by, because this is about mean is higher, means a positively skewed. Assignment of numerals to objects who represents their attributes is known as nominal, ordinal and interval ratio. Last 5 minutes only 19. No, it never be 19. I didn't saw 19. 45 members are existed today. Today when I am in live, 45 members are there. And it may go up to 55, 60 and touches and it will come back. Like that it is going on. So nominal data is the one, because like nominal data is the one classification of an entire data into various thing, and we can attach the numbers to it to represent or to classify them. Either one is an male, two is an female. So one category, two category, A and B. All the properties of order interval 0 and 0 origin are simultaneously possessed by. Who are asking you to sleep at 10? Sleep at 2, sorry. Sleep at 10:30 or 11 to wake up early. Good question, Haripriya. Good answer is also available. Shilu Chaurasiya. Good answer also available for that. All the properties of order interval 0 origin are there in the ratio data. Rather than chatting with a boyfriend till the night time, rather you can do the sleep early. Spending time on the Insta, Facebook, WhatsApp, etc. You can cut it down from the timetable and sleep early at 11. Try it out once. A scale of measurement for a variable that considers order, distance and unique origin are known as unique origin. Option D is the correct answer. D is the correct answer, ratio scale, because order, distance, unique origin, absolute 0 also will be there. Which of the following relationships are true in modal distribution? So here option actually 1 and 2 can be, 1 is correct and 2 is also correct. Even 3 is also correct. 3 is also correct. This is also correct. Except this, all 3 are correct. 1, 2, 3. Relationship wise, these 3 statements are correct. A, B, C. A, B, C are correct, but answer given by NTA is only 1 and 2. 1 and 2 are the given answers by NTA, but third also correct. Third, because 3 median, this 2 mean will come over here, which is equal to mode only. A, B, C. Which of the following are the position? These are the two 2020 questions. This last question and this question, 2020. Simple questions. I'm not coming, Shilu. I'm not coming and checking you what you are doing on daily activity. But I am not coming anywhere. Other people are coming, you are not coming means I am just asking you to change the late night studies. Don't study that much. Rather, you can study the same in the morning. That's up to you whether I can tell only, because I am not an offline teacher. I can tell only orally. That's up to you whether to follow or not to follow. So option 1 is the correct answer, B and C. Median and mode. Median and mode. Median and mode are the positional averages. AM, GM, HM are mathematical averages. Next, in a moderately skewed distribution, which of the following equations indicate a relationship among the mean? See, in a chapter number 1, only 3, till now 3 questions are there out of the 10 questions. This is another shift, of course. B is the correct answer. Mode is equal to 3 median minus mean, 2 mean. Three median minus 2 mean. Find the mode of the following data. Why? You are getting bored of the questions. So how many questions more? After the question still बाकी है भाई picture. आज का picture बाही like it is left over. A is the correct answer, 8, which is most repeated number of times. 1 time, 2 time, 3 times. Any other variable repeated more than 3 times? 17 2 times. No other. Only one is repeated. That is 8. Mode is the most frequent value, least frequent, middle most, and average value. When class will end? Whenever I end. Whenever I end the class, then it will come to an end. Mode is the most frequent value. A reasonably sized sample. I think these are okay. Done by. The last question is not this chapter. Now let's start with a dispersion. Very small topic. Fatafat we can do dispersion. When you will end. Whenever class completes. Funny undi sir. Danike adigan. నాకేం లేదా like I don't have any other work. I don't have any work. Only you have work. Only like others are not having any work. Others are useless. Only you are useful. क्या है भाई? Class is class. Sir, at the end of the class, please say everyone will get. Those who are attending a 5:30 AM session only will get a JRF. Measures of dispersion. Measures of dispersion. Measures of dispersion. What do you mean by the dispersion? What do you mean by the dispersion? Dispersion is nothing but a variability. The spread difference is called as a dispersion. Difference in the variables or the data is called as a dispersion. Look at the degree to which numerical data tend to spread about an average value is called as a variation or the dispersion of the data. Only 5:30 wali. Only 5:30 wali. Because daily I am taking attendance na. By reading the names I am taking attendance. Those who are not attending will get 100 percentile. That's your positive attitude towards the examination and your result. That will be appreciated, yes. But still NTA will listen to me only, not to you. Mera confidential is sent who already. Not sending. I am preparing already who are added in the previous list. Now I am removing their names who are not attending. Chalo. The degree to which numerical data, the spread. Can you look at the example? 3 firms are there. Firm number A, firm number B, firm number C. In the firm number A, the sales on daily basis are equal sales are there. Equal sales on like a 10 days or 6 days are given. 6 days are given. Then average also will be, mean also will be same. Then second firm B is having a sales like this, very nearby sales, 62,000, 60,000, 52,000, 56,000 and 60,000, 68,000 like that. Nearby is there. So that average also if you can calculate 60,000. That average also if you calculate 60,000. Right? Chalo. So form C, if you look at carefully, form C, 51,032. Difference is higher between the variables itself, between the values itself, difference is higher. 32, again 22, again 18, again 27, again 2,10,000. Sales are having a huge difference. But the mean of this above form C is also 60,000. Mean of all these forms are same. Still, difference between the variables or the data is getting spreaded over, getting increased. Difference is getting increased. Here the zero difference, that is no difference, means that no dispersion. Here a small difference means very less dispersion. Here a bigger difference between the values means higher dispersion. Higher dispersion. That is form C. Form C. Form C is having a highly dispersed. That is what? Highly scattered as compared to the other form. That is spreaded in the scatter of the items is more. Got it? That is what a measure of the dispersion over here. Measure of the dispersion. A word dispersion is can be interpreted in another sense also when all the items or data are not equal to the central tendency. When you compare all the items are to the central tendency, if it is equal, no dispersion. If it is not equal, then there is a difference. The difference is called as a dispersion. Scatteredness, the spread, the difference, the variation between the variables are variable to the mean. That is what we call it as a dispersion. I hope I am clear. Those who want to go from the class, please go by. Okay, you are allowed to go. I am not saying anything to you. That's up to you because everybody is listening to the class now. Let's continue the class. I will complete the dispersion anywhere. Whether even if the one member is going to be there in the chat box, I will complete and I will go. Up to you to attend full or not. Property number 1 of the dispersion. It should be based on all the items of distribution. It is based on all the item because every variable is being considered or not. 51,000 considered, 32 considered, 22 considered, 18 considered, 27 considered, 2,10,000 considered. Everything considered in the variable total data. Right? All the items will be considered in the dispersion calculation. Where it is based on all the observation, not only extreme values, not only middle values, all the values will be considered to represent the data because dispersion cannot be calculated by using only middle or extreme values. Mandatorily, we need to consider all the values. Now, it should be describing the average or a typical deviation of the scores. It should be described the average or a typical deviation of the scores. You can just look into it. Typical deviation of the scores is nothing but average is and mean that we are calculating. Right? Mean we are calculating. Mean we are calculating. And as compared to the mean, how much deviation of each value we are comparing? 51 to 60, 9,000 difference. 32 to 60, like more than 28,000 difference. And 22 to 60, what the difference is higher. So like that, we are clearly calculating a deviation as compared to the mean. And it, that is spread. Spread should be increased in the value as the distribution scores becomes heterogeneous. Correct now, heterogeneous means when the distribution scores are same, no dispersion. When the distribution scores are slightly increasing, it is slightly there is a dispersion. When the distribution scores are increasing, increasing like anything means becoming heterogeneous, becoming different values, then it will be automatically having the values, the dispersion also is going to increase because of this. If values are same, there won't be any type of dispersion. And it will be very easy to calculate and interpret also. How I interpreted very easily by taking a simple example. We have an interpretation over here. If you read this interpretation, the table will be having a clear-cut conceptual clarity over here. Very easy to calculate, easy to represent also. And there are two type of dispersions by absolute measure, relative measure. Absolute measure and relative measures. Absolute measures are range, quartile deviation, mean deviation, standard deviation. Relative measure, coefficient of these absolute measures, that is coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation. Coefficient of standard deviation is also called as a coefficient of variation. Right? Now here range and quartile deviation and the coefficient of range and coefficient of quartile deviation are selected methods, selected measures of dispersion. What are they? Because only selected data will be there in the range and quartile deviation. That is why range, quartile deviation, coefficient of range, coefficient of quartile deviation are called as an based on the selected data of measures of dispersion. Measures of dispersion will be calculated based on the selected data in this 4. Whereas in the remaining, all the data will be considered like a mean deviation, standard deviation, coefficient of mean deviation, coefficient of standard deviation. All the variables will be considered to calculate the measures of central tendency. All the items will be considered in the data. Selected data will be considered in the range and quartile deviation, coefficient of range and coefficient of quartile deviation. Now let's look into it. How to calculate the range? Range is simply an difference between the highest value in the series and the lowest value in the series. That is highest minus lowest. Example 2, 4, 3, 9, 8, 7. So in this case, 9 is the highest value, that is 9. Lowest value is the 2. 9 minus 2, which is equal to 7. 7 is the range of this series. Right? Next, interquartile range or a quartile deviation. What is this? First, let us discuss quartile deviation. Quartile deviation is nothing but the formula of quartile deviation is, we know what is quartile. Q1, Q2, Q3, 3 quartiles and 4 parts. Q4 also will be there, but only 3 parts. The difference between the third quartile and the first quartile of a divided by 2. Q3 minus Q1 divided by 2 is called as a quartile deviation. Right? Quartile deviation is equal to quartile deviation number 3 minus quartile deviation 1 divided by 2. Q3 minus Q1 divided by 2. But when it is only the difference between the Q3 and Q1, that is called as an interquartile range or semi-quartile range. This is also important PYQ. Only numerator without division of the 2, Q3 minus Q1 divided by 2 is an quartile deviation. Q3 minus Q1 is equal to interquartile range or semi-quartile range. That's it. Next, what is a mean deviation? When you compare with a mean, what is the difference that we are getting is called as an absolute deviation. That is what we are telling it as a mean deviation. Comparison with a central tendency, the total sum of the deviation is called as a mean deviation. And standard deviation is nothing but it's a square, like a difference of each observation from the mean. Difference themselves were added up and a positive would be exactly balance the negative. One of the property of the arithmetic mean, did you remember? That is the same. Standard deviation is nothing but sum of the positive value of a difference, that is x minus x bar, value minus mean, the difference that we will be getting, which is called as a standard deviation. Deviation from the mean, each and every observation, deviation from the mean will be calculated and we will be adding up them. Some half will be positive, half will be negative, and both if we add together it will become zero. It will become zero simply. So if you look at the total all four put together absolute measures, absolute measure of a dispersion expressed in the same unit in which data series is given, that is independent of change of origin. Plus and minus can be done over here, means addition and subtraction is an independent, because by doing an addition, by doing a subtraction, these absolute measures are not going to be impacted. But if you do the multiplication and division, it will impact. If you do the addition and subtraction, no impact. But if you do the multiplication as well as the division, there is an impact on these absolute measures. Right? So range is a difference between the highest and lowest. Range is affected by the extreme values, but quartile deviation is not affected by the extreme values. Range is affected by the extreme values, quartile deviation. Extreme means starting and end point. Starting and end point is not affected in the mean deviation because that is mean. And range, extreme values, last and first values will be, because that is the highest and lowest. If we arrange them in ascending and descending order, that will be impacted. Now here concept of a range, where it will be used usually. It is used in case of statistical quality control purpose. It will be helpful in studying the variation in the price of the shares. In case of price of the shares, it will be used. Debentures and agriculture commodities who are very sensitive to the price changes now, which are fluctuating. In those cases, range is a good indicator for the identifying those price of the shares also. And it is also good indicator for the weather forecasting. Weather forecasting, it is good indicator range. Highest how much and lowest how much. Next, Q3 minus Q1 divided by 2 is a quartile deviation formula. And mean deviation formula, it is simply used to calculate how far our values of each observation is from the middle of the data set, that is median. Sorry, mean. Middle of the data set, how much it is far, to calculate that only mean deviation will be there. In case of ungrouped data, only individual series is there. Mean deviation is equal to summation of deviation divided by n. What is the deviation? X minus x bar. X minus x bar divided by n. Summation x minus x bar divided by n. In case of ungrouped data. If it is a grouped data, as I discussed yesterday, only frequency is going to be get multiplied over here. Extra one will be summation of the frequency into deviation. Frequency into deviation, FIDI. Frequency into x minus x bar divided by n. If it is ungrouped and grouped. That clear? And standard deviation formula. Standard deviation is a measure of the dispersion of a set of data from the mean. From the mean, how much it is getting dispersed, the variation or the difference. Grouped में frequency आता है. In case of ungrouped data, there are two formulas. And in case of grouped data, there are two formulas, because those are direct and indirect method usually. So I hope the formula is visible to you. You can look at ungrouped data, standard deviation is equal to, this is in case of discrete and continuous series, we can say. Ungrouped is an discrete. Grouped is an continuous. So standard deviation is equal under root of summation deviation square divided by n. Deviation square is nothing but x minus x bar whole square, right? So in other case, summation standard deviation is equal to under root of summation d square divided by n normal minus summation d sum of the deviation divided by n whole square divided by n whole square, that is. This is ungrouped data. And in case of grouped data, frequency is the same. Just add, multiply with a frequency. Multiply with a frequency, multiply with the frequencies. Look at the formula. Simply when you multiply with a frequency, it will come. Summation f d square divided by n. Alternative formula. Summation under root of summation f d square by n minus summation f d divided by n whole square. If you remember one formula, it will be easy to tackle other formulas. No need to mug it up. Answer option will give you the final answers. I hope I am clear with it. Quartile deviation. All the questioning areas are getting covered by. If you carefully observe, you compare with any of the PDF, any of the material, any of the PYQ. Every question is getting covered over here. I am not emphasizing much on the in-depth knowledge. I am emphasizing much on the examination perspective, which are questioning areas. Next, relative measures are coefficient of range, coefficient of deviation, mean deviation, coefficient of quartile deviation, coefficient of standard deviation. So this is also independent of change in origin, independent of change in scale. Multiplication and division, it will be impacted, and addition and subtraction, it is not going to impact. Right? Not that's all. Relative measure is pending. Relative measure of a dispersion based on the range of a given data set. That is, coefficient of range is equal to high minus low value divided by high plus low. High minus low value divided by high plus low. That is what the formula for coefficient of range. Coefficient of mean deviation is equal to, coefficient of mean deviation is equal to, it is calculated by dividing the mean deviation by the average. So mean deviation means x minus x bar divided by x bar, x minus x bar divided by x bar, or else median also you can take it in the denominator. Coefficient of quartile deviation, q3 minus q1 divided by q3 plus q1. If you observe the quartile and range having the same type of formula like a range. Range formula is high minus low, and quartile deviation q3 minus q1 divided by 2. And here also coefficient of range high minus low divided by high plus low, and coefficient of quartile deviation q3 minus q1 divided by q3 plus q1, right? Next, coefficient of standard deviation. Coefficient of standard deviation. That coefficient of standard deviation is also written as a coefficient of variation, which is also known as relative standard deviation. This is relative measure is a coefficient of standard deviation. That is standard deviation divided by mean. Standard deviation sigma divided by x bar, sigma divided by x bar into 100, which will give you coefficient of standard deviation. Acha, this is okay. Done. I will change it. Okay. Now, skewness. Next topic of the discussion is skewness. What is next topic? Skewness. Skewness and the dispersion difference is more important because high possibility to ask the question. High possibility to ask the question. Before going for that, question number 1. Just a question. Coefficient of variation is an absolute measure of the dispersion. Coefficient of variation is a measure of the central tendency. I am not kidding, I am continuing. Please try to understand. Today Sunday, no issue. We can have the session. So option D is the correct answer because coefficient of variation is it is not absolute, it is a relative. Okay, coefficient of variation is not measures of central tendency, it is a measure of dispersion. That is why both are wrong. Which one of the following is a relative measure of a dispersion? Relative by. Array, what you are answering? Relative. Everybody initially. That is coefficient of variation. Skewness. What do you mean by the skewness? Actually, the term skewness means what? Lack of symmetry. Okay. Lack of symmetry. Any other? Skewness is a lack of symmetry, means it denotes a degree of a departure of a distribution from the symmetry and reveals a direction of a scatteredness. Either it is rightly or leftly, which is skewed. Means a leftly skewed is nothing but tail is rightward. Sorry, leftly skewed is nothing but tail is leftwards. Rightly skewed is nothing but tail is rightwards. So in the middle is nothing but a normal distribution. Normal distribution. Symmetry is nothing but which is not having a proper, we can say, where symmetrical distribution is nothing but mean, median, mode. All are equal. That is what a symmetrical. And lack of symmetry is nothing but when this mean, median, mode are getting fluctuated, like increasing, decreasing is happening. That is what a skewness. When increasing, decreasing happening, it will be deviating from this symmetry. Symmetry is nothing but here is the median, mode, mean are equal. When median, mode are not equal, somehow mean is more or median is more or the mode is more, then it is left or rightward, it will move. That is what we call it as an actually the skewness. Skewness is nothing but moving or departure of a tail from the distribution from the symmetry. Lack of symmetry, positively or negatively, which will reveal the direction leftwards or the rightwards, and it will also show the scatteredness of the variables which are involved in it. Right? So it gives an idea about the shape of frequency curve. When the distribution is not symmetrical, it is called as an skewness. When distribution is not at this middle point, when it is not having a normal distribution, then that is called as an symmetrical. So lack of symmetry or skewness. Next, here there are two types of distribution: symmetrical distribution, skewed distribution. Symmetrical we know, which is a middle point where the mean and median mode are equal, is called as an symmetrical distribution. And the skewed distribution is nothing but either rightwards or leftwards. So rightwards is called as a positively skewed distribution, in that mean is more, and negatively skewed distribution in that mode will be more. Right? So symmetrical distribution is a curve which is skewness is not present. Where the skewness is not present, that is an symmetrical. Where the symmetrical is not present, that is skewness. Ulta. The value of a mean, median, mode coincide, that is mean equal to mode equal to median. The spread of the frequency is same in both the sides of central point. That is what we call it as an symmetry or symmetrical. Skewed distribution meaning. Here you can just see with our pictures. A distribution which is not symmetrical means which is not having a middle point where mean, median, mode are equal. That's called as skewed. Our asymmetrical distribution is nothing but asymmetrical is nothing but simply which is leftwards or the rightwards. Which is leftwards or the rightwards. So skewed is indicating asymmetrical or lack of symmetry. Lack of symmetry. It can be a positive or negative. If the longer tail of frequency distribution lies to the left, like this, where the mode is going to be higher and mean is going to be lesser, that is leftwards. That is called as a negatively skewed distribution, where the mean will be less than the median and median will be less than the mode. So here in this case already we have learnt mean less than median less than mode in the negatively skewed. In the positively skewed, mean more than median more than mode. Mode will be smaller in nature. Rightwards. When the tail is rightward positively skewed, where the mean is going to be more than the median, and median is going to be more than the mode. Clear? This point skewed distribution, positive and negative. And there are three measures of a skewness by Karl-Pearson measures of coefficient of skewness, Bowley's coefficient of skewness, Kelly's coefficient of skewness. Kelly's coefficient of skewness. So here you can just see, I hope everything is visible clearly. This measures of skewness. Full slide is visible, na? Guys, do hit the like button. Karl-Pearson coefficient is also known as Pearson coefficient of skewness. This is based upon the difference between the mean and mode. It is a difference between the mean and mode. The representation of the Karl-Pearson coefficient will be there. So it's an difference of mean and mode divided by the standard deviation. Mean minus mode, mean minus x bar minus mode divided by standard deviation, which is called as an Karl-Pearson coefficient of correlation. So coefficient of skewness. And here theoretically Karl-Pearson coefficient of skewness lies between the plus or minus 3. From minus 3 to 2 plus 3 will be there. In such a case, when it is plus or minus 3 in between, then in such a case coefficient of Karl-Pearson skewness will be 3 into mean minus median. 3 into mean minus median divided by standard deviation. Means that it is between the plus 3 minus 3, it will be light, and that rarely exceeds the plus or minus 1, but it will be lies between the plus or minus 3. So here 3 mean minus median divided by standard deviation will be the formula in such a second case. Alternate formulas have been also given. Next, Bowley's coefficient of skewness. Bowley's coefficient of skewness is above. This is purely based on the quartiles. We have already learned what is quartile in the previous session when it is representing Q1, Q2, Q3. But 4 parts will be there. Q2 is called as a median and Q3, Q1 are called as an extreme endpoints. Here the value of Bowley coefficient is between the plus or minus, not between the plus or minus 3. And here it measures a usefulness. In case of open-ended distribution, this Bowley's coefficient of skewness will be useful. Open-ended distribution which doesn't have any end point. And this measure is based on pure, only middle, that is 50% of data, and ignores the remaining 50% of data. Why it is considering only 50% of data? Because it is ignoring the before median, after median. Either this or that only will be considered, not the entire data will be considered. Right? The value obtained by the Bowley's and Pearson methods neither comparable nor thereby any relationship to one another. So here if you can see the skewness of Bowley, Q3 plus Q1 minus 2 median by Q3 minus Q1. We have learned quartile, how the formula will be there for the quartile. Q3 minus Q1, Q3 plus Q1 divided by Q3 minus Q1, like that formula used to be there. In the same, but here the skewness, how to identify? Q3 plus Q1, which are end extreme points. From that two medians that you are removing, and divided by extreme points difference, that is Q3 minus Q1. You can write this one as Q3 minus Q1 or Q3 minus Q2 minus Q1 minus Q2. Q1 minus Q2. The numerator also can be written in this way. Q3 minus Q2 minus Q1 minus Q2. In such a case, Q3 minus into minus plus, right? So minus into minus plus, and minus into plus into minus, again minus. So 2Q2 will come and minus Q plus Q1 will come. Q3 plus Q1 minus 2Q2 will come. Simply it is a representation of Q3 plus Q1 minus 2Q2, which is a median. Q2 is a median. I think you got the point. Bowley's. They will not ask this much depth, but they will ask the following question. Formula Bowley's, formula Kelly's, formula Karl-Pearson. Like that question has been asked. Next, Kelly's coefficient of skewness. Kelly's coefficient of skewness. PSI I didn't saw your text. Now I saw. Okay. Kelly's coefficient of skewness. Kelly developed another measure of a skewness, which is based upon the percentile and decile. Whereas Bowley based on the quartile, Kelly's depends upon the percentile and decile. The formula for measuring a skewness is that here P90, which is a 90th percentile, right? P90 plus P10 minus 2 median. P90 plus P10 minus 2 median divided by P90 minus P10. This is representation in a percentile form. Okay. Q3 plus Q1 minus Q3 minus Q1. Which formula is wrongly written? Why, if you solve it, you will get the same answer. Same, this only will come automatically. Acha, Kelly formula written wrong, huh? Blue one is absolutely correct. There is no problem in it. If you solve that one, you will get the same answer. Don't worry. No. Practical question you don't expect from any of the skewness. Practical question will not come. If you solve that one, you will get the same. I don't think that is wrong. I have clearly written. So here P90 plus P10 minus 2 median divided by P90 minus P10. And here D9 plus D1 minus D9 plus D1 minus 2 median divided by D9 minus D1. It is correct only, I believe. If you do the if you open the bracket and do that simplification, Q3 plus Q1 will come, minus 2Q2 will come. Absolutely, it is correct. Open bracket and solve it, Rahul. Q3 minus Q2 minus Q1 minus Q2. Then you will get Q3 plus Q1 minus 2Q2 will come. दोनों ब्रैकेट बीच में प्लस साइन आएगा. I have also done. Now I am getting the same thing. Then if you are not getting, what should I do? I think it is written clearly. Don't confuse. P90 plus P10 minus 2 median divided by P90 minus P10 equal to D9 plus D1 minus 2 median divided by D9 minus D1. This is the Kelly's coefficient. This is based on the deciles and percentile, and the Bowley based on the quartiles, whereas mean and median based is that called Pearson coefficient. Q2. You can write 2 P50 also. P50 is indicating a median by. P50 is nothing but a median. And here D5 is nothing but a median. You can write a D5 or a P50, that's your choice. But remaining things will be constant. Always remember, median is indicating a middle value. In case of that quartile Q2 and in case of percentile P50, in case of decile D5. Next, here movements, measures of a movements is more important. Measures of I am very sweet and kind. Who told like you are not sweet and you are not kind? Nobody told, no? First movement is that mean, second movement is that variance, third movement is that skewness, fourth movement is that kurtosis. This mean will give you the center of the distribution. Second movement is that variance, which is giving a spread of the distribution. The we can say spread means how much it is getting deviated. And the third moment is nothing but a skewness, asymmetry, lack of symmetry. Fourth moment is an kurtosis, which is indicating a peakedness. 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 Peakedness means highest, we can say. So, and here we need to understand the partition values also. Partition values, as we understood, percentile, deciles, quartiles. When it is divided into 100 equal parts, it is called as a percentile. When the data divided into 10 equal parts, it's called as a decile. When the data divided into 4 equal parts, it's called as a quartile. That's it. Difference between the skewness and dispersion. Look at difference between the dispersion and skewness. Dispersion is, it measures the tendency of data set distributed over a range in a statistical analysis. In a statistical analysis, so dispersion means like a variation from the mean that is dispersed over the mean, we can say, and it measures the asymmetry, means a lack of symmetry. It deals with a distribution of values set up around the central point, which is a mean, and this is about the symmetric or asymmetric only. Range, standard deviation, average deviation, that is mean, are based common ways to calculate the dispersion. Here mean, median, mode are the common ways to calculate. Even quartile, decile, partition values also will be. And your degree of variation it will be determined in the dispersion, variation from the mean. And here extent of variation in terms of the lower and higher values will be comes under the skewness, extreme values. That is why P90 or the D9, D10 or the P10, even you can say this one, Q3, Q1, first extreme values will be considered over here. And this is used for the statistical methods such as regression analysis, it will be useful. Dispersion will be useful for regression analysis, and here skewness can be useful for economic analysis in the financing as well as investing purpose. Next, can you answer this question please? Guys, do hit the like button. You are not hitting the like button. This is not fair. पाप लगेगा भैया, पाप लगेगा. अरे कितने बार जोमेटो ऐड आते भाई. What is the third measure of movement in the measures of skewness? Third movement of measure is what? Skewness. Option A. Now the kurtosis. What do you mean by kurtosis? Kurtosis meaning of the kurtosis. Here, kurtosis is a statistical method which is to describe the degree to which scores cluster in the tails are the peak of a frequency distribution. Simply, it will show it is called as a degree of a peakedness. Peakedness means highest. Peakedness means highest one. That is taken relative to the normal curve. Plugginess or the peakedness or the highest, that comes under here. So there are, to explain that peakedness, there are three curves: leptokurtic, platykurtic and mesokurtic. Wherever leptokurtic, like leptokurtic is nothing but a highest one, which is actually a normal distribution. Leptokurtic, actually a normal, highest one, not normal one, highest one. Here in this case, curve is having a high peak than the normal curve. higher peaker than the, this is actually the mesocratic is a normal distribution curve, mesocratic, where the beta 2 is equal to 0 and the gamma 2 is beta 2 is equal to 3 and gamma 2 is equal to 0. Those are comes under where it is going to be mean, median, all are equal. This is actually a symmetrical distribution. This is actually a symmetric distribution, that is a medium peakedness will be there. And high peakedness will be higher than the this mesocratic. Low peakedness will be lower than the this mesocratic. So that means higher than the mesocratic is called as an higher peakedness, which is leptocratic, and lower to the mesocratic is nothing but platycratic, which is lower peakedness that we are having. And it is represented by actually beta as well as gamma. Beta as well as gamma. What is this beta? What is this gamma? Beta is simply a variance. It is trying to explain the variance, which is indicated in the form of a mu also. So mu is a variance and beta is trying to explain about the variables. I will show you another point over here, which is useful for you. Here in my handwritten notes, it is there. Even I will be adding into the our notes also. But wait, let me tell the points. You can just see this. Mesocratic is the normal distribution, correct? You can just see this. For movement of a coefficient of kurtosis, we can have two types of formula to calculate. First is Pearson beta coefficient is called as a movement of coefficient of kurtosis. That is beta 2 is equal mu 4 divided by mu 2 whole square. Mu 4 divided by mu 2 whole square. You can look at, for using Pearson beta 2 coefficient of kurtosis, mu 4 is mu 4 divided by mu 2 whole square, right? So mu 2 and mu 4 are what? Second and fourth movement about the mean. That is, we can say variables, second and fourth movement. And here mu 2 is an variance. Usually mu 2 is called as a variance. The variance square we are indicating. Simply mu 4 divided by variance square, which is equal to a standard deviation. Simply we can call it as variance square is nothing but it will become a standard deviation. Under root standard deviation we can say. Beta 2 is a measure of a degree of peakedness, which is greater the value of the beta 2, which is greater the peakedness will be there. Greater the value of beta, greater the peakedness. That is why in the mesocratic, you can see beta 2 is equal to 3, means it doesn't have any high peakedness, low peakedness, medium peakedness. High peakedness means highest. Leptocratic beta is more than 3. Leptocratic beta is more than 3. Beta is more than 3 means more peakedness. Beta is less than 3 means less peakedness. So remember in that way. Are you getting the point? That is why here I have given a summary also in my handwritten form. Beta equal to 3, 0 skewness, 0 kurtosis, and positive kurtosis more than 3, negative is and less than 3. Negative is and less than 3. Now gamma. What is this gamma? Gamma. Another way of a measure of kurtosis is that Pearson gamma coefficient of kurtosis is that gamma 2 minus beta 2 minus 3. Gamma 2 minus beta 2 minus 3 will come here. Kurtosis is termed as an beta 2 minus 3, which is gamma. So the value of gamma is positive for leptocratic curve, as because excess of kurtosis is present there. And the value of gamma 2 is negative for the platycratic. Value of gamma is 0 for the mesocratic. So final conclusion is that gamma 2 is equal to 0 mesocratic, which is 0, and leptocratic is an more than 0, which is positive, less than 0, which is negative. And in the same case, how the beta 2 is going to behave also is more important. Clear? Beta 2 more than 3, gamma 2 more than 0. Beta 2 equal to 3, gamma 2 equal to 0. Beta 2 less than 3, gamma 2 less than 0. Highly peakedness, middle peakedness, and lower peakedness. That's it. Question, please. Guys, do hit the like button and subscribe to this channel. Don't forget to subscribe now. I think if you are new over here in this channel, do subscribe. Yes, option C is the correct answer. Leptocratic is having higher, which is a measure of peakedness. Kurtosis. Now the correlation. Done. Am I ignoring any of the important areas with respect to examination? I hope I am not ignoring. What is correlation? Correlation is an association between the variables. Relationship that establishing between the variables based on association that is there. So correlation is a statistical tool which shows the relationship between the two variables in which change in value of one variable due to change in the value of other variable. One variable is trying to change the other variable. One variable is trying to change the other variable. Due to change in other variable, one variable is getting affected. So usually the formula, what is the formula for the correlation coefficient? Sigma x, summation of xy divided by summation of x square under root and multiplied by summation of y square under root. Summation of y square under root. This is the formula. Now most important questioning area is that properties of the correlation. Coefficient of correlation always lies between the -1 to the +1. So it limiting values are -1 less than or less than +1. So -1 to +1 only, all the limits of coefficient of correlation will be existed. Yes, this is useful for the management also. If R is -1 or a +1, that will point lies on the straight line only, plus or -1. If R is close to -1 or a +1, R is equal to -1 or +1, that is on the straight line only, point will be light. If R is close to -1 or R is close to +1, then we can say that is having a strong correlation. Strong correlation. Then if R is close to 0, we can say points have a weak correlation. That doesn't have much association between the variables. And the geometric mean of the two regression coefficient is an correlation. That is R is equal to Bx of y into By of x. Bx of y into By of x. Under root Bx of y into Byx. That's an correlation coefficient geometric mean. So geometric mean of the correlation coefficient, that is under root of AB, comes under here. Now independent of scale and origin, either you do the plus, minus, division, multiplication, anything, there is no effect over here. Independent of change and origin. Plus or minus and multiplication, division, anything can perform, because this is a unit free correlation. Unit free correlation coefficient is an unit free measure. There is no proper significance over here. So no kg, no rupees. It is unit free. We cannot measure in anything. Unit free measure. Only it is available in the numbers. That is -1 to +1 only it will be there. It is not going to tell anything. It is not going to tell like a measurement and a kg, rupees. Those things will not come under here. Done. And the uses of correlation will be, correlation is to study the strength of a relationship. Most of the time in all the shifts of examination, if you look at whether 2020, 2019, formulas are going to play a key role than the actual problematic solving of the question. You can just see, it will study the strength of a relationship and it will help in planning and forecasting. It will then take the decision accordingly. It will take the decision accordingly. It is to study the direction of a relationship also. Direction of a relationship. And based type of correlation by type of correlation. How many types of correlation? There are many types, but based on the three bases, we are having this type of correlations. Based on the change in variables, positive, negative, no correlation. Based upon the variables studied, simple, multiple, partial. Based upon the consistency of the ratio between the changes, linear as well as non-linear correlation. Linear as well as non-linear correlation. Let's study one by one positive and negative and no correlation. What is positive? It can be represented in a scatter diagram which you to show the relationship between the variables. Positive correlation is nothing but the points are very close to the straight line. Positive correlation. Points are very close to the straight line that you can see in the scatter diagram. It increases. One variable increases, the other also variable. A basic example of positive correlation is that height and weight. Taller people tend to be heavier. Taller people tend to be heavier because they are very closely to each other. And shorter people tend to be like we can say lower weight. So which is having a positive correlation. Positive or negative correlation. Positive correlation means association is very, very close association. Very, very close association it will be. Right? And negative correlation is indicating negative correlation. Negative correlation is a point lies close to the straight line from the left to the top, right bottom. Left to the right bottom here. Point is lies to a straight line from the negative top to right bottom. This shows that one variable increases, other variable decreases. This is in the same direction it will go. Whereas when the demand, like it is like a demand curve where it is coming now in the scatter diagram, then this is a negative relationship. This is a positive relationship. Right? Like price and demand of a commodity, as a price increases, demand for a commodity increases. Now, negative correlation inverse and positive correlation direct relation. Next, no correlation is nothing but these are, this is to pattern to the point. This shows that there is no connection between the variables. Actually, not even having any type of variables comparison. Here, no relationship between the amount of tea drunk and the level of intelligence. Amount of tea drunk and level of intelligence. Somewhere at a different places will be keeping this no correlation activity. Different because doesn't have strong relationship much. Next, correlation on the basis of variables studied. Simple random, look at simple random, simple correlation. Under the simple correlation problem, there are only two variables, that is correlation between the income and expenditure. These are two variables. Between these two variables, you can draw the relationship. Otherwise, you can't draw. So, which can be simply we can draw, that is simple, two variables will be involved in this. That is what a simple correlation. Multiple correlation is nothing but more than one variable, more than two variables will be involved. Three or more than three, like a rainfall, production of the rice and price of the rice should study. If rain comes, rice will be produced. If rice produced, then only the price of a rice will get to know. Price of rice will get to know. And in the same way, if the no rainfall, production of rice is not possible, then price of the rice also will fall down. Like this, multiple correlation where more than one variable is involved. And partial correlation. Partial correlation. It analyzes and recognizes more than two variables, but considers only two variables, keeping the other variables constant. That is, you might want to see if there is a correlation between the amount of food eaten and the blood pressure. Amount of food eaten and the blood pressure while controlling for the weight or amount of exercise. Analysis and recognizes more than two variables. It will consider only two variables, keeping other variables as constant. And you might want to see if there is a correlation between the amount of food eaten and the blood pressure while controlling a weight or the amount exercised. Right? Is that clear? Partial. Two variables are changing, two variables are constant. Like that, partial correlation. Next, based on the variables, change in between the variables. Linear correlation, non-linear correlation. What is linear? If ratio of a change is constant, when the amount of output is a factor is doubled by doubling the number of workers. Look at, if the ratio of change is constant, when the amount of output in a factory is doubled by doubling the number of workers. So this is an example of linear correlation. In other points, All the point, when all the points on a scatter diagram tend to be near line, looks like a straight line, then that is said to be a linear. So in case of first also it is linear actually. Positive correlation is having a linear, we can say linear correlation. And non-linear is nothing but correlation is said to be non-linear if the ratio of the change is not constant in nature. That is what a non-linear or a negative correlation. Non-linear or a negative correlation. In other words, when all the points on a scatter diagram tend to near a smooth curve, the correlation is said to be a non-linear or a curvilinear. Non-linear or the curvilinear. Simply, non-linear is nothing but it's a ratio change is happening. Ratio change is not constant in nature. Keeps on changing. That is why it is non-linear in nature. Now, if you see correlation degrees, perfect correlation positive +1, negative -1. High degree correlation minus plus 75.752 plus 1, minus 0.752 minus 1. And here moderate is a moderate degree of a correlation plus 252 minus 0.75, minus 2.5 to 0.75. And low degree of correlation, that is 0 to 25 and 0 to 0.25. Absence of correlation, we can't do anything. And we can move to the next. Standard error, probable error. What do you mean by standard error? What do you mean by probable error? Guys, do hit the like button if you like the session. And do not forget to subscribe to this channel. If you subscribe, you will be getting a notification whenever I'm going live. Standard error, I need to start. What do you mean by the standard error? Formulas, I'm directly hitting the main point only. Formulas will be discussed, and remember the formula that will come in the examination. Conceptual questions are very rare questions in the statistics. Formulas matching or else related to the main key point of that particular concept will be there. Right? What do you mean by standard error? Standard error is nothing but the deviation. It is a measure to extent which sample mean that we have taken is deviating from the whole population mean. Sample mean is getting difference. The difference between the sample mean and population mean is called as a standard error. So that is standard error is equal to difference between the population mean minus sample mean. Difference between the population mean and sample mean is called as a standard error. How it is represented? Standard error is equal to 1 minus r square. 1 minus r square divided by under root of en. That is a usual formula that we have to see when we are referring to the standard error. So here population and sample mean difference is called as a standard error. It is represented by the formula in the form of 1 minus r square divided by under root n. Right? Now there is a concept called as a probable error. Probable error is nothing but it defines half of the interval about the central point of a distribution such that half of the values from the distribution will lie within the interval or half will be lying out of the interval also. Like you can see, this is a normal distribution that we know, right? And here is a central point will be there. And here minus 1 standard error, like minus 1 standard error or else a deviation and plus 1 standard deviation. Minus 2 standard deviation plus 2 standard deviation. X plus 1, x minus 1, x plus 2, x plus 3. So x plus 2, x minus 2 and x plus 3, x minus 3. Like that it will be there. So here simply a probable error is nothing but the portion which is showing, which is conforming or which is accurately where we can believe the correlation coefficient. That is what we call it as an probable error. So here it is a difference between, sorry, not difference. Probable error is a correlation coefficient, helps in determining the accuracy as well as reliability of the value of the coefficient that it so far depends on the random sampling. Accuracy and reliability of the value of coefficient of correlation is decided by the probable error, and it will show the upper and lower limits. You can just see. In other words, probable error is the value that is added or subtracted, either plus or minus 1 usually. plus or minus 1. Probable error is called plus or minus. It is a representation of either a plus 1 or a minus 1. It lies in between this only. Added or subtracted from the coefficient of correlation. From the R only it will be. From the R only it will be subtracted or added to get the upper limit and lower limit respectively, within which value of the correlation is always lies. In this probable error only, the correlation coefficient value will be lies over here. And measures of error of estimation for a sample from the normal distribution. Error of estimate of a sample from the normal distribution. It is computed by standard error. You can look at the formula. How to calculate the probable error? Probable error is equal to 0.6745 into standard error. What is the formula of standard error? 0.6745 into standard error formula 1 minus r square divided by n under root n. That is also can be written in the form of 2 by 3 because 2 by 3 exact representation you can equal to 6745 point. So probable error is equal to 2 by 3 into 1 minus r square divided by root n. It will simply show the reliability and dependability of the correlation coefficient. Whether we can believe this correlation coefficient or not. Whether we can rely upon this association which is existed or not. That will be revealed by the probable error. I hope I am clear. 0.6745. This is a py cube matching as well as the standard error 1 minus r square divided by under root n also is an question. Py cube. It tells us the limits where the r should fall. That is correlation coefficient where it should fall. If r is less than the probable error, no evidence of correlation. If r is more than the 6 times of probable error, r is more than the 6 times of probable error. But this is more important. R should be 6 times. R should be 6 times of the probable error. Then we can say that correlation coefficient is reliable and it should fall. Right? When R is less than PE, no significance and no evidence, nothing is there. We cannot rely on that one. We cannot believe on that one. It is not accurate. It is not reliable. When R is 6 times of the probable error, then that correlation is significant where we can rely upon it, where it is showing an accuracy. Right? Significant it is. What about the TSSET? If you ask like it in between the session, now what about TSSET? Bolata, I am not getting your point. What about TSSET? Nothing is what we are discussing. Why you in the middle you are coming and what about TSSET? Am I conducting exam? Look at 6 times are a more significance. Exactly. Less error and chance of reliability is high. Look at methods of studying the correlation is of 2 types. Methods of studying the correlation is of 2 types. Graphical method and algebraic method. Graphic method is an like scatter diagram. Graphic method is a form of a scatter diagram showing is there now. Graphic method can be a scatter diagram or else a correlation graph method. And here algebraic method is of Pearson coefficient of correlation, rank correlation, Passman rank correlation coefficient, concurrent deviation method. 3 deviation. 3 methods are here. Graphic and algebraic method are there. So here in this algebraic method we will be having a formulas to calculate the coefficient of correlation. Whereas graphical method represented in the form of a graph. You can just see here. Graphic method is an extension of a linear graphs only. How we have done linear graphs? When it is in a positive direction, when it is in an opposite direction. How we have drawn the diagram in the same way that is depicted over here in the graphical method. So that is over here. So this is an extension of a linear graphs. In this case, 2 or more variables are plotted on a paper. If this curve is moving in a direction, that is in a positive direction or a negative direction or else with no direction when it is moving, that will show the scatter diagram. So here just you can see by the scatter diagram you can able to understand what the graphical method wanted to convey. Good afternoon everyone. Scatter diagram is an graphical representation of finding relationship between 2 or more variables. It is between the 2 or more variables. Independent variable are taken on the x-axis dependent variable on the y-axis will be taken. This is dependent, this is independent on x-axis and dependent on y-axis. And it will plot a curve. Whenever there is a perfect correlation, look at, whenever there is a perfect positive correlation, it will move in a same direction like a supply curve. Remember always, positive supply curve, negative demand curve. Moving in a same direction, supply curve behavior. You can just see perfect positive correlation moving like a supply curve. Perfect negative correlation moving like a demand curve. Slope downwards from left to right and slope upward left to right. Positive, slope upward left to right. Negative, slope up, downward left to right. And low degree of positive correlation. You can see association between the variables is very low. Right? Association between the variable is low. In case of low degree or a positive degree, here the nearness of the variables is very low. And that is moving upward, that too. Moving upward. Low degree positive. Association is less, and that is why it is low degree, and it is moving in a positive direction, which is in a like upward. Low degree of a negative correlation. Low degree of a negative correlation. Move downward from the left to right. Move downward from the left to right, and association between the variables is very, very less. Very, very less. Right? And high degree of a positive correlation. High degree of positive correlation. Here, perfect positive is very close relation by. High degree of positive correlation, somehow you will be having association stronger as compared to the low degree, but it is not that much stronger as compared to the perfect positive. Always perfect positive will be having high association. Later high degree positive correlation will be having strong association. Later low association is there between the low degree of positive correlation. In the same way the negative also. Here high degree of negative means not like low degree and not much like a perfect negative degree. It is like association is strong but not lower than the low degree, not higher than the perfect negative. This is strong, perfect, low. In that way positive, negative also will be classified. And when there is no correlation, it can move in any direction. Either it can be a circular, it can be a convex curve, it can be an U-shaped, it can be of any shape. That comes under the no correlation one, which is the diagram of the scattered. Right? Next, Pearson coefficient of correlation is very famous one to calculate the correlation. This is one of the best way to calculate. Correlation coefficient is a mathematical or algebraic and most popular method of calculating. So here arithmetic mean and standard deviation are the base. Arithmetic mean x bar and standard deviation sigma are the two bases for calculating the Pearson coefficient of correlation. This is also called as a linear correlation coefficient, which measures the strength as well as direction of a linear relationship between the two variables. Strength as well as direction of a linear relationship means moving upward between the two variables. The value of this R is like a correlation only, which is lies between the -1 to +1. It will be there. -1 to +1. The value of this correlation coefficient as per the Pearson, it will be there. Right? What is the formula? Did you remember the formula? Pearson coefficient of correlation. Pearson of coefficient of correlation is simply this one only. Big formula will be there, but you remember sigma xy divided by under root sigma x square divided by, so under root sigma x square multiplied by under root sigma y square. That can be a Pearson or normal correlation coefficient, which is treated as a correlation coefficient of Pearson. Next, coefficient of determination. Coefficient of determination. Actually, Pearson I didn't mention, right? Formula. This is what the formula. You can just look over here. n into sigma xy minus sigma x into sigma y, or the summation we can say n into summation xy minus summation x into summation y under root summation x under root n into summation x square minus summation x whole square into under root n into summation y square minus summation y whole square. This is what the correlation coefficient of Pearson formula. Correlation coefficient of Pearson formula is this one. N into summation xy minus summation x into summation y divided by under root, whole under root, n into summation x square minus summation x whole square into n into summation y square minus summation y whole square. Right? This is what simply the correlation coefficient formula of Pearson. Now there is a concept called as an correlation, so coefficient of determination. Coefficient of determination is also been asked in the examination. Coefficient of determination. When correlation coefficient whole square is called as an coefficient of determination. Coefficient of correlation whole square, that is R square, is called as an coefficient of determination. Coefficient of determination will find out the causation between the variables, not the association. So here it measures the strength of relationship between the variables. It measures a change in one variable due to other variable. The causation means a dependency, a type of a dependency. You can just see how a change in one variable is leading into a change in other variable. This is denoted by the R square. And coefficient of non-determination. If R square is coefficient of determination, then 1 minus R square is an coefficient of non-determination. Simply square of the correlation is called as a coefficient of determination, denoted by the R square. When it is non-determination, that is 1 minus R square. And another way of calculating the determination is that explained variation divided by total variation. Explained variation divided by total variation. Out of the total variation, what is explained, that comes under the determination, which can show the relationship. It measures the changes in one variable due to change in other variable. The relationship will be shown over here, right? Same. R square and explain. See, this is a coefficient of determination, explained variation. There are two types of variation. One is explained variation, which is showing a relationship. And another variation also will be there, which we can't able to make a association, relation. That is unexplained variation divided by total variation is a non-determination. When it is explained variation divided by total variation is called as a determination. Now the Spearman rank correlation coefficient. Spearman rank correlation coefficient. This is to measure the ordinal association. Ordinal is indicating ranking. Nominal is a classification. Ordinal is an ranking, right, in the levels of measurement. So it's a relationship between the ranking of ordinal variables, that as first, second, third type of rankings will be given to the observation of a particulars. So here D is important. That is difference between the ranking of each term. And N is a number of paired observation. How to identify the correlation in case of Spearman rank correlation coefficient method? This is R is equal to 1 minus 6 into summation D square divided by N into N square minus 1. 1 minus 6 into summation D square. 6 into summation D square, which is a difference between the rank of each term whole square and that sum of that square also, multiplied with a 6, divided by number of paired observation into number of paired observation whole square minus 1. This is what we will be using for the Spearman rank correlation method. Next, concurrent deviation method, which is the last method of the correlation. Under this method, whatever the series x and y are to be studied for the correlation of each item of there is compared with the preceding term. Whatever the series x and series y are to be studied in the correlation, each of the item of the series compared with the preceding item, previous item. And if the value is more than the preceded, then it is assigned with a positive. If value is less than the preceding value, then it is negative. So when always comparing the one value with the preceding value, if it is more, positive sign; if it is less, negative sign will be assigned. So that's what a concurrent deviation method. It is simply deviating by comparing with the previous value. That is why concurrent deviation method for calculating the correlation. Now concurrent deviation correlation coefficient is equal to plus or minus under root plus or minus 2 into C. C means number of concurrent deviation are the positive signs in the product column, that is C, minus M, that is number of paired observation, whole divided by N, sorry, M, right? 2C minus M divided by M. M is a number of pair of observation. C is a number of concurrent deviation or a positive sign in the product column. Now in the 2020 question, there is another area of question. Sampling with replacement, sampling without replacement. This is actually related to a standard deviation. Now here we need to discuss over here only. Actually we can discuss this in the sampling, what should I say, probability part also, but let us discuss. I hope everybody is following by. If you are following, please do hit the like button and at least something say in the chat box. Here sampling with replacement, without replacement. What is with replacement? What is without replacement? Means average, arithmetic mean after each successive item is selected for the sample. Mean that after each successive item is selected for the sample, the item is replaced. The item is replaced into the population and may therefore selected again. After each successive item is selected for the sake of sampling, picking up the sample, that item is replaced back to the population and it will be selected again. That is what is sampling with replacement. You are selecting like this and going back again, keep it in the same place, selecting again. So that's total activity of selecting a sample with a replacement is nothing but you are selecting something from the by comparing with a mean successive item and you are selecting another one and replacing with that one. Sampling without replacement is nothing but sampling without replacement means after an item is selected for the sample, it is removed from the population. Here after selecting an item, it is replaced, and after even after selecting a sample, it will be removed from the population. Here we are not going to remove, here just we are going to replace. We will select into the sample and we'll keep it at the same place. Suppose by this is a book. This is a book is there. In this book, number of pages are suppose 50. Suppose 50. 50 pages, suppose I have taken these 3 pages. What I will do, these 3 pages I will select and count it in the sample and I will keep it the 3 pages as it is. Now the book is as it is, I haven't done anything. Otherwise, sampling without replacement is nothing but if I selected 3 papers into a sample, I will cut it down these 3 papers like this and throw it out like this. This is what we call it as an sampling without replacement. Once we selected, we will not keep it over there. We will remove that one and we will not select that one again. We will remove from there. That comes under the without replacement. Are you getting the difference of both? Without replacement, with replacement. This is a question which is asked in the any important pages got cut it down by me. Surprisingly, nothing. I teared the pages by here. I teared the pages now. Now we in case of with replacement, here mu x bar is equal to mu. In case of with replacement, without replacement, how the mean will be? Mean will, there is no flow, intentionally done that one. There is no flow, intentionally only done that one. So mean is equal to mu and here mean is equal to mu. Same. With or without replacement, mean is as it is. The difference will come in the variance and standard deviation. Here Variance is like standard deviation, means standard deviation square is equal, variance is equal standard deviation square. So standard deviation square x bar equal to standard deviation square divided by number of observation, n. Standard deviation square divided by n in case of with replacement. If it is without replacement, standard deviation square divided by n into capital N minus small n divided by capital N minus 1. Right? Capital N minus n divided by capital N minus 1. That's what a variance in case of without replacement, variance in case of with replacement. By 2020, match the following question. Don't forget. How the standard deviation in case of with replacement? Standard deviation. Variance is equal standard deviation square. Now the standard deviation is equal standard deviation. This is sigma. Sigma divided by under root n with replacement. And if it is standard deviation without replacement, sigma divided by under root n into under root n minus n divided by n minus 1. That's it. If you remember this one, it will be enough. Now the 2020 question, can you please identify? When sampling is done without replacement, then the standard error of the mean without replacement. Option B is the correct answer. Absolutely. Just now we have done without replacement is nothing but something root will come or something extra will be there other than that. So standard deviation divided by under root n is n with replacement. Without replacement is nothing but under root n in n minus n divided by n minus 1. Everybody answered, That's what the conceptual understand. Now which one of the following is a false statement? The signs of regression coefficients are always same. Acha, this is advanced question. Okay. False statement. Chalo. Answer. You can answer it. Whatever covered, we have made it over here. Correlation coefficient is the geometric mean of the two regression coefficient under root of bxy into byx. The covariance between the two variables is divided by the product of their standard deviation produces the value of the coefficient of correlation. I think under root bracket, root or bracket. I will be discussing a covariance separately. Option D, because correlation coefficient is independent of origin as well as scale, both. Independent of origin as well as scale, both. This is not correct. False statement. If two regression coefficient are 0.8 and 0.2, what is the value of correlation? Do we need to calculate the regression anything? No need. With the correlation coefficient formula property, you can calculate. I hope everybody hit the like button. Under root 0.8 into 0.2. What is that? 0.16, which is equal to 0.4. But it is plus 0.4 or minus 0.4? Plus 0.4, because see, 0.8 into 0.2, 0.4 will come. There is a very high inverse relationship between the measures of overweight and life expectancy. Which one of the following correlation coefficient? Very high inverse relationship. High negative correlation. High degree of negative correlation. Yes, bxy into byx under root. High negative is nothing but negative value should be higher by simply. Here D is the correct answer. Relationship between the overrate and life expectancy is inverse. They are only saying very high. Coefficient of correlation is negative. But the strength is very strong. When the very strong is indicating highly negative in nature, that is minus 80. If it is only low degree of negative correlation, minus 20 will come. That is negative is very clear. Highly, very high inverse means only inverse they mention. Now we can understand that as normal low, which is minus 20. Are them as they mentioned a very high means high degree of a negative correlation, that is minus 0.80. Which of the following formula used to calculate the probable error of a correlation coefficient between the two variables of n pairs of observation? Yes, minus 20 is greater than minus 80. 9 I by, don't go in that way. Don't go in that way. I think you are calculating in the mathematical point of view. This is a relationship point of view. Please go, don't go in that way. So here option A is the correct answer. 0.6745 into 0.6745 into 1 minus r square divided by n. Achha, under root n, na? You forgot, right? Under root n it must be. Under root is missing. Wait. The question number, what is the question number? Question number, okay. Probable error question. Probable. It must be an under root below. The absolute value of a difference between an unbiased estimate based on a randomly selected representative sample and a corresponding population parameter is known as sampling error. Coefficient of correlation is independent of change of origin and the scale of measurement. Fast. Regression also we need to start. Time is moving. Option A, both the statements are correct because this is a sampling error perfect. Just now in the afternoon session we discussed in the research aptitude part. Sampling error definitions that is given, and the property of coefficient of correlation is very clearly given, independent of both origin as well as scale. If the dependent variable increases as the independent variable increases in estimating equation, the correlation coefficient will be in the range. Independent variable is increasing, because of that only dependent variable is increasing. Both are moving in the same direction. When both are moving in the same direction, what we call that one? Positive correlation. So it lies between what? Positive correlation. Same direction is in supply curve. It is option D. 0 to 1, because all the options 3 are negative also there. Only one positive only there, which is 0 to 1. Call Pearson coefficient of correlation between the two variables is. So square root of the two regression coefficient byx into bxy, that is the geometric mean of the two regression coefficient. Maximum value of the correlation is 1, 2, 3, 0. It is option A is the correct answer. Maximum value of correlation is only 1 because -1 to +1 will be there by very well known property it is. Maximum value is +1. That's it. Spaceman method is a method of calculating correlation coefficient by Francis Galton, Carl Pearson, Lorentz and Charles Spaceman. Charles Spaceman is the correct answer because name itself is indicating that's a Spaceman correlation coefficient. If the value of coefficient of determination is 0.6.4, then what is the value of coefficient of correlation? R square is equal, coefficient of determination is square of the correlation. That is equal to 0.64. Then what is the value of the R? R is equal to 0.64 under root, which is equal to 0.08. Sorry, 0.64 means 0.8 will come, not 0.8. It is 0.8 only. 8 8 is 64. No? 0.8 will come, not 0.8. Option B. R square is the determination. Non-determination is 1 minus R square. If bxy is 0.25 and byx is 0.64, then correlation coefficient is what is the property of the correlation coefficient? Correlation coefficient is equal to under root of regression coefficient of x, bxy and byx. Geometric mean of two regression coefficient is equal to correlation coefficient. That is bxy into byx, which is equal to under root 0.25 into 0.64. How much it will be? 0.25 into 0.64. 0.25 is an 0.5 and 0.64 is an 0.8. Both are 8 5s are. 0.25 square root is 0.5. 0.64 square root is 0.8. And 8 5s are 40. So 0.40 is the correct answer, I believe. Correct. If all points of a scatter diagram lie on the straight line falling from left upper corner to the right bottom corner. Left upper corner to the right bottom corner. Downward. Zero correlation. High degree positive correlation, perfect negative correlation, as well as perfect positive correlation. Straight line. Via straight line falling from the left upper to right bottom. Demand curve or supply curve. First you decide that one. Later you will understand. It's a negative correlation, not a positive. I have clearly drawn a diagram now. Bhai. It's an inverse correlation because starting from the left upper over here and to the right bottom means moving from left to right bottom, which is a demand curve, negative relationship. High degree of a positive correlation is availability of the sunlight. Between the availability of sunlight and weight of the people is meaningless, spurious nonsense. It's a confirmed answer actually. Sunlight availability and weight of the people. So all are giving a same meaning. It's a meaningless, no comparison between the sunlight and weight of the people. Spurious, unwanted relationship. Meaningless, no meaning to that relationship. If coefficient of correlation is more than dash of the PE, then correlation is significant. when the correlation is said to be a significant. When the correlation is said to be a significant. Guys, do hit the like button, share it with your friends. 6 times, when the correlation coefficient is 6 times of the probability error, then that is called as a significant correlation. 6 times it is. Option number D. Correlation coefficient explains concentration, dispersion, asymmetry relation. Good. Now you became expert of the correlation. Each and every point covered in the questions also, which I explained, which we discussed, all points covered. Carefully see. It's a relation. It is explaining a relation. Correlation is explaining a relation. Option D. Numerical measure of the correlation is called as an coefficient of correlation, coefficient of determination, coefficient of non-determination, coefficient of regression. Option number A is a correct answer because numerical only one measure is there, that is coefficient of correlation. Simple. Correlation coefficient probable error is equal to 0.6745 into standard error. Yes, standard error into 0.6745. Option C. In unexplained variation between the variable x and variable y is 36%. Unexplained is 36. Then what is the coefficient of correlation between the variables? Unexplained is 36. Then what is explained? What is explained will give you determination. Upon that correlation we want. Carefully understand the question. They are not asking direct question. What is explained variation? It's a non-determination. 1 minus r square given as an 36%. Moreover, r square we can able to identify. We want r in the question. We want only r. We want only r. Carefully observe, I am saying again and again. Explained variation divided by the total variation. Explained variation is an 64% divided by total variation. This will give you r square, which is equal to 64%. Because explained is nothing but if 36 is unexplained, then remaining 64 is explained. Then r is equal to 0.8 will come. Excellent question it is. Such a nice question. Simply, without even touching the neck, it is cutting. Total conceptual. Option D. Explained is r square. Unexplained is 1 minus r square. That is determination, non-determination. Correlation is only r. Graph of variables having a linear relationship will be. Overconfident, huh? Happens. We have to make a mistake in the class. Then only it will be in the exam hall good. So graph of variables having a linear is nothing but a straight line by. Which of the following is not correct about the properties of correlation coefficient? Depends on the origin. 2020 question. Option number C is the correct answer, that is A, B, C. are the false statement. These three are false statement. Depends, depends, depends. Outrightly eliminate. Wherever independent, check that only. Because correlation is not dealing with a dependence. It is dealing with the independence. Independence with respect to origin as well as scale. Both multiplication, division and subtraction, addition, all will be independent of effect of correlation. That is C and D correct, remaining 3 part. First 1, 2, 3 are wrong. So here simply it will be giving us about a cause and effect relationship will be there. In the regression, it's a statistical modeling and set of statistical process estimating the relationship between the dependent and one or more independent variable will be there. That is either a single variable which is an independent variable or multiple independent variables will be there which is showing an impact on the other variable. And I'm saying like there is a damn sure one variable is known variable, another known is unknown variable will be there. Suppose if I put the advertisement expenditure of a 3 lakh rupees, how much sales I am going to get it? How much sales I am going to get it? 3 lakh of advertisement is my independent variable. To know the effect on the dependent variable, that is sales. To know the effect on the dependent variable, this is a cause and effect relationship will be there. Dependent independent variables will be placing a major role in the regression analysis, right? That is the first point. And this was coined by whom? This was coined by Francis Galton. Francis Galton determined the both nature and strength of a relationship is called as a regression, was given by the Francis Galton. Now let me take you through with the one by one property which will be giving you total full clarity. Same properties which I have written in my own notes now, the same property with a good example I am going to tell you by. Property number 1 first. What is the property number 1? What is the property number 1? Before the properties, let me tell you about the regression equation. I think regression equation I have a slide by. Wait. I have a slide. Why to write unnecessarily? This slide is there. This line of a regression is most important. Line of a regression. Line of a regression, there are two types in the line of a regression. When y is dependent on the x and when x is dependent on the y. When the y is dependent on the x and x is dependent on the y. Here it is used to calculate the y for a given x slope. For a given x slope, we need to identify the we need to calculate the y for a given x slope. That is equal to, like you can see, this b is an regression coefficient and byx is equal to by is dependent on x. Means we need to identify the y which is depending on the x. So y on x formula will be y on x formula and x on y formula. Y on x formula will be y is equal to a plus bx. Y is equal to a plus bx. Simply y is equal to a plus bx. Whereas x on y formula will be, here we need to calculate the x which is depending upon the y. Here the formula will be x on y formula. X is equal to a plus by. X is equal to a plus by. This whether it is a, whatever the a is there na, a and a in the both of the formula, that is what we call it as a constant intercept. What we call that as a constant intercept. So by on x is equal to a plus bx, byx, and this is denoted by bxy. Byx is equal to y a plus bx. That is y is equal to a plus bx. Y is called as a dependent variable in the first situation and x is called as a dependent variable in the second situation. Whereas x is called as an independent variable in the first situation, y is an independent variable in the second situation. So by on x and bx on y. Did you got the formulas for this y on x and x on y? Y on x and x on y. Very simple to identify. So by on x is indicating there is a regression coefficient of y which is depending upon the x. There is a regression coefficient on x which is depending upon the y. Simple to recognize. And whatever the b is there now, that is b is a slope of the line. Y is a dependent variable in the first, X is a dependent variable in the second, and X is an independent variable in the first, Y is an independent variable in the second, and the B is a slope, A is a constant intercept. A is a constant intercept. Simple representation of the formula. Nothing more, nothing less. Same thing they will ask. Same thing they will ask. There are types of regression by. That is simple linear regression, multiple linear regression, normal linear regression as well as non-linear regression, partial regression as well as total regression. Now simple regression is about studying only two variables. Here only two variables at a time will be involved. One dependent, one independent. Like relationship between the income and expenditure. How your income will be deciding the expenditure. How the expenditure is going to like expenditure to income will not be there, but income to expenditure will be there. Pakka. Right? Now next is that multiple regression is nothing but more than two variables. At least a minimum three variables are necessary. Minimum three variables are necessary over here. So one is dependent variable, other can be an independent variable. Multiple independent variables will be there, but only single dependent variable will be. Now linear regression is nothing but when one variable changes with the other variable, some fixed ratio, that is what we call it as a linear regression, which is depicted in the graph by mean of a straight line. With a straight line, linear regression can be shown. Whereas a non-linear regression is on the contrary, when one variable with the other variable in a changing ratio. On the contrary, when one variable varies with another variable in a changing ratio. It is not changing same. One variable is changing is 10%, another variable is another percentage. Like that, it does not have following a linearity. Linearity is not there. That is, wherever the linearity means a fixed ratio, like a 10%, both. Whereas non-linear means 10% and 30%, 30% and 50%. This is improper proportion is a non-linear, a proper proportion is a fixed proportion is a linear, right? Next, a partial correlation is an when two or more variables are studied for a functional relationship, but at a time relationship between the only two variables are studied, other variables are keeping constant. Simply partial regression is nothing but this is speaking about we will establish a relationship between the variables. But the relationship between only two variables we will study first. Remaining variables will keep it constant. That's what a partial. Only half of the regression we are doing, not full. Next, a total regression means whatever the variables which are involved in the study, everything is going to be included in the study at a time. That is a total regression, simply. Now let's go ahead towards the properties of a regression. Property number 1. Property number 1. Before going for the property, let me tell you about covariance. In the correlation, I forgot to discuss this concept. That is covariation I didn't discuss because I have to tell this covariation. Otherwise, it will be going ulta. Covariation we need to understand. Otherwise, it will be creating a complex in the understanding of the regression. Covariation is very simple by. Partial is only half of the study by, not full study. Covariation is like when one variable are associated with the changes in the second variable. Means a dependency of a one variable with another variable is there. That's an covariance. So how the formula will be? Here there are a positive covariance and negative covariance will be there. Positive covariance and negative covariance will be there. What is positive covariance? When the variables are moves together. Isn't positive covariance. Negative covariance is nothing but when the variables are moves in opposite direction. Opposite direction. When the variables are moving in opposite direction, these are called as an negative covariance. Positive covariance, negative covariance. Negative covariance. This covariance is telling about how one variable is associated with the other variable. That comes under here. Next, this covariance of x and y formula will be summation of x1 minus mean multiplied by y1 minus y bar mean, y mean, x mean and y mean, summation, whole divided by n, whole divided by n, whole divided by n. Simple formula. This is the deviation or a variance from the mean of a one variable and other variable, and how they are related, how they are related to each other. One variable, this is a first variable, this is a second variable, and the mean is that x bar and y bar of that particular variables, and the second variable is mean is that y bar. So divided by, whole divided by their multiplication, difference of multiplication divided by n is an covariance. Here there is a PYQ which I can solve it just for you. We need to identify the covariance. Covariance is a question. Okay, the question is that sigma x is given as an 55, whereas summation x is given as 55, summation y is given as 74, summation xy given as an 411, and n is equal 10 is given. We need to identify. But whenever you are studying this x bar, x bar is equal to what? Summation x total divided by n. This we know very well. Y bar is equal to summation y divided by n. This we know very well. Now we need to identify the covariance. Can we identify the covariance for this question? Please identify the covariance for this question. Summation x divided, the formula will be summation x minus x bar into y minus y bar divided by n. Can you write the same formula in this way? Summation x y divided by n. Simplification of the above covariance formula I am writing. This covariance formula simplification, same covariance. Summation x divided by n, which is a mean of x bar, this is an x bar, and summation y divided by n, this is an mean of y, which is an y bar. Right? Now can you apply this? Please apply this. Yes, apply this. How much it will come? What is the summation xy given? 411 given, right? (411), which is an n10, minus sigma x divided by n is how much? Sigma x divided by n. Sigma x is an 55 divided by 10, and sigma y is an 74 divided by 10. How much it is coming? Can you please tell? This is 41.1 and 5.5 into 7.4. How much it is equal to? 41.1 minus 5.5 into 7.4. How much it is total? Total, can you please tell? Covariance is equal to. Whether this board is good and Microsoft Edge is good. Which is good to write it and explain? Can you give the feedback about that? Guys, do hit the like button if you like the session. So the total is coming as 0.4. Exactly 0.4. Vishwa, correct. Super Vishwa. 0.4 is the answer. 0.4 is the answer. That's it. This is the calculation. Simple. It's a derivation of the above formula or not. Summation x minus x bar into summation y minus y bar. That's I simplified into summation xy divided by n minus summation x divided by n into summation y divided by n, which is a mean of the x, mean of the y. Simple calculation, there is nothing. In the exam also it will be like this. Now, properties. Property number 1. Property number 1 are the characteristics of a regression. Characteristics of a regression. First characteristic is that, are the properties that R is, regression is ranging from -1 to +1, correct? -1 to +1 will be there. This one is good, okay. -1 to +1. It can be a +1 or equal to or else more than -1 also. It can be, but till the -1 only it will be there. -1 to +1 it will be there. Next, second is that correlation. Most important property is this one only. Correlation coefficient is an independent of a change as well as independent change of a scale also. Independent of a change of origin as well as scale. Whereas regression is an why wait. Very sorry. I was seeing the slide of the correlation. That's why I got a doubt already. Here regression coefficient and correlation coefficient have same sign, right? That is the first property. And coefficient of correlation is an geometric mean of the regression coefficient. This I have studied, this I have explained in there also, and here also I am explaining. In the correlation property also this is there. That is under root of bxy into byx, which is r equal to. And third property is like, if one of the regression coefficient is greater than the unity, other must be less than the unity. If one regression coefficient is greater than the unity, then other should be less than unity. If one is greater than unity, greater than 1 means other must be less than 1, because it must not be more than 2. Next is that fourth property, which is most important property, the regression, which I am writing in a different color also. Yes, if one is greater than 1, other must be less than 1. The regression coefficient are independent of change, but independent of change of origin. This is but dependent of scale, right? Independent of the change of origin but dependent of the scale. Scale is indicating what, and this origin is indicating. Origin is nothing but a plus or minus only, addition and subtraction, whereas scale is indicating multiplication as well as division. Multiplication. So multiplication and division is impacting the regression, whereas it won't impact on the correlation. Regression coefficient is affected by the multiplication and division, whereas regression coefficient is not affected by the addition and subtraction. That's what the meaning of the independent of origin and dependent of the scale. And next, the fifth point is that origin plus minus multiplication and division are scale. Arithmetic mean of the both of the coefficient of correlation is equal to greater than the coefficient of correlation. Look at arithmetic means both of the regression coefficient arithmetic mean byx plus bxy. This is the divided by 2. This is the arithmetic mean of the regression coefficient. This is more than or equal to r only. Means arithmetic mean of the both regression coefficient of correlation is equal to or greater than the coefficient of correlation only. This is a coefficient of correlation, right? Coefficient of correlation. Arithmetic mean of the regression coefficient are more than or equal to. It must not be less than the correlation coefficient. It will be equal to the correlation coefficient or more than the correlation coefficient, but it is not less than the correlation coefficient, right? Next, the sixth property is that these are the 5 main properties by. That's it actually. Now, if I can discuss the some more regression coefficient in terms of the deviation. Regression coefficient in terms of the deviation. In terms of a deviation of x and y, values from the respective mean. I hope handwriting is properly visible to you and understandable to you. I am not troubling you much in this session because just only regression properties are remaining. I can't able to make the properties in the slide, don't have a time, but I will give you in the PDF form for sure. So here regression coefficient in terms of a deviation, wise. In terms of a deviation of x and y value from the respective mean is that byx. Most important, very carefully see. Summation of xy divided by summation x square. So the x which is coming later will be n square in the denominator. In the same way, bx and y is equal to summation xy divided by summation y square. So same way here also, which is later and denominator will come over. Now you tell me whether x is in the first case byx, y is dependent on the x, means x is an independent variable. Independent variable comes in the denominator always. So that is summation xy divided by summation x square, summation xy divided by summation y square, right? This formula as it is they have copy pasted. This formula they have as it is copy pasted, and they will ask you in the math the following, or they can put you in the questioning form also. They can put you the problematic question also. Next is that regression coefficient. This is in terms of the deviation. Now I am going to tell you in terms of the standard deviation of the x and standard deviation of the y. Standard deviation of the x and standard deviation of the y. Same regression coefficient in terms of a r, comma, standard deviation, which is denoted by this one sigma, and standard deviation of x, standard deviation of y. That is, standard deviation is nothing but standard deviation of x and standard deviation of y. Independent variable will be the denominator in the deviations case. Whereas now in terms of the r as well as standard deviation, if you look at r is equal, not visible, I think. Okay. R is equal to covariance of x comma y. They will give in the question if they wanted to ask the question in this way. Covariance of x divided by standard deviation x into standard deviation y. Right? Based on this question, based on this formula, now if you wanted to go b y on x, b x on y, b y on x and b x on y. B y on x is equal to r into sigma x divided by sigma y. B1 sorry, sigma y divided by sigma x na ulta. Sigma y divided by sigma x because independent variable in the denominator. Now r into sigma x divided by sigma y. Sigma x into sigma x divided by sigma y. R into. So this is regression coefficient in terms of a standard deviation and r is involved. But here we know very well like bxy into byx. Byx is equal to r square which is an regression square or else correlation square, sorry, these are correlation coefficient of determination we can say. Now based on that formula we can also write in this way. What is the bxy formula? Bxy formula is that r into sigma y divided by sigma x multiplied by r into sigma x divided by sigma y, right? Like this we can write. Now x and x cancel, y and y cancel. What is left over? R square. We got it now, coefficient of determination or the correlation we got it. If not coefficient of relation, if you convert that into a root, that will become correlation coefficient. Simple, it's a derivation from then and there only. It's a derivation. Now you know r is equal to under root of bxy into byx. How the derivation came? This is how the derivation came over there. The property number 2 which we discussed now in the correlation as regression. The property number 2 derivation is in this way. That's why we are saying correlation coefficient is equal to under root of the regression coefficient of both. Is that clear? Now with this I am putting an end to correlation. Almost I have covered all the important points from the examination perspective. None of the point is ignored. But there is a one slight point I wanted to cover over here which I have given in the first slide now. Over here. You can just look into these statements which are mentioned over here. Clear? Done. Thank you. I hope everybody hitting the like button. Those who didn't. One big formula is there by which we have already. These are the regression lines. Correct now? Regression lines. In this y is equal to a plus bx and x is equal to a plus by is there. That's two formulas which we learned. But I can write this y is equal to a plus bx formula as y minus y bar equal to byx into x minus x bar. This is for the byx formula. Alternative formula for the same linear equation. Y minus y bar is equal to byx into x minus x bar. Whereas alternative formula for this is x minus x bar equal to bx on y multiplied by y minus y bar. Sometimes they may give a alternative formulas to confuse you. So the same derivation will be comes over here. Either this can be a c plus dy, this can be a c plus dy or a plus bx. This can also be written as an c plus dy. In such a case, a and c are called as an constant intercept, and b and c, d are called as an independent variables, and y and x are called as an dependent variables. Either way you can write it. That's an alternative way of writing a formula simply. Now a final one which I just wanted to give you the formula is that there is a one final formula. These are all formulas only, but questioning of a problematic application will be very much less, but the properties they can put you under the assertion, reasoning, statement, as the following. It can be of anything. Byx formula, bxy formula. Again, Big formula it is. Number of variables into summation x y minus summation x into summation y. Okay. This is divided by n into summation x square minus summation x whole square. Right? This is the formula. Remember this one. N into summation xy minus summation x into summation y. Now this is x now over here. Independent variable x square. Which independent variable always will comes in the denominator only. Remember that blind rule. Now how can I write this one? N into same numerator xy minus sigma x summation y whole divided by n into summation y square. This is of x square now. This is of y square minus summation. What will come? Can you please tell? What will come? Summation y square will come because this is independent variable. Y is an independent variable over here. That's it, bye. This is the end of the regression. Now we can move like anything towards a next. Now no book is required, no slides only. We can move ahead. Everybody understood with this? Let me recap once. Let me go to the first slide so that you can understand in a very easier manner. It is denoted by B. Yes, sir. Denoted by B. And if two variables x and y are the two values of regression coefficients obtained, and one will be independent, one will be dependent value. We consider y as an independent and x as a dependent usually. So regression coefficient is denoted by byx and bxy. Both regression coefficient must be having a same or a positive, either a negative. In the same way it has to be there. If one regression coefficient is greater than the unity, other will be with less than the unity. And the geometric mean between the two regression coefficient is equal to correlation coefficient, that is under root of the bxy into byx. And the arithmetic mean of the both regression coefficient is equal to, greater than or equal to only, but it must not be less than to correlation. This is what discussed so far. And covariance formula, two formulas are there: summation x minus x bar into y minus y bar divided by n, and or else summation xy divided by n minus summation x divided by n into summation y divided by n. After that, geometric mean, and it must be having a same sign. All these and the regression coefficient is independent of change of origin, not of a scale, because it is dependent on the scale. That is, dependent on the scale is nothing but it is impacted by the multiplication and division. It is not impacted by the subtraction and addition. Next, covariance in terms of the deviation. So regression coefficient in terms of a deviation x and y. That is, byx is equal to summation xy divided by x square, summation x square. Bxy is equal to summation xy divided by summation y square. And in terms of a standard deviation, covariance of xy divided by standard deviation x into standard deviation y. After that, byx is equal to r into standard deviation y by x, and bxy r into standard deviation x by y. Then if you get the like total derivation of the under root of bxy, then please multiply this both, you will get r square, which is under root of the r equal to under root of the bxy into byx. This is the end of the regression. I hope I am clear. Now let's see the difference between the both. By correlation is a statistical correlation, means the association it will be giving you, whereas regression is an independent and dependent, means a cause and effect will be revealed by the regression analysis. It is to represent the linear relationship between the two variables, means association. Here, to fit a best line, whether it is one variable on the basis of other variable, what will be the best line? And no difference between the dependent and independent variable. There is no dependent because both are independent over there. Independent of origin, independent of a scale. Whereas here, both independent and dependent variable are different, and it is independent of origin but dependent on the scale. So here indicates to what extent to which two variables are moved together in the same way. Like move together is nothing but that is an association established. Whereas impact of a unit change in one variable, how it is going to change in the other variable, whether it is going in the same direction, whether it is going the opposite direction, that's an regression. And finding a numerical value expressing a relationship is a correlation. Whereas to estimating the value of a unknown variable identification. We know with a one variable, we are trying to identify the unknown variable by the help of a regression. And here limited application, whereas this is a wider application will be there. This is a clear-cut difference. Now, final summary note I am giving till now, whatever the discussion so far, whether it is a mean, median, mode, range, mean deviation, standard deviation, correlation coefficient, regression coefficient. Look at everything, only correlation coefficient, regression coefficient slightly differs. Mean, median, mode are three measures of a central tendency. These are impacted by the origin, means plus as well as minus. Because of the plus sign minus, it will be impacted, whereas multiplication and division also, it is dependent on the scale also. Multiplication, division is also impacting on the measures of central tendency, right? Measures of central tendency impacted by the origin as well as the scale. Next, range is independent of origin. Range, mean deviation, standard deviation. Range, mean deviation, standard deviation are not impacted by the addition and subtraction, but impacted by the multiplication and division. That is plus independent of origin but dependent of a scale. Independent of origin but dependent of a scale. That is range, mean deviation, standard deviation. Now look at the correlation coefficient. Out of all, only hero is looking like it is independent of a origin as well as independent of a scale. Both it is. And regression coefficient is an independent of a origin like dispersion only, which is a range, a mean deviation, standard deviation, and dependent of a scale like a dispersion. So measures of central tendency is an independent of origin and scale, dependent of origin and scale, whereas dispersion, that is range, mean deviation, standard deviation, is independent of origin and dependent of the scale. Even regression coefficient also. Correlation coefficient alone is an independent of the both. So important note is that only correlation is the only measure which is independent of both origin as well as the scale. Am I clear? Can I move ahead towards the question solving? Can you please give me the answer for this question? Fadafat. Summary table. How is the summary table? So option C is the correct answer because they are asking about the false statement. False statement means both correlation regressions have a same sign. Absolutely correct. And arithmetic mean of a regression coefficient is always more than. That's what just now discussed. Regression coefficient is independent of both origin and scale. This is correlation, not a regression. Wrong. Correlation coefficient is the square root of the two regression coefficient. It is correct only. If two regression lines are as under, y is equal to a plus bx and x is equal to c plus dy, then what are the variables of x and y is called? So what is the correlation between the correlation coefficient between the x and y? Working really hard. Huh? I am expecting JRF. That is why I want the JRF of all. At any case, I want it. That is what hardly I am expecting. D is the correct answer under root of B and D. Because why B and D? Independent variable. Look at geometric mean of a two regression coefficients are equal to B xy into B. yx, that is under root of b into d only. That is under root of b into d only. This is b xy and b yx. Option D. If regression coefficient of x on y is greater than the 1 and regression coefficient of y on x is less than 1, then geometric mean between the two regression coefficient is a coefficient of correlation. On the basis of above, choose the appropriate answer. What is the correct? Super question. Exclude me. Okay. When the others are going in one direction, you will go in other direction, no? So, okay, no problem. Both are correct. Why? This is a property. This is also property. Just now discussed. Just check back and go back. You will get it. Regression of the x on y. Then the variable of y is known as. The regression of x line is x on y. Then the y is known as independent variable, dependent variable, none of the above, all of the above. This is an independent variable because b x on y means y is an independent variable, x is an dependent variable. Okay. Next, if the regression x on y, y is known as. Acha, question repeated, huh? No. Same question got asked in the PYQ. That is why. Not repeated. Regression line is x on y, then y variable is known as. Options are different by. Question is same. Option A. Okay, very good. Everybody under the trap. Option D is the correct answer. Option D is the correct answer because it is independent variable is also known as explanatory, which is trying to explain the reason, that is a cause, and that is also called as a regressor. That is also called as a regressor. If r is equal to 1, angle between the two regression line is. Acha, I forgot to explain this point by. Okay. Anyway, I will add it now. You answer this question. If there is a perfect positive or perfect negative correlation, that is r equal to 1 is given, then how it is? What will be the degree? Is it a 90 degree or 45 degree or 180 degree or 0 degree? It will be a 0 degree. That is what we call it as an coincide. There is a one property which I need to add it. Wait by. There is a one property which I add it over here in the property slide. Eighth property. In case of correlation, in case of perfect correlation, either it is a perfect positive correlation or perfect negative correlation, then two regression lines will be coincide. That is equal to 0 degree. It will be lying on the same line. 0 degree. R equal to 1, or it is a perfect positive correlation or perfect negative correlation is then 0 degree, right? That's it. Good evening, Shivanshi. Too early, Shivanshi. Very good, nice, excellent. Next question, regression coefficient is independent of change of scale, origin, and both scale and origin neither scale. This is a 2020 question, I believe. ये कब start हुआ? Morning start हुआ till the evening 7:30 AM. I am teaching live only statistics. Where you are sleeping? The regression coefficient is independent of the change of scale, change of origin, both scale and origin, neither scale nor origin. Option B is the correct answer. B is the correct answer. That is, its origin only, not of scale. Now, enter भैया. अब तो आ गया. Probability distribution, discrete series, continuous series, binomial distribution, Poisson distribution, normal distribution, most important part, and the pakka and the properties of these three distributions only question is going to hit. Right? Question is going to hit on these properties only. Let's see. There are two types of series by. Usually a discrete series as well as continuous series, right? Continuous series is nothing but where frequency intervals will be there. Right? Now here single variables will be involved. To the point, from the examination perspective, I will tell you, you will enjoy like anything the entire properties of 3. Within fraction of 15 minutes, I will complete the 3. Look at. Binomial distribution is nothing but, it will give you what? It will tell you either a success or a failure of an outcome in an experiment survey that is repeated for a multiple times. Like binomial distribution can be thought as simply a probability of a success or a probability of a failure in an experiment. Outcome is definite, outcome is going to come, either a success or a failure. Look at the example. By means a twice, means a double, multiple times, right? For example, coin is tossed like this. Possible outcome can be either it can be head or it can be tails. And taking the test could have two possible outcome, either a pass or a fail, or a success or a fail. It can be of anything, right? So the two chances are very clear and equal chance of being occurred is there. Very clear, equal chance. Now look at the properties. From this slide, there is a damn sure question which is going to be there in your pocket. 100% you can expect from here this question, this slide only the question will come. Please do not deviate and do not get disturbed by any of the unknown like unnecessary chart in the chat box. Just concentrate on the slide very carefully for the next 10 minutes. Look at number of trials should be very finite. Yes, number of trials are very finite. Whereas large number of trials also can happen, but finite. It is not indefinite trials are going to happen. Finite trials, 1 time, 2 time, success or failure. How many times you will make it? Infinite, not now. It is finite. Trial should be independent. First trial, second trial, there is no link. It both are independent in nature. There is no link and impact of both. And each trial is having only 2 possibilities. Every trial is only 2 possibilities. Success or a failure. Head or a tail. That's it. So sum of the probability in the binomial distribution, probability of a success plus probability of a failure is equal to 1. Probability of a success, that is P, denoted by the P. Probability of a failure denoted by the Q, which is equal to 1. Then can I say Q is equal to minus P, 1 minus P? Yes. Failure is equal to 1 minus success. Success is equal to 1 minus failure. In that way we can write it. Next, probability of outcome remains same in every trial because either a head or a tail. outcome, one will be one side, one other will be other side. 50 percentage of chances, every probability in every trial same type of outcome will come. One is head, one is tail, right? Next is that for the binomial distribution, who is the hero for the binomial distribution? Mean. Mean is the hero of the binomial distribution. Mean as well as probability of a success are the parameters in the binomial distribution. Mean and probability of a success is the binomial distribution. Right? Now look at, that is why mean more than the variance. What is a mean formula? N into P. N into P is a mean formula which is more than the variance. Variance is equal to NPQ. Variance is equal to NPQ. So that is, I would say, NP is nothing but, N is what? What is N? Number of trials that we have taken. P is nothing but probability of a success. Number of trials into probability of success is equal to mean. Right? Number of trials into probability of success is called mean. And when it is supported, when it is multiplied by the failure also, that will become variance. When the mean is multiplied by the failure, that is Q, NPQ, that will become a variance. So mean, the probability of a success multiplied by the number of trials, will always be more than the variance, that is NPQ. Variance is equal to NPQ, mean is equal to NP. Now symmetry of the distribution, look at the symmetry. When the distribution is symmetrical, probability exactly is equal to 50%. How much? 50%. 1 by 2 or a half. Or half 1 by 2. 0.5 or 1 by 2. 50%. Symmetrical means in the middle exactly it will be. Like we know na, normal distribution. Like this. In the middle it will come exactly this portion. Here 0.5. Here 0.5. In that case, that is a symmetrical distribution, binomial. Whereas negatively skewed binomial distribution is nothing but, when it is negatively skewed, P will be more than 5, means right side. But here only it is different by negatively skewed more than like 0.5, this will be more than 0.5 means more than half is indicating negatively distribution, right? And first one is the equal distribution. Next, a positively distribution less than half. This is less than second, this left side. Rightly skewed negative and leftly skewed it is positive. That one. Next, a mean which is x bar is equal to, it is also written as a mu. Right? And it is also written as an NP. It is also written as a mu. X bar is equal to mu which is equal to NPQ. Which is equal to NPQ. And here standard deviation by variance is equal to square, right? And variance is equal to standard deviation square. That standard deviation square, variance is equal to NPQ, that we understood till now. Now standard deviation is equal to under root of NPQ or not? Obviously that will become, because square will become under root. That's it. These are the 9 properties which are repeated again and again, right? Again and again. Now look at formula for the probability of binomial distribution. Formula will be probability is equal to NCR into probability power R, probability of success power R, into failure, probability of failure power N minus R. NCR into P power R into Q power N minus R. This factorial, NCR is indicating permutations related. How we can write that one? Permutation. Here N factorial divided by R factorial into N minus R factorial. How can we write? N factorial divided by R factorial into N minus R factorial into probability power R Q into Q power N minus R. Simply NCR can also be written in the way of a factorial. So what is this factorial actually? Suppose example is given 5 factorial. 5 factorial is nothing but 5 into 2 into 3 into 1. Sorry, 5 into 3 into 2 into 1. Where is the 4 went? Get numbers also. 5 factorial means 5, 4, 3, 2, 1. Both are different. Bernoulli, binomial. Bernoulli, yes, Bernoulli and binomial both are same. Here I think it is written in the first slide. This is also called as a Bernoulli distribution. Not written. No? Okay. So 5, 4, 3, 2, 1 divided by r factorial will come. R factorial, r is nothing but a number of success. That is actually you are expecting as a number of success. That comes under the r. R factorial, that is in the given question we need to write in. R factorial means that one. And n minus r factorial is nothing but from the total number of trials r we need to remove, and that factorial we need to write it. Suppose this r is an 3 factorial, which is 3 into 2 into 1. And n minus r factorial is an 2 into 1. So now n minus r factor, or total 10 minus 3 divided 3 by means a 7 factorial is an r, n minus r means a 7 into 6 into 5 into 4 into 1, like that we need to go. That comes under here. So with that will be multiplied. Actually practical area will not come, but remember the formula. Why to take a risk? Just remember the formula. Just remember the formula. Why to take a risk? Done. So here probability of r is equal to probability of a success. Probability of r is equal to probability of a success in n trials, and probability of p is equal to probability of success, and the probability of failure is n q. Number of success actually expected. Number of r is a number of success desired. Number of trials actually undertaken is an n. The symbol factorial is indicating computed as follows: 5, 4, 3, 2, 1. 5 factorial taken as an example. Right? 0 factorial is equal to 1. Next, a Poisson distribution. What is Poisson distribution? Poisson distribution. Here Poisson distribution was given by whom? Poisson distribution was given by French mathematician Simon Denis Poisson. Simon Denis Poisson, and very similar to binomial only almost. Here binomial distribution deals with where number of success and failures can be counted, but uncounted number of possibilities will come. In the Poisson, events occur continuously over a given sum of period. Here distance or space, while the Bernoulli process events occur in the context of a trials. Here some of the examples of Poisson distribution will be number of telephones received per hour. It can be anything. Large number of can be. Large number can be. Correct now. Large number. Large number of a telephone also, telephone calls also you can receive. And the number of fatal accidents per a week in a city, any number. And number of patients arriving at a health center per a day. And number of typing mistakes per page in a book. Number of cars arriving in at a toll booth per hour. So those are car arriving. Means at a toll how many number of cars are coming. So based on that we need to identify. Based on that identify. Why this is like simply we can say, can I say this is an infinite number of outcomes, large number of outcomes, infinite number. In a simple terms, large number of outcomes are there, many possibilities can occur in within a short period of time over one another. It will be having an infinite number of outcomes. Infinite number. It is not like a definite head and tail. It will be having a number of outcomes are infinite. It can be occur in a larger way. So let x be a Poisson random variable representing a number of outcomes. That is success in a given time. The probability of exactly r equal to is given as following formula as per the Poisson. So that is given in the 2020 examination. Probability of x, which is equal to r, that is a success that we are expecting, equal to e power minus lambda multiplied by lambda power r, which is the probability of success. Lambda power r means r is the probability of success, divided by r factorial. This is the simple formula. E is an Euler number. Euler number means the specific number is given by the Euler only. That very background reason is there why he given that one. So E value will be given in the question always. 2.71828 is an E value, exact E value. So that E value power lambda. Lambda is nothing but average number of outcomes occurring in a given, because we cannot able to calculate the exact one. That is why we'll take the average. So in the average only, when the infinite number is occurring, how can we able to identify? That is infinite. Number itself, outcome itself is infinite. That's why we are trying to identify the average outcome, not the exact accurate outcome. That is e power minus lambda, e power minus lambda into lambda power r, which is r is an exact number of success. Lambda can also be written as m, which is a mean. Lambda is a mean actually. Lambda can also be written as an NP, number of trials into probability of success. Lambda can also be written as over here in this standard deviation square, that is variance. It can also be written as an, in the binomial distribution, mean is equal to NP, variance is equal to NPQ. But here mean and variance both are equal. Mean equal to variance in case of a Poisson distribution. So the properties of Poisson distribution will be discrete probability distribution. First, number of success like a 0, 1, 2, 3, it will go on, keep on going only, which are given in a whole numbers, not in fraction. There is no 0.5, 0.25, those are will not be there, right? And value of the p value, success value is very less, because large number of infinite outcomes. Very small success will be there, that is 0. Even 0 success also can be possible. Q is high, failure is very lamba, because too much high population now, failure is very large, failure is highly large. It tends to be 1, it tends to 1, and n is infinitely large, n is infinitely large, n is infinitely large. So value of p is tend to be small, even 0 also. Value of a q is very large, even to 1 also. Next, main parameter. In case of a binomial distribution, main parameters were what? N and p, right? Sorry, mean and n and p are the parameters. Here main parameters is only one, that is np. Np, only one parameter, which is a lambda, that is a mean, and np is an probability of a success, which is probability of a success, and number of trials, which is an mean only. Main parameter is mean, is the main parameter. There mean as well as p are the main parameters. Here only mean. Next, constants of a probability distribution. Mean is equal to NP is equal to variance is equal to standard deviation square. All are equal. This is the most important property of the Poisson distribution, right? Now standard deviation is equal to under root of the NP. This is there in the binomial as well as Poisson, both. Next, a normal distribution. Normal distribution. This was given by the, initially normal distribution was introduced by the Abraham D. Movie in the year 1773. Later this was extended by the Laplace. Some days after, Carl Friedrich also extended in the Gauss. Friedrich also extended this, Carl Friedrich Gauss extended in the 1809. That is why this is also called as a Gaussian distribution. Gaussian distribution. Gaussian distribution, because Gauss is also there who extended. And this probability is fully, already we completed normal distribution in many of the times. This is speaking about a diagrammatic representation of the symmetry. Right? That is symmetry about the mean, showing that data near to the mean are more than the occurrence than the data far from the mean. Whether it is near to the mean or far from the mean, the proximity will be disclosed or revealed by the normal distribution. Normal distribution is applied when the number of trials are large and infinite. It is same as the case of a Poisson distribution, large as well as infinite. Number of trials are large and tend to infinite also. Neither P nor Q, none of the thing is very small or very big. Both are normal. Whereas in case of the Poisson distribution, P is very small, Q is very high. But here both are 50-50 percentage will be there. 50-50 percentage will be there. That's what. Now let's move into the normal distribution. Properties of normal distribution we know very well. That is more important. Properties only. Questioning area, seedha properties they will ask. Look at, it's a bell-shaped curve. Yes, it's a bell-shaped curve which is showing about the symmetry. This is a bell-shaped curve like this. You can see my shape is going out of the bell. So this is a bell-shaped curve and middle line will be there, which is dividing into two parts. This is a 0.5 and this is a 0.5, total 1. And middle one is called as an equal distribution, which is a symmetry, where mean, median, mode all are equal in the symmetry. And this is a rightly skewed and this is a leftly skewed. This rightly skewed is called as an asymptotic, whereas left is nothing but symmetrical side. These are half of the symmetry and half of the symmetry. This tail, whatever the tail which is coming now, which is not touching the x-axis, the curve it is slowly deeper is going now. That is what we call it as an asymptotic. I will explain over here. So it is bell shaped. Normal curve is a bell shaped and symmetrical about the vertical line through the mean, and it is a unimodal. Model means only one mode is available. Only single mode will be there. It tails extend to a infinity in both the direction, which is the curve is asymptotic to the x in both the direction. The curve is, now I was showing now that picture here, this is what x, it will not touch the x-axis because the curve is going like that only, like a railway track, but it will not touch the x-axis. It is same as like indifference curve only. Asymptotic to the x-axis is nothing but in the both the direction, whether it is this direction, left side, right side, in the both direction it will go, but it will never ever touch the x-axis. That's what the unimodal and asymptotic in nature. Whereas equality is indicating all the three measures of central tendency coincide, where mean, median, mode, all the three are equal in nature. And a range, the total area under the curve will give you the total probability of a random variable, taking the values between the -2 plus infinity. -2 plus infinity means here left side minus infinity to right side plus infinity. Like that, from that area to this area it will be moving. Total probability coverage -2 plus infinity. Right? Next, total area 50% on the left side, 50% on the right side. 50% on the left side and 50% on the right side. Next, equidistance of a quartile. 6th and 7th is most important. 6th and 7th. Look at equidistance quartile is nothing but Q1, Q3 are the equal distance from the median. The distance between the Q2 and Q1, which is second quartile to first quartile, which is a median. Second quartile is a median. And the same distance will also be there between the Q3 and Q2 also. Same distance, Q2 minus Q1 is having a same distance as equal to the Q3 minus Q2. Great, right click. Nice. Thank you so much for informing. So here Q2 minus Q1 is equal Q2 minus Q1, or Q2 minus Q1 is equal Q3 minus Q2, which is Q3 minus median equal to median minus Q1, which will give you the same equidistance quartile. From my place to your place is having a one distance, means your place to my place also same distance. That's what the same logic apply. Now the relationship of a normal distribution between the quartile deviation, mean deviation and standard deviation is equal to quartile deviation, mean deviation, standard deviation. Standard deviation is denoted by this one, sigma. Right? So mean deviation is equal to 4/5 of the standard deviation, whereas quartile deviation is equal to 2/3 of the standard deviation, or 5/6 of the mean deviation. By remember or by heart this one. I will give you the logic also behind it. It is given in the box, you can see. Mean deviation is equal to 4/5 of the standard deviation. Whereas that same quartile deviation also can be written in the way 2/3 of the standard deviation, or else quartile deviation can also be written as 5/6 of the mean deviation. Right? Now how this ratio will be working? Quartile deviation 2/3 of the standard deviation. Yes. And mean deviation, which is equal to 4/5 of the standard deviation, and another one is the standard deviation. every component converted into a standard deviation, and which standard deviation gets cancelled over here. Remaining left over 2 by 3 is to 4 by 5 is to 1. 2 by 3 is to 1, 4 by 5 is to 1. Then when it is multiplied by the, when you do the LCM, we need to make it the denominator equal or not. So in order to make the denominator equal, this 2 by 3 multiplied by 5, 4 by 5 multiplied by 3. In such a case, 2 by 3 multiplied by 5 means that will become 15. 3 into 5, 15, as well as 2 into 5 will be 10, and 4 by 5 multiplied by the 3. 4 into 3, 12, divided by 3 into divided by 5 into 3, which is equal to 15. That will become 12. Numerator will be 10 is to 12 is to, and remaining 1 will be divided by 15 and 15. That will be 15. So finally, if they ask the relation, what is the relation that we need to tell? The relation is that 10 is to 12 is to 15, quartile deviation, mean deviation, standard deviation. One way of asking question. Second way of asking question is that mean deviation is equal 4 by 5th of the standard deviation. Quartile deviation is equal 2 by 3rd of the standard deviation. This is, or else 5 by 6th of the mean deviation. Either way they can ask. QMS. QMS. Clear? Next, 7th or 8th property. For a normal distribution, coefficient of skewness is equal to 0 because thank you so much. Right click. Please do share it with your friends from Kerala. So share with your university friends also if anybody is there, so that I will also get motivated to do more and more as such. And do not forget to intimate if you get the JRF. My number is given in the WhatsApp. The Telegram link is given in the chat box, or else description. You can go through with that and join over there and stay tuned to till the result. After the result also you can. So here mean, median, mode are equal. Here is the place, and these two properties are going to be most important properties. Listen, skewness will be 0 because there is no skewness. Right and left skewness is not there. All are 0. That is why mean, mode, all are equal. The point of inflection of the normal distribution is denoted by x bar plus or minus standard deviation. So x bar plus or minus standard deviation is indicating a variable. Now look at carefully. X plus or minus, this is a mu, which is a mean, middle. Mu minus 1 standard deviation plus 1 standard deviation, like this. The area is this one. Mu minus 2 standard deviation plus 2 standard deviation, that is second area, which is at 95.44. Next, mean or a mu minus 3 standard deviation to plus 3 standard deviation, that is this area. So first minus 1 plus 1 standard deviation area is that 68.26% of area. This is the PYQ. I am repeating again and again, right? And mu minus 2 standard deviation to mu plus 2 standard deviation formula area covered is that 95.44% of the area. That is the second, moving from this place to this place. Next, minus 3 standard deviation to plus 3 standard deviation is that 99.74% of the area. Okay, this is the area is originates from the, this implies normal distribution. 68% of the observation lies between the minus and plus 1 standard deviation, and 95% lies between the minus 2 and plus 2 standard deviation, and 99% lies between the minus plus 3 standard deviation. So the result shows that practically range of distribution is 6 times, although theoretically it is ranges from minus infinity to plus infinity. It will be minus infinity to plus infinity, it will be there. This is the end of the distributions. 3 distributions. How it is? 3 distributions. Get done by. Questions, fatafat. Let's do the questions related to it, and we'll move forward. Next. What are the features of normal distribution? Mean equal to 0, standard deviation equal to 1. Mean equal to 1, standard deviation equal to 0. And mean equal to 0, standard deviation equal to 1. Mean equal to 1, standard deviation equal to 1. Which one, Rahul? Which one you are asking? Option A is the correct answer because mean is 0, mean, mode, median all are equal and standard deviation is equal to 1. A. Which one of the following? Which one of the following is the characteristics of normal distribution? A. That is bell shaped and symmetric characteristics. Remaining, these are unequal, wrong. Total area under the curve of probability not equal to 1. No, it is equal to. Two tails are touches, never touches it is. The 2020 question, the standard deviation of the binomial distribution. Very easy, standard deviation of the binomial distribution. Under root NPQ, option D. Next, Poisson distribution, please calculate by. What is the Poisson distribution formula? Poisson distribution formula, which I remember, e power minus lambda, which is lambda power r divided by r factorial. Now can you able to identify? Easily you can able to identify. Please identify. If on an average, 2 customers are arriving at shopping mall per minute. What is the probability that in a given minute, exactly 3 customers will arrive? 3 customers has to get it. Means the probability desired is that 3. Desired is that 3, which is a lambda. Sorry, r I think. After studying easier. No idea. Get idea, please. Calculate. Try by. I am giving a hint of the question also. It's a PYQ of 2020. You can't escape from here. How to calculate? One three five three. Lambda is equal to how much? 2 and 2 power 3. R factorial, which is 3 into 2 into 1. So can you give 0.1353 power 2? Two cube is equal to this is 2 into 2 into 2. 3 into 2 into 1. The remaining portion is this one. Okay. How much it is this? Can you please tell? 0.1353 power 2 minus 2. Acha, okay, very sorry, already given na. I am not looking, I am just applying the formula blindly. Okay, already given. Sorry, extremely sorry. So 0.1353 into 4 divided by 6 or else 4 divided by 3. How much? 2 to cancel, na? How much it is coming? 0.3532. Option number B. Sorry, point 1 is given 1/8. By how much it is coming by? You are telling 2 as an answer. I am thinking that this outcome is that one only. 8 by 6 are 4 by 3 same na bhai. 2 4s are 2 3s are. Point 1804. Okay. Next. Yes, good evening guys. Let's move ahead. What do you mean by probability? What actually the meaning of probability? Fatafat, please participate in the chat box so that I can also be getting motivated to complete as early as possible with a proper understanding and a clarity of understanding will be there while doing a questions and understanding a concept. In today's session, I am myself Vodnala Shivalingam will be covering up parametric, non-parametric will be covered, that is belong to Statistics chapter number 5 of the UGC NET Commerce. Is that clear, Miss or Mr. Vaishu? Yes, good evening guys. Probability means it is something likely. The name itself is indicating probable. Means something likely to happen, which is a probable or expected to happen. If you flip a coin like this, if you toss a coin like this, there is a probability like it can be a head, it can be an tail also. It can be a head and it can be an tail also. That is 50% chance are there for the head and 50% chance are there for the equal chance of getting head and tail is there. So now there is a 50 times of getting head and 50 times of getting tail also out of 100 possibilities. That means it can be anything. Anything can come. Probability of something which is going to happen or something which is not going to happen is called as a probability. Next, the probability of event lies in between the 0 to 1 only. Always remember this one, 0 to 1 only. There is no probability called as minus. There is no negative probability will be there. Acha, if I coin a toss, then minus 1 probability is going to happen. Nothing as such. Either it can be a 0, which means a failure, or it can be a 1, or it can be a 50, or it can be a 30%, it can be a 20, it can be a 0.2 also. But it is more than 0 or equal to 0, but it should not be less than 0. Is that clear? So that 1 is indicating surety of the event and 0 is indicating impossibility of an event. So sum of the all probabilities always 1 only. Sum of the all probabilities always 1 only. Suppose 50% is failure means 50% is success. This is equal to 100 means which is equal to 1. Which is equal to 1. So there are some terms related to probability. So first one is an experiment. First one is an experiment. What is that experiment meaning? When we conduct a trial to obtain some statistical information is called as an experiment. Like a tossing of coin to get the head and tail is called as an experiment. The tossing coin itself is an experiment. Whereas the events means the possible outcomes. That means possible outcomes of the trials are there. Now the trial or experiment, the outcome is going to get is called as an event. Events can be denoted by A, B, C, D like that. And after that, exhaustive events. What do you mean by exhaustive event? Total number of possible outcome of a trial or experiment are called as an exhaustive event. These are like in case of tossing a die or a coin. In case of tossing a die, there are 6 possibilities that 1, 2, 3, 4, 5, 6. These are called as an total possibilities of outcomes are called as an exhaustive. Total possible outcomes of a trial is called as an events. And total number of possible outcomes are called as an exhaustive events. Exhaustive events means in totality. Exhaustive means in totality. Events means which are going to happen. Next, events, likely events is nothing but, equally likely events is nothing but the chance of happening event is there for all the variables are there in the particular population. Every variable is having an equal chance of being selected in the sample, or else every variable in the population is having an equal chance of being likely to happen. That's what a equally likely events. Now, like a head and toss. In statistics, probability theory is having a two, that is mutually exclusive as well as non-mutually exclusive events. So what is this mutually exclusive events? If they cannot occur at the same time, the simplest example of a mutually exclusive is that it is coining a toss. A toss is coined, outcome can be a head, outcome can be a tail. Right? But both head and tail cannot occur at a time. Correct? That means mutually exclusive is indicating which cannot occur at a time, which is independent of each other. One of the probability, other probability is independent of each other. So that is denoted by probability of A or A or B is equal. That is A union B is equal probability of A plus probability of B. Next one, non-mutually exclusive is indicating the events which can happen or that can happen at the same time. Suppose driving and listening to the radio, even numbers and prime numbers on a die, both can happen at a time. Multitasking, that's what a non-mutually exclusive events, which are denoted in such a way. A or B, probability of A union B is equal probability of A plus probability of B minus probability of intersection. Intersection means a combination of both can happen. Both can happen at a time is called as an intersection. It is denoted by and. Union is indicated by or, either this or that. Whereas intersection is indicated by both are happening at a time. Right? So probability of A plus probability of B minus probability of A and B is called as an non-mutually exclusive events. After that, dependent and independent events. What do you mean by dependent events? Dependent event is an outcome of one event affects the outcome of other. Outcome of one event affects the outcome of another. That is, if A and B are dependent event, then the probability of both occurring is one event depending on the other. That if A and B both of the dependent event, then the probability of both occurring is equal to probability of A intersection B is equal to probability of A into probability of B by A. Probability of B by A means here probability of B given A means probability of A is depending upon the B. That is what the indication. B is an independent variable and A is a dependent variable. Like that, both are depending events. That probability of both occurring is that indicated by probability of A equal to probability of B by A. Right? It is multiplication will come over here. Next, independent means both are independent to each other. If A and B are independent event, the probability of both, which one event does not affect the other. Whereas one event affect the other is nothing but dependent. When one event does not affect the other is nothing but independent. That is simply referred as an probability of A and B is equal to probability of A into probability of B. Probability of A into probability of B. That is what the independent events, right? Independent events. So these are the small things which you need to keep in mind while going through with the probability. That is not a questioning area. And now this is also not a questioning area. But these are the basis for asking answering a questioning area. Now let's move ahead. There are three approaches of a probability. What are the how many? Three approaches: subjective approach, objective approach, and axiomatic approach. What is subjective approach? Here, the probability is going to happen based on the past experience, based on the already ready-made available information will be there now. If you are going to make the probability or calculate the probability already based on the past experience, based on the data that is available with you. That's what we call it as a subjective approach, which is given by Frank P. Ramsey associated with this, and it is also called as a Bayesian approach. Whereas objective approach is divided into two types, that is classical approach and empirical approach. This empirical approach is also known as relative frequency approach. What is this classical approach? Classical approach is given by the Laplace. Laplace is given this classical approach. This is a priori probability. That is also known as a priori probability, presence of equally likely events or outcomes. The events are going to happen likely events are outcomes. Equal events can happen. The probability of occurrence of equal probability, like a 50 percentage and 50 percentage. The equal chance of being occurred, which is the original definition of a probability, which is called as a classical approach. Whereas relative is saying posteriori probability. Posteriori probability is called as a relative approach, which is also called as an statistical approach, which is also called as an empirical approach. So other names of this is an posteriori probability, relative frequency approach, or statistical approach, or the empirical approach. Whatever you call, that is what all one and the same only. Next, happening of an event depending upon the past experience or a past experiment. So there is a dependency relationship is going to be arise. That's what we call it as an empirical approach. Happening of event that depends upon the past and experience, a past experiment or a past experience. Right? So next, axiomatic approach is nothing but this is not much important at all, and this is not actually a part of the classification. But why to take a risk? I have taken over here just to show you that something is there called as an axiomatic. Hello Arun. So Russian mathematician A.M. Kolmogorov has given this axiomatic approach. Those are, it is set of axioms and based on the logical structure of the probability theory. That means this is going to be believed and accepted by many people without any substantial proof. Without any evidence also you can take it as a true, and acceptance also you can take it up. That's what axiomatic, because this is purely based on the logic, not on the experience. This is purely based on the logic and structure of the probability. That is why this is can be accepted as a true and accepted as a true without any proof. Right? Now look at classical approach. Some more, if you look at, when a card is drawn out of a well-defined deck, out of the 52 total cards, if a card is drawn directly taken up from the 52, every one of the card is having a basic outcome that is likely to occur as any other. This type of situation is marked as an equally likely, which is in classical theory or classical approach. Whereas the relative approach is fully concentrating on probability of happening of an event is determined on the basis of past or on the basis of relative frequency of the success in the past. Suppose number of items and event occurs, there was the total number of terms or experiment is done. So then we can able to get to know like that is probability of event, how much it is based on the number of items an event occurs, and total number of times experiment is already conducted based on the past or depending upon the past experience, depending upon the past data. So past we can say it is not data, past experience or past experiment. Subjective approach is is a situation where events do not occur at all or occur only once and cannot be performed repeatedly under the same condition. It will be having a different condition. We will be performing a test. It is not same condition will be taking in this probability. This is an personal probability. This subjective approach is there now, which is here. This we can say personal, one personal experience, one's own personal experience, and this posterior is not a personal experience based on that experiment that we conducted previously. Right? So subjective probability is based on the one's judgment and wisdom and intuition and expertise. Subjective probability is based on what? It's based on the one's own judgment, one's own wisdom, one's own intuition, one's own expertise. Whereas objective relative approach is there now, that is not based on one's own judgment, that is based on the experiments past in the previous we conducted. So subjective is one's own personal probability, and classical is an priori probability, whereas relative is an post priori probability. Right? Posterior probability means after happening of an events only, based on that experiments we are going to make it. What happened, Sony Keshari? What happened? Seriously, the class is going on, you are coming and saying Pintu, Mintu, Bantu. What is this? What happened? Breakup ho gaya with your boyfriend? आ गया questioning area भाई. Look at, very easy, dead easy, you are going to answer like anything. 3 theorems of a probability. How many 3 theories are there? 3 theories are there. Addition theorem, multiplication theorem, Bayes theorem. Addition theorem, multiplication theorem, Bayes theorem. Addition theorem is nothing but a mutually exclusive events. Addition theorem is also divided into mutually exclusive and non-mutually exclusive. And multiplication theorem is of 2 types. Conditional probability theorem for a dependent events. For independent event, multiplication theorem or multiplicative theorem. Next up, Bayes theorem. Bayes theorem, let's put aside. I will discuss separately that one. Now let's start with the addition and multiplication. Addition theorem is like, it's an mutually exclusive events. So mutually exclusive is an probability of X union Y is equal to probability of X plus probability of Y. I already told you whenever mutually exclusive comes, plus will come. Look at, because this is an addition theory by addition theory plus. So probability of X plus probability of Y, or else probability of A or B, or else A union B is equal to probability of A plus probability of B. Right? And non-mutually exclusive events are nothing but probability of A union B or X union Y is equal to probability of X plus probability of Y minus probability of A intersection B or X intersection Y. So this is both can happen, removing where both can happen. This is what addition theorem in case of mutually exclusive, non-mutually exclusive, right? Next, a multiplicative theorem or a multiplication theorem. This is multiplication theorem is also like condition probability theorem. It is called for the dependent events. There are 2 types of events by dependent event, independent event. And multiplication is also called as a condition probability in case of dependent event. And it is also called as a multiplication theorem when it is independent events. Multiplicative theorem for the independent event, condition probability for the dependent event in case of multiplication. Now you can look at independent event. Probability of A and B is equal to probability of A into, this is multiplication, that is why multiplication is coming, into B, probability of B. In case of dependent, which is a condition probability, is probability of A and B is equal to probability of A into probability of B by A. If you go back and see this one's dependent events formula isn't there, probability of multiplicative classical probability, not dependent theory. Right here, classical probability. Whereas independent events is nothing but here the independent events are there. Same formula. What are the 4 formulas are discussed? That is related to addition and multiplication theory, dependent and independent events. Hello Felicita, FDO. Bayes theorem. What is this Bayes theorem? Guys, do hit the like button if you like the session, and do not forget to join into the Telegram group. How to identify the events independent or dependent? By very clearly I have already told you dependent and independent is indicating when both are one outcome of the probability is depending upon any of the other variable, then that is dependent. If it is not depending, then it is independent variable. Next, the probability, the Bayes theorem, third one is that in the statistics, the probability theory, which is a Bayes theorem, is also known as a Bayes rule. This is a mathematical formula determine the condition probability of event, conditional probability. So the theorem which is based on the conditional probability is known as a Bayes theorem. Essentially describes the events based on the prior knowledge. Events based on the prior knowledge of the conditions that might be relevant to the event which is going to happen. That might be based on the prior knowledge only this is going to be conducted. So this theorem is named after the English statistician Thomas Bayes, who discovered in the 1763 year. It is considered as a foundation of a special statistical inference approach called as an Bayes inference. Now let's see what are the formulas, which is a 2020 repetitive question is from here only. That is condition probability Bayes theorem and Bayes theorem, actual Bayes theorem. Bayes theorem is having a two formulas by. Either it can be related to Bayes theorem based on the condition probability, Bayes theorem normal one. So Bayes theorem based on the condition probability is equal to probability of A divided by B is equal to probability of B by A into probability of A divided by probability of B. This is what we call it as an, actually, this is a dependent probability or dependent events. Correct? Because condition probability just now we discussed, it's a dependent one. It's a dependent one, which is dependent one. Probability of A divided by B equal to probability of B by A into probability of A. This is the original formula for the probability. Now, another formula for the probability is that probability of A by B is equal to probability of A intersection B divided by probability of B. Right? Probability of A intersection D divided by B divided by probability of B. This is another formula. This is another formula. So generally condition probability is what? Probability of event A, that is based on the occurrence of another event. That's what a condition probability. Did I wrote the formula ulta over here? I think this table, this box over here, this box over here. Final PDF I'll change it. Okay, don't worry about it. I'll change in the final PDF. Right, and Bayes theorem is like, Bayes theorem is using a definition of condition probability. The Bayes theorem formula includes a two condition probabilities. That is what we discussed over here. Now what is this probability of A by B is indicating? A by B is indicating probability of an event A occurring given B has occurred. That means A occurrence is depending upon the B. A by B means A occurrence is depending upon the B. Whereas B by A means probability of event B occurring based on the event A. So based on the past experience that some event might have occurred, now we are going to make the probability of another event. So that is B by A. So denominator will be an independent variable and B is an, the numerator will be an dependent variable. Denominator is an independent and numerator will be a dependent variable. Probability of A is equal to probability of event A, event B. Probability B, right? Next, ABBA means probability of AB equal to probability of BA, ABBA. After that, AB she told A into my probability A divided by probability B. That is what she meant to say, I think. Probability of A by B, AB equal to probability of B by A, BA, ABBA into probability of A, which is A, divided by probability of B, that is B last. So the trick she is saying is that ABBA, AB, ABBA, AB sequence. Right? Now can you answer this question please? 2020 question. Answer please for this question. Given an A instead of ABC, they given E. So fourth is the correct answer. That is Bayes theorem. Just now we discussed probability of A divided by B is equal to probability of A intersection B divided by probability of B. That's it. This and condition probability related formula is given. Now the condition probability separately is given. This is Bayes theorem related formula, and now condition probability formula separately given. That is the condition probability is given as an probability of B divided by A is equal to probability of B intersection A divided by probability of A. This is another formula. Next, a theory of complementary events. Theory of complementary events. Theory of complementary events. So complementary means probability of X bar equal to 1 minus probability of E. Probability of E means This is simply we can say probability of failure is equal 1 minus probability of success. That's what a complement here formula is given. And addition theorem is an probability of A plus probability of B, addition theorem. So two formulas are covered and two formulas are not covered, but with that we can able to answer. Now what is the probability that a random chosen card from a deck of cards will either be a king or a spade? Hello Bhavna. Guys, please do hit the like button. I cannot go directly into the test, Narahul. I need to discuss the remaining topic, whatever is pending. Test will come at the end, that is. What is the probability of randomly chosen card from the deck of card? Either it will be a king or a spade. So that is answer is an 1, that is 0.3077. Probability of event A is an being card being king, which is 4 by 52, because total 4 kings will be there out of 52 cards and 13 spades will be there out of the 52 cards. So event B, which is 13 by 52, and event A king is an 4 by 52. So both are dependent event. Like A, as events are A and B are dependent event, there is a possibility of king of spade is also there. So which are king, that can be a spade also possible. So based on that, probability of A or B, which is addition theorem, applies. Probability of A plus probability of B minus probability of A and B. The probability of the card is drawn, which is 13 divided by 52 plus 4 divided by 52, minus there is a one possibility where king of spade can be there. King of spade, which is 1 divided by 52. So if you do the total multiplication, 13 plus 4, how much? 17 minus 1, 16. So 16 divided by 52 is equal to 4 by 13. 13 fours. Next question, same. Probability of theorem of addition, theorem of multiplication, condition probability, base theorem. Multiplication, addition will give you the answer, I believe. Multiplication and addition will give you the answer. So option 2 is the correct answer, that is probability of A intersection E divided by E, which is related to fourth one, base theorem, and this probability of dependency, when it comes, it is an condition probability. This is dependent and this is not dependent, related directly to the base theorem, and this is an multiplication, this is an addition. Now the sampling. So shall we go to the directly the testing, hypothesis testing before the sampling? Because we know the statistical sampling is very easy, already discussed in the research. So as many are directly telling like hypothesis tests are required to discuss. So let's go to the test directly. Look at hypothesis. What is hypothesis? What is hypothesis? Hypothesis is an tentative prediction. It is an hunch about the outcome, means a clue about the outcome. Expectation about the outcome is called as an hypothesis. Expectation about the outcome. So prediction or explanation of the relationship between the two variables. It implies that systematic relationship between the independent and dependent variable. It is a systematic relationship between the independent as well as dependent variable is called as an hypothesis. And the characteristics of hypothesis is, it is a conceptually clear one. We must be having a clear-cut conceptual clarity about the hypothesis. All concepts used in the hypothesis must be clearly defined when you are making an hypothesis. And a hypothesis must be empirically testable and verifiable also. We cannot like make like it should not be empirically verifiable. That type of hypothesis is not a valid hypothesis and it is a useless hypothesis. Empirically verifiable and testable hypothesis must be there. Hypothesis must be a specified and precise hypothesis. It must be a specified hypothesis and a precise hypothesis must be there. And it should be consistent with the known facts. A hypothesis should be consistent with the known facts, and hypothesis must be very clear and definite, stated in a simple manner also. It is stated in a simple manner also. Next, it must have a reasonable explanation why you are making this hypothesis. The expectation or a proper reason must be there in making an hypothesis over here, right? Now there are there are many types of hypothesis, but four main types over here. Null hypothesis. Hypothesis where there is no relationship between the variables is called as a null hypothesis. Where there is no relationship between the variables is called as a null hypothesis. Alternative, which is a research hypothesis or the substantive hypothesis, is called as an there must exist a relationship between the variables. Between two or more than variables, the relationship must be existed, or between only two also. Alternative hypothesis, which is denoted by H1 or HA, which is also called as a research hypothesis, which is also called as a substantive hypothesis. Next, another one is an directional hypothesis, non-directional hypothesis. Directional hypothesis, non-directional hypothesis. In one-tailed test, by manipulating, so in the directional one-tailed test will be used. In the non-directional two-tailed test will be used. You can just see directional how it is, one tail test only on one side, either this side, left or right side, one tail test. Whereas non-directional is an two tail. The error of rejection is there now, which is called as a critical region. Critical region is divided into two parts in case of non-directional, half right side, half left side will be there. Whereas in case of directional, only one side the error will be there, that is a critical region. So in one tail test, by manipulating an independent variable, the dependent variable will change in a specific direction, in either a positive rightly skewed, either a negative leftly skewed. Positive rightly skewed and negative leftly skewed will be there. There is a proper specific direction, only one way direction will be there, either this or this. Next, a two tail test, in the both side it will be, in the both side it will go. By manipulating the independent variable, it will change the dependent variable. But you cannot predict whether this change is a positive, whether this change is a negative. It can go in any direction. You cannot predict that in what way it is going to be there, right? So H1, that sample mean is larger than the population mean, then in such case directional hypothesis. And non-directional is an HO where there is no effect, and H1 there is an effect. In the null hypothesis there is no effect in case of non-directional. And in case of non-directional, there is an impact on the alternative hypothesis is going to be there. And it is two-tail test, which is a 2% chance of error from left side, 2.5 chance of error on right side. Equal chance of being occurring, error occurring is both side, that is left or right. We don't know what direction it will go. Now, null and alternative hypothesis, some more clarity. Null is an no relationship between the variables that are being studied. Alternative is an always predicts that there will be a relationship between the variables that are being studied. There will be a relationship between the variables that are being studied. So it is denoted by HO and this is denoted by H1 or HA. Right? And this is a researcher which we are trying to disprove this hypothesis. Alternative is an researcher try to prove this hypothesis, trying to prove. Rejection of a null hypothesis will imply simply an acceptance of this alternative hypothesis only. And here null is the one which we are going to test it actually, which we are going to test it is called as a null hypothesis. Till here we have studied in the research aptitude and we have also studied the errors also. We have also studied the errors. What is this type 1 error and type 2 error? Look at type 1 error and type 2 error. Very simple. Type 1 error is nothing but error of rejecting an null hypothesis when it is true. When the null hypothesis is true, we are taking a statistical decision. This is an actual situation. When actual situation is untrue, we are taking a decision of that whatever the null hypothesis it is, and when it is true, we are rejecting that one. We are taking a decision as a rejection, right? Rejection, that is denoted by the alpha, which is called as a type 1 error. Denoted by the alpha, which is called as a type 1 error. False positive, false positive. This is also called as a false positive, and this is denoted by the alpha. Whereas statistical decision, if we are actual situation is a null hypothesis is false, but you are taking a decision that statistical don't reject this null, which is a false null hypothesis. You are accepting a false null hypothesis. That is what we call it as an type 2 error. Type 2 error. Or you are rejecting a true null alternative hypothesis or accepting a false null hypothesis. Both are one and the same, which is an beta error. That is a type 2 error. Here the decision will be an acceptance of a false null hypothesis and decision. Wrong. Which is a false negative. Which is a false negative. This is denoted by the beta. Error of accepting a null when it is false. Done. Now, there are two words that we have to know. The alpha, which is a type 1 error. The beta, which is a type 2 error. Alpha is a probability of occurrence of an error when the null hypothesis is true. Actually, we need to reject, but we are accepting that one. That is an alpha. That alpha represents what? It represents the maximum probability of occurring type 1 error. The probability of occurrence of type 1 error is an alpha. So, the rejection, probability of rejecting a null hypothesis when it is true, this is what we call it as an alpha is called as an what? Level of a significance. Level of a significance. That is, in the normal probability distribution, if you can see, this is a two-tailed diagram, two-tailed test. Here 2.5 is an alpha, means a 2.5 rejection. Error occurred, alpha occurred 2.5 percentage. Here 2.5 percentage occurred alpha. Means that is indicating a level of significance, which means the level of rejecting when it is true. The rejecting a null hypothesis when it is true, our level of rejection is called as a level of significance. Percentage of a rejection we can say. Which is also called as a critical region. Critical region. Next, here confidence is indicating how much we are confident enough to get the expected outcome in the probability. Like how much we are having a confidence. Confidence means probability of occurrence, the success, probability of success. It is not occurring a type 1 error. That is why it is denoted by 1 minus alpha. 1 minus alpha means if 5% is an error, 95% is an occurrence. If 10% is an error, 90% is an occurrence. If only 2.5 is an error, then 97.5 is an occurrence, success. So, if you remove the error from the total, then automatically the success which is going to happen will come over there. So, probability of confidence means which is the probability of a correctness, which is 95% in the given example in this chart or graph. So, usually, if the level of significance level is 0.1, 99.9 is then confidence level, which is acceptable, very much acceptable hypothesis. And level of significance is 1 and 99. 1 minus alpha means 100 minus 1, which is equal to 99 is the confidence level. That is also very much acceptable. 5 is a significance. Error is 5%, 95% is in confidence level. Acceptable normally. And 10% is significance level, 90% is in confidence level, which is indicating quite acceptable one, quite acceptable. And 20% error means 80% success, which is a considerable one. You cannot reject. So like that. Now what do you mean by critical region? The portion of a significance level is there now. That is what a critical region. Region in the area of a normal distribution curve. When we indicate the area, that region is called as a critical region. Critical region is also known as a rejection region. The region under the normal curve which is not covered by the rejection region is called as an acceptance region. That is over here. This is a critical region 2.5%. This is a critical region 2.5%. So here standard deviation minus 1.96. Here standard deviation plus 1.96. And the region of acceptance which is in confidence level is that 95% is there. So this is a region of acceptance. This is a region of rejection. Region of rejection technically called as an critical region. Done. And there is a in the hypothesis test time, there is a test called as a chi-square test. Chi-square test related goodness of fit test. This has always been appeared in the PYQ with a formula. Formula we have to identify and when the match the following comes. So goodness of fit test is also called as an chi-square test. chi-square test. This is denoted by chi-square like this. This is what chi-square. So goodness of fit test is a statistical method often used to make an inference about the observed values. Observed values. It is actually determining how actual values are to be predicted values. How to determine or determine how related actual values are to be predicted values in a model when used in decision making. It is simply predicting about the future trends and patterns. That is by making a difference between the expected frequency and observed frequency. What you have observed and what you have expected. So that is chi-square is equal summation means a sum of observed variable minus or observed frequencies minus expected frequencies divided by the expected frequencies. The square of the difference between the observed and expected frequency divided by expected frequency is called as an chi-square test or a goodness of fit test. This is a non-parametric test also. Done. Now there is a PYQ, whether it is a paper 1 or paper 2, the sequence of a hypothesis testing steps they are asking. So in that hypothesis, look at first step is that there are 5 steps in the hypothesis. Step number 1 is that what? Step number 1 is then we need to state that first null hypothesis and alternative. H0 and H0 and H1 we need to decide first. Later set the significance level. What the significance level? Alpha, how much error? The critical region on the left and right side we need to set it. And that establishment of this error, first we need to identify the level of significance. That is 5% or 2.5 or 10%. How much? Identify that percentage. Later you need to plot on the graph. When you are plotting on the graph, that is critical region, right and left, both tails will be there. But when it is there only on the one side tail, that is a one-tailed test, which is a statistical test in which area of distribution only on the one side, like as we seen in the directional hypothesis, only on one side, either left side or right side will be there. Rightly skewed or leftly skewed will be there. That's a part of the one-tailed test. This is a directional hypothesis or else directional test also. Either only on one side, full critical region only on one side. That is what a one-tail and two-tail test we need to see in order to create that critical region. Right? Two-tail test is indicating both the side it has to, both the side. Either it can go on the right side, it can go on the left side, or proportionately it will be divided into the direction of the left and right. It can go in any side. We cannot decide. So either one tail or a two-tail test we need to perform to establish the critical or a rejection reason. Right? That is a third step. Next, a fourth step is that calculate the suitable test statistics. Test statistic, whether you have to use the parametric test, whether you have to use the non-parametric test. Parametric, in that parametric, what is the sample size? More than 30, Z test, F test, T test, and you can also use ANOVA also. If the non-parametric chi-square, crucial values, Mann-Whitney, U test, and various other tests also there, those tests. So based on that you need to you need to decide. But generally hypothesis means based on the assumption. Assumptions will be considered only in the non-parametric test. That is, assumptions will be considered in the only non-parametric, na? It is an assumption oriented. Where we can correct only. Where we can make the assumption. That is purely based on the assumption. Generally in the hypothesis testing, non-parametric test only will be used, like a Mann-Whitney, crucial values, that one. Right? And finally drawing a conclusion. How to draw the conclusion? There is a PYQ over here. That is why I added small box which can be visible, I think. So compare the calculated, whatever the value that you got in the step number 4 with a critical value. That is standard table value of the test statistic. It can be both. I didn't say anything. Chi-square test, whenever chi-square test, I will discuss that point, whether it is both parametric and non-parametric. So if after calculating a test statistics and a critical value that you got, then we can see if the calculated absolute value is more than the critical value, that is absolute value is indicating from the test whatever the value that you got. If it is more than or equal to the critical value, then reject that null hypothesis. And if that absolute value which you calculated in the step number 4, test statistics, if it is less than the critical value, accept the null hypothesis. Compare the actual with the critical value. If the critical value is less, then reject. If it is more, then accept. Next, there are two types of tests that, as I told you, that is parametric test, non-parametric test. Most important, right? It has a complete parametric means it has a complete information about the population parameter that can make the assumption about the population. That we can make the assumption about the population. Just wait by, I will tell you some more differences also over here, which I made a note of it. There is a small correction, no assumptions in the, just now I told you na, the assumptions will be taken in the non-parametric. The assumptions will be in the parametric and no assumptions in the non-parametric. Now let's see. First, wherever we are, look at, wherever we are, we can make the assumptions about the population. We can take the assumption about a population. That's where we can use the parametric. Wherever we can't able to make the specific assumption, neither he can make the assumption nor he can make he can have a specific assumptions. So he has no knowledge about the population and the parameter. He don't know much about anything. When we don't know about the population, when we don't know much about the, look at, when we don't know much about the we can say data or a population or a parameter which is involved in the study, then non-parametric will be used, because without any assumption we can go. Now metric means a quantity. Metric means a quantity. Non-metric means a no quantity. Metric is indicating this parametric is an quantitative test. This is a quantitative data which will be used for a quantitative data. Whereas non-metric means no numbers. Metric is a number. Non-metric means no number. No number means that is a qualitative. In case of qualitative data, we can use the non-parametric test. So this is normal probabilistic distribution. This is skewed distribution. Non-probability is based on the graph and all. That's a skewed distribution. And here measurement of scale will be an interval and ratio scale can be a metric test because quantitative in nature. Whereas non-metric is an nominal and ordinal because quantitative in nature. When the population is very well known, you know about the entire population, you have a good knowledge about the entire population and the variables which are involved over here, then you can go for the parametric. When you don't know much about the population, when you don't have any clue about the population, go for the non-parametric. And here measures of central tendency in case of parametric, which one will be used? Mean will be used. Mean will be used as a measures of central tendency. To identify the central tendency, mean will be used. Here, to identify the measures of central tendency, which one will be used? Median will be used over here. Mean and a median. Now, here applicable on the variables. Variables will be involved like a variable number 1, dependent variable, independent variable, like that. The variables will be involved in the quantitative, the parametric. Whereas here, attributes, the characteristics, the nature also will be involved because this is about the quality, not of a number. Not of a number, it is of a quality. And correlation test is an Pearson correlation, called Pearson correlation test, which is a parametric test. Spearman rank correlation test means that is ranking. Rank correlation itself is saying it is about ranking, which is a quality. Pearson itself is a number, specific number will come, correlation 0.5, 0.25, 1 and 0.75 and more than 0.5. That is what indicating a specific number, correlation, which is called Pearson parametric quantity. Whereas non-parametric is about the ranking and the sequence, that is of attribute related. And here we will be comparing the mean and the standard deviation. X bar as or mu and standard deviation will be compared. Here the percentage and proportion we are going to compare. Here non-parametric percentage and proportion we are going to compare. And this parametric is a most powerful test to get the exact outcome, and this will be a statistical test also. Whereas non-parametric Parametric is less powerful in nature because there is no assumptions and we don't know about the entire population. Whether we can rely on this or not, we can't able to tell. Next is specific assumptions are required about the population, as you know entire population. Here what assumptions you will take? You don't know anything about the population. You just have a knowledge, just a basic knowledge is there. Even though you are having a basic knowledge, you can't able to make the assumptions over here regarding the population. And examples of a parametric can be a t-test, f-test, z-test, ANOVA. Here non-parametric can be of a chi-square and crucial values, and all those will come. Right? Anything which is ignored by me? Right? Nothing is ignored. Now let's move. How many type of tests? Parametric is of t-test, z-test, f-test and ANOVA. I will discuss each and everything in detail. Now this side non-parametric, chi-square test given by the Carl Pearson, Wilcoxon rank sum test, Mann-Whitney U test, Passman correlation test and crucial values test. All these are comes under here. Done. Now let's discuss about the first non-parametric. What are the non-parametric tests? What are the non-parametric tests? Here non-parametric tests are distribution free because there is no distribution is required. But whereas in the parametric, normal distribution is required. Distribution is must. These are the methods or the method testing hypothesis which nature of distribution is unknown. No distribution or unknown distributions. Right? Crucial values. Crucial values. Sometimes this crucial values is also called as an one-way ANOVA and ranks. One-way ANOVA and ranks. Whereas usually ANOVA is this parametric which is based on the number. When you apply the same one-way ANOVA and the ranks, that will become a crucial values test simply. Right? It is a rank-based non-parametric test that can be used to determine. If there are statistically significant difference between the two or more groups. If there are a statistical difference between the two or more groups, often independent variables on a continuous or ordinal dependent variable. Independent variable on a continuous or ordinal dependent variable. Why they are saying ordinal? Because this is related to order and the ranks. About the nature it is going to give you. This is a non-parametric. Nothing about the quantity. This is determining the difference between the two or more groups of the independent which is not going to dependent on each other on a continuous ordinal dependent variable. Independent variable on a continuous or a ordinal dependent variable will be there. Next, a Mann-Whitney. Mann-Whitney U test is used to compare the difference between the two independent groups. But when the dependent variable is either ordinal or a continuous but not normally distributed. There is no normal distribution of a dependent variable. It can be ordinal, it can be a continuous. In that case, in order to compare the difference between the both independent and dependent groups, we will be taking a Mann-Whitney U test. Next, a Lexicon. Lexicon ranks some test is and this is used to test for the difference between the two samples. It is difference between the two samples. Non-parametric counter to the Lexicon is a rank sum. Non-parametric counterpart to the two sample Z or two sample T test. Instead of comparing a two population means we can compare the two population related medians will be there. Now the population related medians will be compared in the Lexicon rank sum test. Population median will be compared. I will be telling you in detail about it by. Now you concentrate on one by one. Rather I will explain with this chart. So this is a total parametric table. Population here T test is normally distributed. Entire all the parametric tests are normally distributed, right? And sample size is when the sample size is less than 30, then you can use the T test. But condition variable is unknown, sample size less than 30, and it will be having a comparable mean. We will be comparing the mean only, difference of a two dependent and independent related, and William Gusset is the author who is given. Right? Now look at T is equal to X bar. Just remember the formulas with respect to each of the tests. Remember the formula, that's it. No need to remember anything in depth. Variable, all are normal distribution, t-test less than 30, unknown, and comparing with a mean. Gusset has given this one in the 1908. And t is equal to x bar minus mu divided, which is a mean, x bar minus mu, which is divided by sample statistics, all divided by under root n, number of observation. Or else another alternative formula, x bar minus x bar 2, which is between the two dependent and independent variable now, divided by under root of s1 square divided by n1 plus s2 square divided by n2. These are comes under the unknown. Which is a t-test, small sample less than 30, small sample size less than 30. Whereas z-test is an large sample size more than 30. Large sample size more than 30. When the variable is known, more than 30 variable has to know. It will be compared with the mean only. Ronald Fisher has given this one. Z-test is equal to x bar minus mu divided by standard deviation divided by under root n. This is a simple identification of a Z-test formula. Now here variable is known and large sample size more than 30. F-test is small, which is a less than 30. Normally distributed, sample size is less than 30 only. T-test and F-test compare it. T-test less than 30 is F-test less than 30. But in the T-test variable is unknown. Variable is unknown in the T-test. Variable is unknown in the T-test. Here variable is known in the F-test. Here comparison with a mean. Here comparison with a variance. That is what? Largest sample variance divided by smaller sample variance. Given by the Ronald Fisher only. That is standard deviation whole square 1. Standard deviation 1 square divided by standard deviation 2 square. So this is comparison with the variance. This is comparison with the mean. That's why means are used in the formula over here. x1 bar minus x2 bar divided by under root of s1 square divided by n1 plus s2 square divided by n2. That comes under here. So x1 bar x bar minus mu the mean minus mu divided by standard deviation divided by under root n in case of Z-test. Right, this is about the F-test. Right, variance itself is between two. Variance will be between two only. Variance will not be within one. All are between two only. If you look at here, everything is between the independent and dependent only. Right, now ANOVA is more than 2. All three are between 2. ANOVA comes where more than 2. More than 2 or more than 2 will come. Normally distributed, here 2 or more than 2 samples. 2 or more than, when we are in a position to, or when we require to pick up 2 or more than 2 samples are required. It is not a single sample. More than 2 or more than 2 samples are required. When the variance is known, comparison of the mean of a more than 2 sample. More than 2 samples mean we need to compare over here. More than 2 samples mean we need to compare over here. This is given by the Sir Ronald Fisher. And here, this is simply, there is a one-way classification of ANOVA and there is a two-way classification of ANOVA. In that much depth that is not required. When it is used is important simply. When it is used. When 2 or more than 2 variables are involved, or when 2 or more than 2 samples are required to pick up, in such a case you can use this test. Is that clear? Now if you want a more clarity about the each test, just look into this slide. This is given by the Gusset. Sample size less than 30, variance is unknown and normally distributed, more than, measure the mean of a 2 samples of a one population only. In the single population we will be in the single population we will be having a comparison of a mean of 2 samples, right? And here F-test is an less than 30, population vary is known and normally distributed, mean of a 2 samples on one population only being compared. It can be a one-tail test, it can be a two-tail test, but here variance is the main one. Here we are going to compare, measure the mean is given, actually the variance it is, I think it is variance. I will change it by, okay, this is variance. Measure the variance of 2 samples in one single population, right? Next is that They will ask this much only, nothing much, nothing more, nothing less. You can just see what is not covered in the PYQ. Almost everything got covered. There are exceptional questions always will be there. One or two questions, sometimes rare cases it will be, but majority this is the scope of majority this is. Next, jet test, more than 30 population is variance is known over here, and normally distributed data and observations are independent. ANOVA is an extension of a t-test only. More than mean of a more than 2 population and more than 2 or more samples are required in it. And sample variance is equal to population variance. In which of the following hypothesis test where the sample variance is equal to population variance, that is ANOVA, because multiple samples will be there. Now, chi-square test. What is chi-square test? Chi-square test is given by the Carl Pearson. It is compare the expected frequency with the observed frequency. Compare the expected frequency with observed frequency, which is a positive skewed distribution. Positive skewed distribution. Expected observations and expected observation as well as no Sarji. It is less than 30 for a 2, only for 1 it is more than 30. Observations are independent and random. Ascertain the degree of freedom. We need to ascertain the degree of freedom in the chi-square test. Frequencies must be minimum to minimum 50 frequencies. More than that only, or minimum equal to 50 or more than 50 only we can. This is also called as a goodness of fit test. This is also called as a goodness of fit test. It is to measure consistency of a sample with a population. Consistency of sample with a population. This is also called as a test of independence data. This is also called as a test of independence data. Right? So, Mann-Whitney U-test is a data not normally distributed. In case of large sample, we can use this one by, which is more than 50 or more than or equal to 50. Now, data is not normally distributed. Data is ranked from the highest to lowest. This is of quality. Measured 2 samples of one population, non-parametric variant of A. Simply in the same way, t-test for the parametric and non-parametric t-test is that Mann-Whitney U-test. Mann-Whitney U-test is an which is non-parametric t-test. Non-parametric t-test and ordinal data will be used. Crucial-Wallis H-test. This is also called as an H-test. Crucial-Wallis H-test. Extension of a Mann-Whitney is called as an Crucial-Wallis, which is determine the significant differences between the more than 2 samples. Data is not normally distributed. Data is not normally distributed. In all the cases, data is not going to be normally distributed because this is a non-parametric test, non-metric test it is. Done. Now, ANOVA, which is given by the Fisher only. It is an extension of Z and T test. Mean value among the more than 2 sample group, because 2 or more than 2 sample groups will be there over in the ANOVA. Each sample is drawn from the normally distributed population. All the subpopulation means a sample is having a same variance. That is why sample variance is equal to population variance in the ANOVA. This is the conclusion of the hypothesis testing. I believe that I have done the done. Let's solve the questions one by one question. Arrange the following in ascending order in testing of hypothesis. Guys, do hit the like button. Solve the questions. Let's solve the question. Determining the level of significance, state the alternative, state the null and decision. Actually, so much is there to discuss the hypothesis. I can go in deep, which I made in the notes in such a way where we can go deep. But simply over here, anything else in the statistics? Yes. Sampling is there and the data related, data collection, frequency, polygon, that is there. Now, small things. One more session, that's it. It will be completed tomorrow. Half an hour or 45 minutes. Fasak. So here option A is a correct answer. That is, first one we need to state the null hypothesis, later alternative only, after that level of significance, final decision. And if hypothesis is statistically significant, then it is concluded that option A is the correct answer, because observed result is probably not due to chance. When the hypothesis is statistically significant, it is concluded that observed, whatever the output that we are going to get it is not by the chance that we are getting. It is not the probably not due to a chance. It is in principle statistical significant, usually a difference. Significant result is nothing but usually a difference. This is not attributed to a chance. More technically, it means that if null hypothesis is true, which means that there is really no difference between the variables. There is a low probability of getting a result larger or larger. Means the probability of failure is more in this case. Probability of failure is more in this case, because significant is nothing but it is not occurring due to a chance. There is always a chance of differences that we observe when we are measuring a sample of users is just the result of a random noise or a chance of fluctuations or a happenstance. Happenstance means it happening of something only. Next, in a medical test where a null hypothesis, the patient does not have a disease. The alternative is that patient has a disease. Suppose a patient has a disease and needs a treatment. In hypothesis testing, which of the following error got occurred? Are more serious? Hello, Akshita. So option B is the correct answer. That is type 2 error. Because now what is a type 2 error? What is a type 2 error? Why it is not a type 1 error? You can just see in a medical test, null hypothesis saying patient does not have a disease. Patient does not have a disease. Does not have a disease. And alternative is that have a disease. Does not and have a. Does have a disease. Now patient has a disease and needs a treatment. Now suppose a patient has a disease. Actually original is that patient is having a disease and needs a treatment. Right? Originally. Let us take originally over here. This is does not and have na. Originally patient is having disease. So now we are making an hypothesis testing. Which of the following error is more serious than the others? Type 2 error is more serious. Actually, there is no requirement of this example. We can tell orally. That is, when you are rejecting a null hypothesis, when you are rejecting a null hypothesis, or when you are accepting a null hypothesis, which is when it's false. When it is false, you are accepting that null hypothesis. Or when you are rejecting a true alternative hypothesis, that is a type 2 error. You should not reject the true alternative hypothesis which is actually required to be proved. And you can reject the null hypothesis which is actually to be disproved. So that is why rejection of a true alternative hypothesis is a type 2 error, which is more dangerous. Next. Which of the following statement on testing of hypothesis is always true? Look at which of the following on testing of hypothesis is always true. Answer is that option number B is the correct answer. Why? While null hypothesis is rejected at 1%, the It is rejected also at a 5% level of significance because very nearby, na? Always true. When a null is 5%, always rejected at a 1% level. No, that is not, like ulta is not possible. Look at significance level is also denoted as an alpha. Probability of rejecting a null hypothesis, for example, it is 5%. Risk of conducting a difference exists, there is no actual difference. So if you have rejected a null hypothesis at a 1%, then definitely it is rejected at a 5%. But when we rejected at a 5%, then we cannot say that we can reject at a 1% also. Right? Option B is the correct answer. Next, which one of the following possibilities leads to type 1 error in the hypothesis? Hypothesis is true, but our tests are leading into a rejection. A is the correct answer. Hypothesis is true, but our tests are leading into a rejection, which is a type 1 error. Just I am rushing out. I don't have a time by. A hypothesis test for comparing a variances of a two independent population with the help of a variances. Two small samples is known as a chi-square test. Two small samples is known as a chi-square test. Actually, chi-square test doesn't think about the small samples. Small sample, it is more than or equal to 50 only. More than or equal to 50 only. Large sample size. To test the hypothesis population standard deviation as a specific value on the basis of the value of a sample, standard deviation of a small size sample where the F test is relevant. Here, in case of F test, now just now we have studied here the standard deviation of not small. I'll tell you. F test, which is small sample less than 30, that is okay. But this is about a larger sample variance divided by smaller sample variance will be taken care in the F test. Will be taken care in the F test. But they are saying over here as the test of hypothesis that population standard deviation has a specific value on the basis of sample standard deviation of a small size. F test is relevant. Actually, this is not at all. F test is about the variance, whereas this is about the totally t test they are speaking. Statement number 2 is actually about the t test. It is fully about the t test or a chi-square test they are using. Now, when a null hypothesis is true, but as per the hypothesis testing, it is rejected. It is known as a type 2 error in hypothesis testing. And for a testing of for testing the significance of a difference among the performance of more than two sample groups, when the data are non-parametric, Crucial-Wallis test is appropriate. First, option D is the given answer. Statement 1 is correct and statement 2 is incorrect. This is incorrect and this is correct. So when null is true as per the hypothesis, it is rejected. It is type 2 error. Actually, it is an type 1 error. Right? For testing of significance difference among the performance of more than two sample groups, then Crucial-Wallis is yes, Crucial-Wallis will be useful. You can see Crucial-Wallis may be by the ranks or a test. It is also called as a one-way ANOVA and ranks, or a t-test, one non-parametric test of a t-test. It is also called as an. To use for comparing a two or more independent samples equal to or different sample sizes. Hypothesis tested at a significant level 5%. That means that option answer is not given. Okay. Anyway, we can tell if hypothesis tested as 5%, that means that 5% probability null will be rejected. That is true. And 5% probability that null will be false. 5% probability null will be true. And 95% probability alternative will be false. This is actually not possible because that is true. If this is true, then it might have correct. Significant level 5% means I think option A is appropriate answer. How many degrees of freedom should be used to apply the chi-square test? Statistics on a contingency table. 5 rows and 4 columns. Having 5 rows and 4 columns are there. So what should be, how many degrees of freedom should be used to apply the chi-square? This is a depth questions, but this much depth is not required. Even though I kept it over here, but this much depth is not at all required. Here, if the degree of freedom they are asking now, Simply R minus 1, C minus 1. That is row minus 1, column minus 1 we need to use. R minus 1, 5 minus 1, row minus 1, 4 minus 1, which is to be multiplied. That is 4 into 3, which is equal to 12 is our degree of freedom. Next, when the size of a sample is 25, standard deviation of population is not known, and the researcher wanted to test the significance of the difference between the two sample groups' performance. Which of the following hypothesis testing is appropriate? In such a case, D is that is t test will be appropriate because less than 30, sample size less than 30, one is, and standard deviation is not known. Researcher wanted to test the significance. Here two sample groups are there, which is appropriate. When the n is less than 30 and the variance is unknown, in such a case you can go for the variance is unknown, t test will be used. And variance is nothing but standard deviation here. The shape of the F distribution depends on the number of degrees of freedom, both the numerator and denominator of the F ratio. That is larger variance divided by smaller variance. Next, in analysis of variance, sample size should be equal. And analysis of variance may be used to test whether the means of more than the two populations are equal or not. Option C is the correct answer. 1 and 3 statements are correct, but ANOVA sample size should be equal is wrong statement. Remaining F ratio as well as this one is also correct. Analysis of variance may be used to test whether the means of more than two population is equal. Now look at analysis of variance does not assume equal sample sizes. It is just assume equal variances and normal distribution. That is population variance is equal to sample variance. That is what the ANOVA, but it is not saying like sample sizes should be equal. Population and sample variance is equal. Next, F ratio contain two estimates of a population variance, two estimates of a population mean, one estimate of the population mean and one estimate of a population variance. Option C is the correct answer. Only one statement is correct. Two estimates of a population variance will be there. Larger divided by smaller. Right? Two estimates. Larger divided by smaller. In that only variance, larger divided by smaller will be there. Only one is the correct answer. Remaining are wrong. Next is that non-parametric tests are based on some assumptions about. It is some assumptions about parent population from which sample has been drawn. Parent population from which sample has been drawn. Right? So, and the standard deviation of the sample distribution of a mean is called as a standard error of the mean. Non-parametric tests are based on the some assumptions about the parent population. It is wrong statement because first itself is wrong. Non-parametric is no assumption. Standard deviation of the sample distribution of a mean is called as a standard error. It can be correct. Option the statement number 2 can be correct. That is 1 is false, second is true. Option D. And when the null hypothesis is true, but as per the hypothesis testing, it is rejected. It is known as beta type error hypothesis testing. Here, chi-square test is exclusively non-parametric. Actually, this can be a parametric, this can be a non-parametric, but they are saying exclusively non-parametric. No. Chi-square in if 3 to 4 conditions are satisfied, chi-square can be a parametric test. 3 to 4 conditions. That conditions are not important. Remember the word. If 3 to 4 conditions are satisfied, then that chi-square test can be a parametric. Otherwise, it is a non-parametric. So, exclusively non-parametric is a wrong sentence. And when the null hypothesis is true, but as per the hypothesis testing, it is rejected. And this is known as a beta type. It is an alpha type error. Right? So, option 2 is the correct answer. Both are wrong statements. Last and final question. Under which of the following chi-square testing is applicable? That is testing of homogeneity, testing of goodness of fit, and testing of equality between the two samples, two sample proportions, and testing of independency of attributes. That is option B, A, B, E. A, B as well as E, which is homogeneity and goodness of fit test and independence of attribute. Equality of two sample mean and sample proportion, this will not be useful. These are the questions that are there related to hypothesis. Right? Thank you so much, guys. And tomorrow my topic of the discussion will be maximum sampling, the types of sampling, and sampling related small questions are there. 2020 question, can you please solve the 2020 question, please? Goodness of fitness is tested by 2020. This is that is chi-square test. Goodness of fit test. Ready? Sampling, first terminology we'll discuss. Before that, there is a surprise which is waiting for you after this class. I will be posting one video about it. So which is suddenly came, it suddenly came. Just now I received from an academy only. So I will be informing via video, as well as another big surprise, as I told you, that is waiting for you all. So that is almost everything is ready over here. Only 2 days to go. On the 26th evening, I may reveal this one. After the commerce examination evening, we are going to have that celebration with all the people, right? So with a farewell, I will be thanking you all for the entire 1 year. So I will be informing you about it. Somehow a bit excited. Let's see later after the class, not to disturb the class. So population. What is the meaning of population? In the sample, we need to understand two things. Suppose this is the entire study of your population. Marriage. My marriage, what is a surprise for you, bhai? If it is my marriage, what is a surprise for you? But, so this is the total population that we need to study. And in this total population, we are going to pick up some portion as an like this. So here, so study of the population is, and suppose there are 10,000 members that we have to study. This is our population, right? That 10,000 members, if I can able to study, that 10,000 students or 10,000 members, if I can able to study each and every person, then I will be getting an accurate outcome or not. My outcome will be an accurate. Right? Surprise is for everybody. By surprise is not, there is no discrimination telling my surprise, not to you all. Because of you only, everybody, it is free as well as plus all will be included. Nothing discrimination. So total 10,000 members, if I can study about the entire 10,000, I will be getting a total accurate outcome, I will get it. That's what we call it as a population study usually. So if I speak about a terminology in the sampling, this 10,000 members are called as an what? Parameter. So inside the population, whatever the events or variables are involved, the totality of that events or variables are called as an parameter, population parameter, right? Inside the population, parameter will be there. If I can study this parameter, I will get the accurate outcome. Whereas now if I, out of this 10,000 members, if I am going to study only the 1,000 members, then my accurate outcome will not be there. Only expected or else a probable outcome I will get. A probable outcome. It may not be an accurate one, as because studying the 10,000 members and studying only 1,000 members, how it can be equal? But I can get a guess about the entire population. I can get a, if I can study these 10,000 members, I can have a total hunch about our total expectation about the entire 10,000 people, right? This 10,000 members, it may not give us the clarity or the accuracy, but it will give you the expected outcome. We can guess it, how the total population is going to behave. It will give you the roadmap, how the population is going to behave. So this is called as an what? Sample usually. So whatever the portion which is representing the entire population that we are picking up is called as an sample. Inside the sample, the number of members or the number of variables are involved, or the different information is involved inside the sample. That is called as an what? Statistic. What is that? Statistics, right? So sample, population parameter, sample, statistics is a word you need to remember. Done? Hello everyone. So population is a collection of element that we require to study actually the entire population, the entire group which is there under the study is called as a population. And parameter is a descriptive measure about the entire population of a data. Statistics is nothing but the sample will be picked up. Inside the sample, whatever the data is involved inside the sample, that is called as in statistics. Statistics will not give you the accuracy of outcome, but parameter will give you the accuracy of outcome. Still, we will do the sampling. Excuse me. Still, we will do the sampling. Why we will do the sampling? Because we are not having that much time to study about entire population one by one, like 10,000. It's a huge quantity. Studying about that one is a hectic one, and it is a time consuming process. That's why we'll be picking up a sample and we'll be doing an entire study. How many types of sampling do we have? Two types. One is probability sampling, next is non-probability sampling. Probability sampling is like random sampling, non-probability is a non-random sampling. Each and every variable which is involved in the study is having an equal opportunity to come into the sample or to be selected as a sample. Those are simple random sampling, stratified random sampling, cluster sampling, and multi-stage sampling, and area sampling also will come. What is the trick to remember? S cube MCA, S cube MCA, simple, stratified, systematic, cluster, and multi-stage, area. These are S cube MCA. Right? Non-probability are DSP CQ. DSP CQ means dimensional, snowball, purposive or judgmental or intermental sampling, and quota sampling, convenience sampling, or a chunk sampling. Or it is convenience also called as an accidental sampling. Right? These are the tricks to remember. Simply in the paper one, they will ask you which is not a probability sampling, which is a probability sampling. Like that, simply they can ask in the paper one. In the paper two also you can expect, but paper two some more in depth also there is a possibility to go. What is simple random? Simple random is a subset of a statistical population in which each member is having an equal opportunity. This is another definition. Simple, exactly the definition of probability random sampling is called as a simple random sampling. Right? Next, a stratified random is an stratified random. Stratified random sampling is an we will be creating a heterogeneous. We will be picking up, or we will be creating a homogeneous groups called as an stratas. Entire population will be there. Out of that entire UGC-NET is a population, UGC-NET aspirants. In this UGC-NET aspirants, what I will do? I will create the groups in such a way where all the male candidates under one, or else all the commerce under one, all the economics under one, all the management under one, and all the English, all the Hindi, and all the environmental science, geography, electronic science, computer science, like this I will form a group. What I will do out of that forming, each and every group is similar or not? Every group is a homogeneous group which I created called as a strata. Strata number 1, strata number 2, strata number 3, strata number 4, like that. So then that is what we call it as a similar homogeneous stratas we have done. Between one strata to another strata, heterogeneity will be there because computer science and commerce we cannot compare, both are different. Those are heterogeneous between the groups or between the stratas. But within the group, commerce are commerce only, all are commerce only. Within the group, all are computer science. Within the group, all are geography only. That means each and every strata will be there. In that also, how I will do? I will be picking up one person from the commerce, one person from the computer, one person from the electronic science, one person from the geography, one person from the management, sociology, other environmental science, and Hindi, Arabic, Assamese, Bengali, human rights duties, law, like that I will pick up. From each and every group I will pick up one person. Like that all the total people will become how much? 81 subjects, 81 members will come. If I can study about these 81%, then I can get to know about the entire population of the all over India. How many people are giving as UGC-NET exam and what pattern it will be there. for each and every subject, how the syllabus is going to be changed. Everything I will get to know by studying about these 81 members. Correct? So that's what homogeneous inside, heterogeneous outside, and picking up the sample from all the groups proportionately is called as a stratified sampling. Whereas cluster sampling, making the groups, but each and every group will include all the elements of a population. Like in one group, I will include the commerce member, environmental science, geography, management, English, Hindi, sociology, geography. Like that, I will form one group. I will form another group, another elements. Total all the elements, another group. All the elements, another group. And I will select at only one group as an sample. I will select only one group as an sample, which is called as a cluster sampling. So in that cluster sampling, within the group it is heterogeneity, between the group homogeneity is going to be there. But ultimately, whether it is stratified or cluster, it is going to be an sample heterogeneity will be there. Is that clear, bhai? I hope everybody have a clarity with a stratified and cluster. Now let's move into the systematic. Systematic means every nth variable will be chosen as a sample. Every nth variable in the total population will be selected for the sample. So here, first we will decide the entire population. Next we will decide how much sample we want. Suppose 10,000 is a population. 1,000 is a sample size that we are expecting. So how much? 1,000 tens are, which is 10,000. What I need to do in order to select the 1,000 members till the 10,000 population, first I need to select the first one randomly. First person I need to select it randomly. Later, from that number, suppose I have selected a second person randomly, second person. Then from this second I need to go for every nth interval of this gap which I got it, which is the interval I got it, not 10th. Every 10th variable, that means 12 means 22, 32, 42, 52, like this 10,000 it will go, like this 10,000, 992, till the 992 it will go. So all put together 1,000 numbers will come, that is called as a sampling. Is that clear? First number is random, carefully observe by. In the systematic sampling, once you identify the class interval or the nth interval, you need to select the first variable or the first one will be picked up as an random. Then only if it is called as a random sampling, otherwise it is not a random sampling. Is that clear? Guys, do hit the like button if you like the session. 77 are there, only 40 are there. Very, very bad people. But next, multi-stage sampling is nothing but it is carried out in stages using a smaller and smaller sampling units at the subsequent stages. It is carried out in the stages using smaller and smaller units at a subsequent stages, called as a multi-stage sampling. Called as a multi-stage sampling, it is carried out in stages using a smaller. First we'll do the sampling, later again we'll do the, first we'll select the 4-5 samples. Out of that 4-5, again 1 and 2 only will be. That comes under the multi-stage sampling. Thank you for your help and support. Thank you, Sonia. Next, non-probabilities and dimensional. When your sample is going to be picked up on without any random basis, you are going to have some base for picking up the sample in this non-probability sampling techniques or the methods. In that, dimensional sampling is an dimensional sampling. So picking up the sample by using a various characteristics as a standard. From various parameters, you will be picking up the sample. Like based on the gender, based on income, based on the resident, based on education. Based on the education, that all those are various parameters will be considered to pick up the sample. Multiple parameters. Next, a snowball sampling is like when we don't know about entire population. When we don't have any clue about the population. That comes under the snowball sampling. It works like a word of mouth. When I don't know about my entire population, what to study, what not to study, or else when a little known about a population, then snowball sampling will be applied, like to get to know our chain, to get to increase our chain. How many people are preparing for a commerce? How many people are following a Shiva sir classes? Point number 1, Kalpana. Point number 2, Rahul. Point number 3, Santanu. Like that, one by one person. That person will inform to other person, that person will inform to other person, that person will inform to other person. Like that, it will be getting to know the chain. When I get to know about chain, I can also getting how many members actually are there who are following my classes. Like that, I can get to know my population. Present I am not having any clue about my population because it is not entire population is known to me. It's like a JHO or a referral sampling only. Affiliate marketing. Purposive or a judgmental sampling. This is also called as an intentional sampling or a deliberate sampling. This is also called as a deliberate sampling or intentional sampling. Right? Deliberate or intentional sampling. A sampling technique in which researcher relies on his or her own judgment only. His experience, his knowledge is the base for picking up the sample is called as an non-probability. Next, convenience sample. Convenience sample. Here also called as an accidental sampling. Here we took the people who are most conveniently. If they are acceptable, if it is available, I will take the sample. Whoever is available, whatever, whether you are in the population, you are not in the population, will pick up this sample. Called as an convenience. Next is an quota sampling. What is quota sampling? Quota sampling is an snowball and chain is same, both. Yes. Quota sampling is an chunk sampling. This is an chunk sampling. Sorry. Accidental is called as a chunk, no? Convenience. Deliberate is this is called as a chunk or accidental sampling. Right? A quota sampling is an sampling where you take very tailored sample, like fixed proportion will be there. 10% of a EWS candidate, 15% of a BC candidates, and 10% of a SC candidate, 10% of ST candidate. Fixed reservation quota will be there to pick up the sample. Now, in the statistical inference, there are two estimations: point estimate, interval estimate. Using sample data to estimate the values of a population parameter is there in the statistical inference only. So it is a process of making a judgment about the population based on the sampling properties. Reservation, simply. Reservation is an example. Important aspect of statistical inference is that using estimate to approximate the values of unknown population parameter, right? Those are point estimate and interval estimate. Point estimate is like, it is a single statistics value that best guess for the parameter value, best guess. Whereas interval estimate is like number around the point estimate, which is that has a fixed confidence interval. Like I would say, out of this many candidates who appeared for the examination, I would say there are 62 who are going to get a 60 to 70% of mark are going to get a JRF. That means I can tell you about a range. I can give you the range, highest and lowest range. In between, my sample is going to be there. I cannot clearly say this is my sample. Are you getting my point? Here the interval number of a point estimate will be there. Interval means I will give you the frequency interval, the range will be given to you to pick up the sample. That is a 60 to 70%. Whoever got, they will be getting qualified with a JRF in the paper. That's an sample which I am telling. It may be true, it may not be true, but it lies in between these two only. That's a guarantee. Like that, we can guarantee this interval estimate. Whereas point estimate is like best guess is nothing but by using a variables which are involved in the study. Now you can make a guess. You can make a guess, best guess about the parameter value. What can be the value of a sample, or what can be the statistical estimation in this? That's what a point estimate. Whereas here range will be given. Now most important. Three laws. Two laws of a statistics sample, that is law of statistical regularity and law of inertia of a large numbers. And there is another theorem called as a central limit theorem is also there, which is the most important from the examination perspective. Guys, do hit the like button. Do not forget to hit the like button. That is law of statistical regularity, law of inertia of a large numbers. Law of statistical regularity, law of inertia of a large numbers. What actually the statistical regularity? Simple. Whatever you studied is not going to change. Same, it is called as a statistical regularity. It states that reasonably a large number of items selected at a random from a group of items will on the average represent the characteristics of a group. Will on the average represent the characteristics of a group. That is sample, which we know. The considering all the characteristics of entire population, by considering all those characteristics and you are picking up some sample, you are picking up a portion is called as a sample, which can be including all the characteristics of entire population. That entire population, suppose if you are going for a random sampling without any biasness, you can pick up the sample. There is no problem will arise. If you are going for a non-random sampling, biasness exists. So picking up the sample which can represent the best characteristics or all the characteristics of population is called as an law of statistical regularity. So law of statistical regularity is saying if you can pick up the sample in a best and possible way which will consider all the elements of a population characteristics will is called as a sample, best sample as per the law of statistical regularity. Next, law of inertia of a large numbers is what? It states that larger group of data will show the higher degree of stability in the sample. Means when you are picking up the sample, increase the size of the sample, pick up the large size of the sample so that every variable will be covered, every characteristics of population will be covered. The result is tend to be more accurate and reliable. It will be result is going to be more accurate and more reliable result is going to come. That is a law of inertia of a large numbers. Is that clear? And after that central limit theorem. The central limit theorem state that distribution of a sample means approximates a normal distribution as a sample size gets a larger and regardless of a population distribution. I will tell you, whenever your sample size is more than 30 whenever your sample size is more than 30, then more than 30 or equal to 30, that is the best sample we can say. It is not too much large, it is not too much low. Whenever sample is equal to 30 or more than 30, it is a good sample which can be having all the characteristics of a population. But here the central limit theorem wanted to say average sample means, that is S bar assume sample mean, sample arithmetic mean, and average of a standard deviation, that is standard deviation sigma, is equal to, these both are equal to, average of a sample mean as well as standard deviation are equal to population mean and population standard deviation. Are you getting the point? These are samples. Sample mean is nothing but smallest, and sample mean, population mean is nothing but x bar. So enter population standard deviation as well as population mean, both are equal to sample mean and sample deviation, standard deviation. Sample standard deviation, sample mean is equal population mean and population standard deviation. That's what we can say central limit theorem. A sufficiently large sample size can predict the characteristics of a population more accurately, like a law of large inertia of a large numbers. When you pick up the large numbers, automatically accurate will come. In such a case, sampling mean and standard deviation is equal to population mean and standard deviation. That's it. Together it is together. We can say sum only, not the product. Actually, we should not do that operation. We should understand in such a way both are going to be equal. Sample mean is equal to population mean, standard sample mean equal to population mean, as well as sample standard deviation is equal to population standard deviation. That's it. In that way, you need to understand. Now, paper 1, another most important is that total error. Total error in the sample is of two types. Total error in the study, not in the sample. Sampling error, non-sampling error, two types. Sampling error is nothing but the error which is occurring because of the wrong sampling. It can be a biased, it can be unbiased. When it is biased error, that is called as a random sampling error. When it is unbiased error, that is called as a non-random sampling or non-probability error. Right? Next, non-sampling error is equal. It can be a response error, it can be a non-response error. Non-response error is nothing but, what do you mean by non-response error? When you give a questionnaire, they didn't even know, they don't have any interest to fill that questionnaire. You can't able to get the data. They are not even responding to it. That is a non-response error. Non-response error it is. So because of that also study will be default. Study will be total going in a wrong way. After that, response error is of researcher error, interviewer error, and respondent error. Look at researcher error is nothing but researcher. He himself is committing a mistake. Researcher himself committing a mistake. Incorrect information that he might have taken. Population definition itself is wrong. Sampling frame that he's chosen is wrong. As well as measurement error. Measurement error. So that is researcher error is nothing but he himself has a wrong. He himself is committed a mistake in the study. Interviewer error is nothing but interviewer can be a researcher himself or any of the outside enumerator who is collecting a data also. That is respondent selection by the enumerator or the interviewer is wrong. Wrong selection of a respondent who are not in your study you have selected. Questioning error, wrong questioning. Your framing of the question itself is wrong. Recording error, whatever the data that you collected wrong recorded by the interviewer. And fabricating answers means what are answers given by the already participants, you are changing their answers. That is wrong, not at all allowed. Next, respondent error is nothing but he responded to your queries, he responded to your questions. But here respondent is inability. Respondent means he is not in a position to provide a proper answers for some questions. In that case, he cannot take, when he is not answered all the question properly, we cannot take that questionnaire because half incomplete that is an incomplete. Responding is, non-responding is okay, but responding and not completing is not okay. Responding and not completing is not okay at all. And unwillingness error is nothing but respondent error, unwillingness. He don't want to provide the data, which is some 5 questions are able to answer by them and 5 questions are easily he can tell. But remaining questions are not in a position to remaining question he don't want to reveal, he is insecure about it, the confidentiality of a detail that you are collecting, or he is doubting about your study. Clear all the total sampling and non-sampling related questions? Please do hit the like button. Now biased and non-biased. Biased errors are nothing but arises due to biasness or prejudice. He will only bias. The researcher only will bias or create a discrimination between the participants. Unbiased is nothing but it is by the chance accidentally it will come. Sampling error is a specific group accidentally excluded from the sample. It arises non-sampling reasons other than the wrong sampling selection. Whatever the reason is there, that is called as a non-sampling error only. Already I have told you deviation of a data means a population. Here deviation of the mean in the sample is not equal to mean in the population. Reduction in the error is possible by increasing a sample, but we cannot reduce the non-sampling error because it is sampling size we are not picking up over here. It is non-sampling error is nothing but by the procedural matters itself it is occurring inherent in nature. We can avoid it by taking a certain precautionary measures, but there is no link with the sample size. Here some people are refused to answer certain questions. Those people are likely to have a different opinions. Those who did those who did answer for those questions, right? The order of which questions were asked is influenced the responses also. Sometimes order also will influence you. Now next question. Which of the following errors will be absent from the census method? Let me explain the census also by. Census is there separately. Which of the following error will be absent from the census method? I will tell you what is that census method also. Population, simply. Population is not, population study is not nothing but a census. So option B is the correct answer. Error in the data acquisition. This is not about the sample by. This is a non-sampling error. This is not about the sample. When it is a sampling error, you can say either A or C. But this is about related to data. This is related to data. Thank you Sagar for 14K. And thank you everybody who ever subscribed to this channel. Do hit the like button by. Now the next target is that 15K by the next 15 days. Let's see. At least in the 2022 I can able to reach 20,000 or not, I don't know. Hope so. A market survey was conducted to survey the effectiveness of a new feature in the smartphone. For this purpose, a sample of 1000 people was chosen. However, in only 947 people are actually attended the survey. This type is called as an what error? Non-response error, because out of the 1000 people, 947 only responded, means 53 people not responded. Non-response error it is. Last question answer was data in the acquisition. Error in the data acquisition means when you are collecting data about the population, census nothing but a population. So error related to absent from the population is nothing but that is error in the data acquisition. It is not related to sample, total about the study. Next, which of the following is not the correct statement regarding the sampling distribution? Option B is the correct answer. Sampling distribution of a mean is normally distributed for a small size sample drawn from not normally distributed population. Not the correct statement they are asking, which is this is a false statement. Sampling distribution of a mean is normally distributed for a large size sample. Just now, large inertia of large numbers. P distribution is normally distributed. P distribution is normally, C is also wrong, na? Actually, C is also wrong by. C is wrong. Actually, C can be the correct answer. This is not B. C is the correct answer. Absolutely not B. Because some small sample size, it can be a not normally distributed population. Obviously, it can be. Because small sample may not be covering everything. C is the correct answer. Take C as a correct answer. This is not correct. False statement is C. False statement is C. Please take it as a C. I will change this question. Not correct. B is correct only. C is not correct. Next. In survey, people choose from the class friends or neighbors for the purpose of knowing their preference of a certain brand of cold drink. This is what we call it as a convenience sampling, because whoever is available, Phuket, without any hectic, whoever is available, we are going to take the sample. Next, which of the following is probability method of a sampling? Both. S cube MCA. You are conducting a survey of a people of India to find out the population of a sports R. You randomly choose the people to call 5000 phone calls to people scattered across the country. In this study, statistics term, the population in India, and what is the statistic term? The people you called. Option D is the correct answer. That is, D is the correct answer. That is, people of India are the population. People of India are the population, and people that you called only 5000 member is a sample, which is a D answer. Next. Probability method of sampling. Acha, okay, these both are non-probability, na? None of the above, okay. Which one of the following? Check किया भाई कन्नू. Cool. Which one of the following relates to the probability based sampling? Quota, snowball, stratified, judgmental. Option C is the correct answer because this stratified isn't sampling. Which of the following statement is false? Which of the following statement is false? Option 4 is a given answer, that is, so option A is a given answer. Sample space refers to collection of all favorable outcome of an experiment. It is not all favorable outcome or unfavorable outcome. It is about the study of entire population by taking that sample. So a class collectively exhaustive events are those union sample space, exhaustive events which are different from each other, independent. And all the outcome of experiment is known in the sample space. Two events are said to be independent if the happening of one event does not affect, that is independent variables only. And exhaustive events also given. First one is wrong. Not all favorable. It can be a favor or unfavor, but it's about a representation. When a researcher wanted to select a representative sample to assess different parameter from a large size sample, PDF will not be available in the Telegram. Very sorry for that. Because this is not for the people who are only coming for the PDF. Na? That's why it is available at the Unacademy Plus platform. I will be making this available, this PDF. Very sorry because I cannot give the whole PDF for the free members. If I do that one, it will be unjustified for the paid members. So C is the correct answer, that is stratified random rules. When a researcher wanted to select a representative sample to assess a different parameter from a large sized finite heterogeneous population, which one of the following sampling techniques are most appropriate? So look at C. C is the correct answer, that is stratified random sampling. In the Plus platform, it will be available. The mean of the sampling distribution of a mean is equal to the parameter of a value of a population mean. Stratified random sampling is an unrestricted probability random sampling technique. Option C is the given answer. Here statement 1 is correct and statement 2 is incorrect. Stratified is an restricted probability random sampling technique only. Why it is restricted? Here stratified is an mutually exclusive, that is based on the strata will be there, the groups. Random samples will be drawn from the each group. Stratified method ensures that element within that strata, within that cluster only you need to pick it up. You cannot go more than that, correct now? You cannot go more than that, within that only you need to pick it up. Which one of the following is a restricted non-probability sampling? Restricted non-probability. No. Random sampling is unrestricted. Inside the random stratified sampling is there, na? Inside that one strata or one group. Inside that one strata or one group. In that you cannot go beyond the group. In that group only you need to pick it up. That is what a restriction is there. Option B is the correct answer. Quota sampling. Because quota is a fixed percentage now. Restricted non-probability sampling is a quota, which is a fixed percentage. You cannot go beyond that one. The absolute value of the difference between an unbiased estimate and the corresponding population parameter is called as a sampling error. Multi-stage sampling is restricted non-probability based on the I will become a villain for some people who, if I say I am not going to give the PDF, I may become villain for you, but I cannot be a hero for all the time. Not like hero and villain, it's the exaggeration only. Just I cannot make you happy everyone all the time. So there is a possibility, there is a time that I need to do the action because it will be an violation only. Option C is a correct answer. C is the correct answer. Statement 1 is correct and statement 2 is incorrect. Absolute value of a difference between the unbiased estimate and the corresponding population parameter is called as a sampling error. Corresponding population parameter is called as a sampling error. Multi-stage sampling is a restricted non-probability. By statement number 2, if you look at very clear, multi-stage is a restricted non-probabilities. Is it a non-probability first? It is a restricted only, but it is not a non-probability. It is a probability technique. In survey, people are choose from the class, friends or neighbors. Same 2020 question it is. One of the PYQ. Convenient sampling, because conveniently are available. Friends are available. You can pick it up. Now, next one, which is the last and final part. Now we are entering into it. Nothing happened. Nothing happened. Come back. Come back. Data. Guys, one question is guaranteed from here only. Mark it out. Whatever I am going to tell you next 15 minutes is question from here. Types of data presentation. Pictorial as well as graphical. Two types will be there. Pictorial can be a bar diagram. Pictorial can be a pie diagram. Pictorial can be a data array. Pictorial can be a pictograph. Graphical can be a histogram, frequency polygon, frequency curve as well as ogive curve. Right? Ogive curve. Now look at a bar chart or a bar graph. A bar chart or a bar graph, that is the chart or a graph that represents the categorical data with a rectangular bars. These are called as a bar chart or a bar graph. This is looking like a histogram, but histogram and this is having a difference. I will tell you. Histogram is an graphical representation. Pictorial is an bar diagram. This one. From here you can draw the line also. So here data with a rectangular bars with heights and length will be there, which are proportional to the values that they represent. The bars can be plotted vertically or horizontally. Vertically, horizontally. Vertical bar chart is sometimes also called as a column chart. This is what we call it as a column chart. Right? I will tell you difference between this and that. In a picture form, it will show. Here graphic means graph will come. Graph will be there now like this. Frequency polygon, ogive curve, left side, less than ogive curve, more than ogive curve, like that. Next, a pie chart. Pie chart is a circular statistical graphic. Entire population is divided into various slices. So total here, some are belong to commerce, some are belong to physics, some are belong to chemistry, some are belong to mathematics, some are belong to English, like that. Division. Next, data array, it's a systematic arrangement of the objects. Usually 2020 PYQ, it is in the commerce both shifts. PYQ. An array is a systematic arrangement of an object, usually in rows and usually in columns. Rows and columns. Data array, that observations that are systematically arranged. Systematically we need to arrange the data. That's what here we call it as a data array. There are two types of array data structures, that is one-dimensional array and multi-dimensional array. One-dimensional means only two, like you can look at the table 1, 2, 3, 4, 5 and 11, 12. This is one dimension. When you are making the index values, more and more values when you are adding index on one side and values on the other side, 1, 2, 3, 4 values and index is going like that. So the rows and columns, wherever multi tables, it's a table, like whenever multi tables are there, that is called as a multi-dimensional array. Rows and columns will be there. Next, a pictogram is which is this side, graphical one. Pictogram is this one. This is what we call it as a pictogram. It's called as a pictogram. Pictograph is simply a computer usage, like icons will be there. This apples, now red apples are 5, green apples are 4, and yellow apples are 3. Cute apples are there. That means by showing that picture, you are trying to categorize or present the data in that form. I can able to say out of the total population, out of the total sample, red color apples are 5 and green color apples are 4 and 3 yellow color samples are there, right? Next, a histogram is nothing but it's a bar graph where you can have the limits clearly on this by using this rectangular is there not total. That box is based on that you can plot a graph also. It's a bar graph like a representation of a data buckets in the range of outcome into columns along the x-axis. So the y-axis represents the number of count or a percentage of occurrences. Here it is about a frequency, here about number of occurrence in that frequency. 0 to 2, how many people? And 2 to 4, how many? 4 to 5, how many? 8 to 6, how many? 8 to 9, 8 to 10 is how many? Like that we can say. Yellow apple never seen. Bhaiya, for the classification purpose, understand that I wanted to show the colors in the picture form there. Next, a frequency polygon. Frequency polygon is a visual representation of a. This is in the data interpretation. This will come usually. This computer A this much, computer B this much, like that. Right? It's a visual representation of a distribution. The visualization tool is used to understand the shape of a distribution. Essentially, frequency polygon indicates a number of occurrences for each distinct class of a data sheet. Look at here means, suppose this point is indicating what? This point is indicating what? Right? So out of the 20 people or else 10 to 20 people are within the like zone of a selection, above this, over and above this, outside the zone of selection. Something I can represent over here. Something here I am going to pick up the graph in such a way where I will be plotting on the x-axis and y-axis by linking the two elements over here. The graph will be drawn, but the frequency intervals will be there over here also. Intervals will be selected over here. This can be a saturation point. Like in our economics, we can see now this graph, frequency polygon, that total cost is maximum and marginal cost. You can take that also as an example. Next, a frequency curve, most important frequency curve. Wait, I will give you one example which I have written over here for this to simplification purpose. Possible, I'll try to give it. Ogive. Okay, it is not there over in my notes. Let it be. Now here frequency curve is indicating it's a smooth curve which corresponding to a limiting case of histogram. You will draw a histogram like this. You can see now histograms there. So that histograms also will be there. Plotting that histogram and attaching all the lines of that one. Attaching all the lines. That's what a frequency curve over here, line graph. So simply it's a continuous distribution, number of data points becomes very large. When the number of data points are very large, we can use this frequency curve. It is a whatever the limitation of histogram which is covered in the frequency curve. Now ogive means sometimes also called as a cumulative frequency polygon. Normal frequency polygon is in this one. This only graph will be there, whereas combination of histogram plus graph is called as a frequency curve. Now whenever cumulative frequency polygon, cumulative means Two types of data will be there. This is one frequency polygon, this is one frequency polygon, which is when multiple frequency polygon, when one is less than ogive, one is more than ogive. One is less than ogive, one is more than ogive. Ogive is nothing but this middle point is there now. This is the intersection point, you can see. Where less than and more than ogive is called as an equilibrium point, where both are intersecting, less than and more than ogive curve. Intersection point is called as an equilibrium point. This is where the data midpoint, right? So type of frequency polygon, this is a cumulative of the both. Cumulative frequencies, in other words, cumulative percentages that are added on the graph from the left to right. From the left to right, this is added. And ogive graph plots cumulative frequencies on the y-axis, class boundaries on the x-axis. Here the frequency interval will come. And here variables, we can say boundaries will come. So from left to right and right to left. One is upward, one is downward. One is upward, one is downward, it can be. Wherever it is touching this point is called, now this is equilibrium. This is also written in the statistical form as one of the measures of central tendency as a median. Okay. Now answer these questions. To show a trend for a variable, which one of the presentation method is used? Histogram, frequency polygon, line graph, scatter graph. To show a option C will be used because line graph will be used in case of a when the trend for a variable if you wanted to show. Data, which of the following is not an example of the compressed data? Compressed data. Data array is the correct answer because data array is an only this is related to which one? First group now. Comes under the pictorial only. This will not consider everything. This can be a one-dimensional, multi-dimensional. So it will not be useful for, or it is not an example of the compressed. Compressed data means multiple variables or multiple information will be included in this. That is data. 2020 question. Now data collection methods. Primary data, secondary data. Two types of data collection methods. Primary data can be by doing an interview, like a personal interview or a telephonic interview, depth interview, or a focused group interview, projective interview. And a questionnaire, second one. Second one, questionnaire. Schedule, observation, case study. Questionnaire, schedule, observation, case study. These are primary first-hand information collection sources. Secondary data is an second-hand information, that is internal and external. Internal can be within that we can make the analysis and get it, or else external sources from the published annual reports and various other who have done the analysis already, magazines and all. Computerized database also, or else syndicated services we can get it. Now there is a open-ended, closed-ended, exclusive, inclusive by. There are four words. Open-ended means this open-ended will give you the respondent ability to respond in their own words. Open-ended questions are nothing but these are descriptive questions. The way you want, you can collect, you can answer as the way you want. These are descriptive. Descriptive answer sheet is given, you can fill as you want. So here for example 0 more than 5, 5 more than 10, 10 more than 15, 15 more than 20, like that. In this series we can take any number which is less than 5. We can take any number between in the first interval we can take any number which is less than 5. In the second interval any number within the less than 10 or more than 10. It can be of anything. We cannot say that is only particular will be the answer. subjective in nature. Whereas closed-ended is an objective in nature. Definite specific answer. I am giving a 4 options to you. You need to pick up the one option as a correct one. Means a multiple choice questions will be having a perfect proper answer. Specific answer will be. You cannot go beyond that one. Next, exclusive is nothing but, in this we include lower limit but exclude the upper limit. You can see 0 to 5 is included. Now start from the 5, lower limit. 10 will be included. 10 to 15. 15 to 20. 15 to 20. Is it example became ulta? Okay, it is correct only. It is correct only. 0 to 5, where it is trying to say we will include the lower limit, but we are excluding the upper limit. We are excluding the upper. We are not counting the upper limit into it. We are not counting the upper limit into it. In this series, we include lower limit but exclude the upper limit. The inclusive ones, you look at the inclusive. Upper limit of a class is not included in the lower limit of a next interval. Value of upper limit of a class is not included in the lower limit of the next class interval. Acha, okay, wherever within that, in that next class interval, if you are taking a lower limit and not taking the upper limit, is comes under the exclusive. Whereas inclusive is like here 0 to 5, then 6 to 10, then next number 11 to 15, next number 16, next number 21, next number 26. Like that, we are taking the upper limit in the next as a lower limit, next number as a lower limit. That is what inclusive. Here exclusive means we are excluding the upper limit and including only the lower limit. It is correct only. Correct only, correct only. Now personal interview means by directly meeting that person and getting. Telephone via call. Depth interview is nothing but asking a question in depth about the situation and all, asking in depth. Focused group interview is nothing but people who are having like similar to your study, invite them and ask the questions to that group only. Projective means unstructured. This is an indirect form of a questioning which will be encourage the participant to project their underlying belief. Like not directly asking a question, indirect way of a collection is called as a projective one. Now final one is that schedule and questionnaire differences. Questionnaire is sent through via mail. It will be by the researcher only. Questionnaire will be prepared and all. And your schedule will be filled out by the, actually questionnaire will be filled out by the respondent only. If I send a Google form link now, my questionnaire, you're asking you to fill it up, means you will fill that one. You are the respondent only filling up. Whereas in the schedule, I will ask you the question number 1, question number 2. Whatever you are telling, I will note it down. Generally, it is done by the enumerator. Enumerator is a person who is collecting a data on behalf of the researcher. Generally, schedule will be done by that person only, who will be going like a survey. Survey there, you are going to each and every home and collecting a data. How many members are there? What is their age and what is their Aadhaar card number? What is their marital status? And what is the languages known? Like that, you are trying to collect the data. Schedule. That is filled out by the enumerator who is collecting data. That will be submitted to the government. Relatively economical in case of questionnaire, and here more expensive in case of schedule. Schedule will take much amount of cost. And chances of non-response is high in the questionnaire, because either it is high or half filling of questionnaire will be there, or else no filling of questionnaire also possible. Here chances of non-response is very low because you are directly interacting with them. And respondent is unknown over. Who is filling the questionnaire, we don't know. Here respondent is very much known. Who is filling the questionnaire is known to us. No personal contact. Absolutely there is no personal contact over here. And here personal contact is possible. Here there is no personal contact. Here the personal contact is possible. And careful, useful only when the respondent is literate. Useful only when the respondent is literate. Possible even the respondents are illiterate. Possible even the respondents are illiterate also, because just they can tell, you can fill it up. But here literate only, who are filling the questionnaire, they have to know the like whether they are literate person or illiterate person, you have to know. Then only you can ask them to fill up the questionnaire. Otherwise, you cannot. Right? Now, internal source of data can be consist of information gathered else. This is actually both are secondary only, internal and external. Internal will be from your within your organization, whatever the customer database, sales report, internally available with you. Whereas external source are published data, certain magazines, editorial analysis, those are published data, or various research papers also. Computerized data means which is in the electronic format in a textable, like internet sources are there, Google, or it can be various other source also, right? If I am saying Google, Google is responding. Whenever we want, it will not respond. Now, if I say accidentally, that is Google, I told, no, it is responding. Alright, again. Syndicated services. These are the companies that collect and sell common data of known commercial value designed to serve the number of clients. Syndicated services means data gathering companies, the entities, consultancies will be there who will be collecting a data and getting the data for a purpose which can be used for the commercial purpose. Primary, collected by researcher himself and collected by any other person, and original or a unique first-hand information. This is a second-hand information. Surveys, observation, experiments are example. Internal record, government published data are example. More time consuming, less time consuming, more expensive, more reliable. Primary, less expensive, less reliable. Need of a team, trained investigators. Here no need of investigators. Most suitable to achieve the objective. Here may not be suitable. And collected when the data is insufficient. We will be collecting more data when will be collected when secondary data is insufficient. We'll be going for a primary data. Collected before the primary data. Possibility of a biasness. So which data will be collected first? Secondary data will be collected first. After that only, if not sufficient, then primary data. Biasness possible in the primary. Here somewhat biasness may not be there because already published that one. Precaution to use not necessary. There is no precaution is required. Here precaution, because from where you are taking authenticator or unauthenticator, that has to be very careful. Don't need adjustment. You no need adjustments, and need adjustment to suit actual aim. Here we need to make the adjustment for secondary data. Here no need of adjustments. Now survey and census difference. Census is a information about the every member of the population. Census means the total population is, another name is that census. Survey means survey collects the information from a sample of the population, right? Census is a detailed and accurate version. Survey is not accurate and reliable, not reliable as a census. Survey, we are conducting a survey, that everybody considered in the survey may not be, but census everybody will be considered. Survey only particular area will be doing that one. Census is totality. Census is generally conducted by the government. Surveys are conducted by anyone. Suppose census is government of India only. Election surveys, like various groups will be conducted. Times Now and Republic India, various surveys will be conducted. Census are not conducted frequently. It is after every 10 years. For every 10 years it will be conducted. Surveys are conducted more frequently as per the requirement. Which of the following are the modes of data collection is a possibility of influencing a respondents the most? Personal interview, telephonic, and mailing questionnaire equal for all modes. So more collection of data possible in case of personal interview. Next, which method of data collection does not allow for the clarification of ambiguous questions? Does not allow for the confusing questions, we can say. Option B is the correct answer, because mailing questionnaire will not be helpful. You cannot contact that person again and he may not be responding again also. What are the characteristics of secondary data? Collected mostly via surveys, expensive to obtain, never purchased from the outsider suppliers, not always very useful. So secondary data not always will be useful. You need to make adjustment to make it useful. Which of the following are not a source of secondary data? Questionnaire, observation, interview, unpublished thesis, annual report. PYQ, most important. Not the source of secondary data. Option C is the correct answer. Questionnaire, observation, interviews and primary data sources. Unpublished thesis, annual report are primary sources. A researcher is interested in studying the prospects of a particular political party in an urban area. What should he prefer for the study? Rating, interview, questionnaire and schedule. See, questionnaire it is. Political party in an urban area. Questionnaire. Here any other given? Survey not given. Okay, questionnaire. Primary data for a research process be collected through. Option D is the correct answer, both A and B. Observation and surveys. Primary data for a research process be collected through observation and collected through survey. Which method of data collection? Which method of data collection is employed in census of India? Personal interview, telephone interview and mail questionnaire and none of these. Option A, personal interview will be taken up to employ the census. Now, with this research part is already covered in the research aptitude. So with this, I am putting an end to statistics. Finally, I kept my promise that I will complete the statistics before the exam. So thank you so much for attending.